Do you know that even minor errors in software development can lead to costly consequences? Thank God that we have a safety net, that is, software testing. So get ready to become a master of software testing. Dive into our ultimate guide. From catching bugs before they hatch to ensuring flawless performance, get ready to evaluate your skills and make your software bulletproof. Let's embark on this testing adventure together. Welcome to our comprehensive software testing tutorial. We will start with the basics of software testing, which is the process of evaluating a software application to ensure it works as expected. It involves checking for bugs, errors, and any issues that could affect the software's functionality, performance, or user experience. We will also explore the difference between manual testing and automation testing and when to use each of the best results. Next, we will dive into unit and integration testing to ensure you check individual components and how they work together smoothly. A small fact to keep you all excited about these two testing techniques is that combining them in the software development process not only helps catch individual bugs early, but also ensures that all software components work together seamlessly. We will also uncover the magic of API testing, teaching you how to ensure your apps communicate well and manage data requests. Automated API tests can run faster, providing quicker feedback to developers and speeding up the development cycle. To top it off, we will introduce you to cucumber testing and behavior-driven development. Did you know that Cucumber enables you to write test scenarios in plain English using the Gherkin language, making it accessible for non-technical stakeholders to understand and contribute to the testing process? Let's now begin our journey to have a comprehensive understanding of various testing methods and apply them with precision. This video isn't just about learning, it's about transforming how you approach testing.
Software testing is like an investigation, or we can say it is a method which tells that whether your software is fulfilling your client requirements or not. So basically, what is software testing and why do we need it? What are the different parts which comes into the process of testing? That's what we are going to talk about in this particular course. So in this particular course, we are going to start with our SDLC process. We are going to understand how this SDLC works, and then we are going to slowly jump into the basic concepts of software testing. So let's not waste time and let's jump into the agenda topic and let's see what are the different things we are going to discuss in this particular course.
Testing, and we don't talk about SDLC, which is the software development lifecycle, then obviously you won't be able to know that what happens when you go inside a company or when you take up a project. Okay, you guys are here, maybe some are freshers, maybe some are experienced. You must be knowing that when you go inside a company, if a project is coming up in your hand, you have some procedure which you have to follow. You just not start writing the code when you get a project, right? That is not the thing. So what is the process? What actually happens? Those are all things we are going to talk about in this first topic. Next, we are going to talk about what is testing, where in SDLC testing comes in, what is testing, why do we require that, right? Why do we need it? That we are going to see in the third topic. The first topic is SDLC. SDLC means software development lifecycle. Okay, so let me write it here. What is the meaning of it? Software development lifecycle. Okay, what is software? Software is nothing but you create. If you are a developer, what do? You create a software, right? Correct. Development is what? You are developing that software. Lifecycle is something to develop that software. What all phases you have to go through? Okay, what all sequence you have to go through? Let's take an example. When somebody is creating a road, okay, when somebody is creating a road or a highway, what all things they require? Obviously, the first thing is raw materials, like maybe the charcoal or the colors, the paint colors, or whatever iron rods are there, right? all those things we need, correct? Those are our raw material requirement. We need those things before we design our road. The next is planning. We need to plan that how much long distance the road is, or how much kilometer it will be. We need to plan it accordingly. Accordingly, we will also require the raw materials, right? So that is planning. The next is designing. That means how the road should look, whether it will be a one way or a two way, or how many dividers will be there. Those all things are nothing but your designing. The next is construction. Because we have already planned now, we already now know what all things we need. So now we are going to construct it. So construction is done. After you have constructed it, you have to test it, right? Why do we have to test it? Let's understand. Suppose you have created one web page. Let's say Amazon. You have created one web page which is Amazon. Okay. Now, before making it public, or before public will use this website, you need to check on your own, right? Whether this web page is user friendly or not, whether this page is usable or not, whether it is giving me some error or not. You have to first understand in your own way, right? You have to see it on your own. And then when you will finalize that, okay, everything is fine, now I can make it public, correct? So we do a test, correct? One more example, when you write a test, when you give exams in your college, when you're finished with your paper, you see everything, that every question you have attempted or not, right? What are you doing? You're testing it. You're testing whether all the questions I've attempted and I've written correct answers to it or not, correct? That is your testing. So while making a road, after the construction, we have to test whether all the corners of the road are perfectly done or not, correct? Next is maintenance. Now, after this, people can use this road. People can use the highway for general purposes. But we have to do the maintenance. After every 2 years, we have to check whether the road doesn't have any, uh, potholes or something, right? The road is not blocked or damaged, right? So we have to do maintenance every 2 years for that road, and it happens, right? These all things happens, correct? Same thing goes with any software. Whenever you're creating a software, or whenever you're developing a software or any such websites, you have to do these all things. You have to you require the raw materials, you need the planning, you need the designing, construction, testing, maintenance. Now, this is what is your SDLC, software development lifecycle. Suppose if I'm taking one website, which is Amazon, let's take this one only. Let's say a client is there, okay? A client is telling me that you have to create a website which looks like Amazon, okay? Which looks like Amazon. So let's say my web page name is Great Learning Academy, okay? This is my website name which I have to create, which will look like Amazon, maybe, okay? Now I can't directly start coding for this. I can't directly jump to coding and I can, do the coding. I have to, what all things I have to do? I have to do the raw material requirement. I have to talk to the client. I have to say that I want a laptop. I want the softwares. I want wires. I want Wi-Fi. I want broadband connection. I will ask everything, whatever I require to make that website. Okay. Even the screen, even the mouse, even the keyboard, everything. Next is planning. Planning means you will plan how you will go with it. So first you will make the front end. Then you will go with the back end. Then you will go with the database. Like that, you need to plan. You will plan accordingly, right? Obviously, you are not alone in that team, right? You have a team of 5 members who are working with you, correct? So that is the planning. What is designing? Designing is designing the flowchart of the code, or algorithm, writing the algorithm of the code, writing the pseudocode of the code. These are nothing but the designing. Why do we do designing? Suppose if you're building a building, okay, we have the blueprint, right? Why do we have a blueprint in the bedroom will be? Why is it there? Because we can see that blueprint and then we can create our building, or we can create our home, correct? Same thing happens like that. This is our blueprint. Flowchart, algorithm, pseudocode, these are our blueprint. Using this, we code construction. We will start writing the code. So using the designing, using the blueprint, using the flowchart, algorithm, and pseudocode, we will write our code. We will write our whole code for the project. Once we have written the code for the project, now I have to test it. Why I have to test it? Because I need to see whether I have done some error or not, whether my particular web page is perfect or not, whether it is having some bug. What is bug? Bug is nothing but an error. Okay. Let's say you are having a login page. You have created a login page in which you have username text box and password text box. You are storing correct username and correct password, but when you're clicking on submit button, it is not like letting you log in. It is not opening your profile. So that's a bug. That's an error. Those things we are going to test here. We do the testing there, okay? Because we don't want that public should be having these all errors. Public should not face these errors, right? So before making it public, we do the testing. Now after testing, when I'm pretty much sure that my web page is working, I make it public. Now people are using it. People have used it for 1 year, 2 years, and every time we have to update and every time we have to do the maintenance. Why? Because thousand, lakhs, and billion number of people will use your website, right? When those many number of people will use the website, obviously your website is not capable of storing large number of data. So you have to keep on updating your, or you have to keep on maintaining your project. You have to keep on maintaining your project. You have to check what all errors are coming, what you have to update. That is why you must have seen in all the applications in a mobile, right? In a mobile, every month some updation will come and you have to update it from Play Store, right? Because every now and then some other public, some other people are facing some difficulty and they're pointing it out. So the developers are trying to make it correct, trying to update it, trying to maintain it. This is what is your SDLC, and this life cycle goes on because maintain Amazon, Myntra, these all top websites, maintenance doesn't ever stop. It always goes on, right? Because number of people using that website is increasing, number of problems are also increasing. Okay, now let me make you understand what is testing and let's understand what is happening in this particular topic. See, testing can be defined as performing verification and validation of the software product. That's what I told you in the previous particular topic. So when you're working with your software product, right? When you have created your software product, after that you have to test it, right? What all things you will test here? You will test two things, verification and validation. Verification means you are verifying whether all the stuffs in your particular product or in your particular project or in your particular software product, everything is working fine or not. Is there any bug issue? Is there any error? Those things. Validation means the things which is working right, you try it with trial and error method. You try to do multiple logins with check if you're doing 1,000 logins, whether it is impact or not. That is validation. You're validating that your particular software product can support multiple users or billion or million users. Okay, these two things are very much important when you're doing and second is validation. Okay, for its correctness and accuracy of working. Software testing is to identify errors in order to reveal and spot it. Okay, now there are two types of testing. One is hardware testing and one is software testing. Software testing means that already you have some tools, okay, some software tools to test your product. To test your product. Okay, so we already have some software use to test our product. What you have to do? So in that software, there will be a button in which you have to put your product. You put all the files of your product. Okay, and then just press one button. That particular software will automatically let you know that what all errors and what all bugs are there in this particular product. That is called as software testing, also called as manual testing. So in manual testing, what happens? The human being or the developer or the tester actually tests it by his own, which is also nothing but trial and error method. So suppose if you're opening Great Learning Academy page, okay, you open it, you do some 1,000 logins on your own, you sit and do it. When you're sitting and do it manually, that is what is manual testing. Okay, so software testing is something which you do it using the software tools which is already available. Manual testing is something which the tester is doing by sitting and doing and checking the errors by his own, okay, by looking at the product. So these are the two testing which we have in software testing. Now there is one thing which I need to tell you, which is what is the difference between a developer and a tester. Okay, so if you go to an MNC or if you go to a company, if you're a beginner or a fresher and you are in your engineering field and you're looking out for job opportunities, you are going for an MNC, they'll give you two opportunities. One will be the developer, one will be the tester. Now everybody says that go for developer. Obviously, because there's a lot of money, there's a lot of knowledge gain. Many things are there in this field, developer field. But there are some amount of people who also are willing to go to tester field. What is the reason? Okay, the reason here is the knowledge which you will gain in testing field is not the same knowledge which you are gaining in developer. Now understand, if you're a developer, you have to do the testing work also. Okay, so if you're a developer, you have to do the testing work. Sometimes the the current organization in which you're working on, the manager will tell you to please test your product. So you are doing the testing work also. You have to use some softwares and tools to test your particular product. So a developer is a tester also. He has to test his particular product also. But a tester will never do the developer work. A tester will never do the developer work. Tester work is to just test whatever developer has developed. So tester will just test whatever product has been given by the developer. Tester will test it. If the error is there, all the errors will be listed, it will be documented, and that particular list will be sent to developer again. The developer has to again work on it and he has to again resend it to the tester. The tester will again check some errors and again send it back. The process goes on. It's really more important to understand why do we need testing, right? So the very correct, very normal reasons of why do we need testing is to save time as well as cost. So obviously, if you are testing manually or automatic, if you're doing it using software or you are using tools or technologies, obviously it will save time, okay, and it will save cost. How it will save cost? Let me tell you. Suppose a small organization is there, okay, let's say a startup. What these startup companies do, they hire developers, okay, they don't hire any testers, they don't, and the developers will only test them. So the cost is minimal now here because startup companies are not hiring testers. How much they are paying the developers? With by the developers only they are doing the testing. Okay. When you talk about MNCs, when you talk about bigger companies like Amazon or Accenture, Infosys, right? In these, what happens? In MNCs, they hire developers and testers, both. Developer will do the development part and tester will do the testing part. Okay. Now, how many developers you need? Suppose the company has hired 12 developers. The amount of testers will be less. Okay, because what tester has to do? Tester has to just test that particular whatever development developer has done, whatever product he has designed. So understand that for 12 developers how much paying is there, and for 6 testers how much paying will be there. So it saves time and as well as cost for the company to provide best quality product without taking so much time and money. So money is not getting wasted, time is not getting wasted when you have testers and you're providing the best quality product. How come we are getting the best quality product? Because we have testers. Testers are doing our work. Testers are testing it now and then, again and again, so that the final result will be a best quality product. To find defects or bugs or errors which may get created by the programmer. Programmer is nothing but the developer only while developing the software. To gain confidence in and providing information about the level of the quality. Suppose you have designed a product, okay? Now what is the quality of this product? This product quality can't be described by the developer because developer has designed this particular product. The developer has designed this product. He will say that this product is very good because I have designed it. But if you will give it to some other person or some other public people, okay, some other random people, then when he will use this product, he will tell you the real feedback. He'll give the real feedback that what he has observed when he has used this product. That is why company hires testers. Testers will test this particular product which they have never seen, and they will give a real feedback when they will work with this particular software. So the point is to gain confidence in and providing information about the level of quality. Next is to prevent defects. That is very normal pointer. To make sure that the end result meet the business and user requirement. Very, very important point here. So when a product comes in, right, the product comes in or the client requirement comes in with a list of items, okay, list of all the things which client wants. If you are not filling the requirement or if you are not filling the need of the client, then obviously your company will not get paid and also your product will not be purchased, right? So business and user requirement, that means whatever the client requirements are there, those all things should be fulfilled. If it is not getting fulfilled, tester will reject that product. Why tester will reject it? Because tester will be matching the requirements which needs to be fulfilled. If it is not matching, if the product is not matching the requirement, if the product is really bad at it or it is not working fine, the tester can reject that particular product. He will say to the developers that you have to create again or you have to fix this problem because the client requirement is that. Okay, so that is why we need testing. These are the pointers, very good pointers you should understand now. So I hope now you get an idea like what is the difference between these things.
Now let's understand the two types of testing. Manual testing and automation testing are two essential methodologies in software testing. Manual testing involves human testers manually executing test cases without the aid of automation tools. It's best suited for exploratory usability and ad hoc testing where human judgment is crucial. On the other hand, automation testing uses scripts and tools to automatically execute tests, making it ideal for repetitive and regression testing. While manual testing is flexible and easy to adapt to changes, automation testing offers speed, accuracy, and cost efficiency for long-term projects. Both methods complement each other, ensuring comprehensive test coverage and high-quality software. Now, let's dwell deep into the details of manual testing. Hello everyone. Welcome to the session on Introduction to Manual Testing. When I say manual testing, it seems that we are doing some testing, right? So for example, you are developing a software or you have already developed a software. Now it is time to test that software. So that is when this testing comes into picture. And again, in testing, we have n number of ways, and two major methods of testing are manual testing and automation testing. So today we will understand more about what manual testing is. So without any further ado, let's jump right into the session. In this session, we will be understanding more about what a software is and different phases that are present in software development lifecycle, and majorly we will understand the testing phase. Then we will understand the basic types of testing methods, and then we will understand what exactly is manual testing all about, and the real-time application example will also be explored. Along with that, we will understand what is the need for doing this manual testing, and then the process overview. What exactly happens in the manual testing process will be taught, and then the different types of manual testing will be learnt, and then the test case structure, which means to do manual testing, we will have to understand something called as test case structure. So that test case structure will be understood in this particular session. Along with that, we will also understand what are the possible practices or the best practices that you have to inculcate in order to use this test case structure. Now we will understand more about manual testing. So as the name suggests, manual testing is nothing but a testing process is done manually by a person. So manual testing is a process in which a tester manually operates a software application to detect any defects or bugs without the assistance of the automated testing tools. He is not using any automated testing tools. He is actually present there manually, and he will operate or check the software application to detect if there is any errors or issues present in that particular software. It actually involves the tester playing the role of an end user and using most of the application's features to ensure the correct behavior. So the tester here will act as an end user, and he will check all the features that is present in that particular software or an application. Manual testing is very critical for ensuring that the software is user friendly and for discovering usability issues that automated tests might overlook. So these are few intentions of manual testing. It allows for more exploratory testing where the testers experience, intuition and understanding of the application guide the testing process rather than predefined test scripts. So here nothing is predefined or automated, no scripts are present, nothing. It's just that a person manually will test the software based on the experience. He will give the feedback. Based on the intuition, he will understand the software, and based on the understanding the application guide, the testing process will happen. Now we will see what is the need for doing this manual testing. So first one is human insight. There are few scenarios where the human insight is very important to check whether the software is working properly or not. So manual testing is performed by human testers who actually can observe and then judge, and he will evaluate the software in ways that automated tests cannot do. So that is one criteria to do this manual testing. Second one is exploratory testing. So as the name suggests, exploratory is nothing but you're discovering something, you're learning something, right? You're exploring something. So exploratory testing is about discovery, learning and investigation. It is an approach where the testers explore the application without any predefined test cases or scripts. The next one is complex user scenarios. Manual testing allows testers to simulate the user behavior more closely and provide feedback on the actual user experience. So the complex user scenarios also will be resolved here in this particular testing. First time setup. So when a feature is developed and needs to be tested for the first time, manual testing can be used to perform initial checks before investing time and effort in automation. So that initial stage of where the testing can be done, there you can use the manual testing rather than using few test cases or the scripts or automated test methods, right? So these are few criterias where the manual testing actually comes into picture. The next one is cost effectiveness for small projects. Manual testing can be more efficient in these scenarios, especially when the frequency of code changes requires constant updates to test cases. So there might be few scenarios where you will be adding few code lines or few things to your software. So that has to be tested at the initial stage. So that can be done without any cost invested by manual testing method only. The next one is non-functional aspects. Manual testing is also essential for testing non-functional aspects such as aesthetics, usability, and accessibility. Adaptability. Human testers can quickly adapt to new findings during a testing session and alter their approach based on real-time insights. So here human testers will have the knowledge of how easily he can actually adapt to the changes in the real world or the real time. So manual testers can easily do the testing because of that basic knowledge. Next is visual verification. Humans can actually be very visual in nature. So he will actually see something in real and then he will judge. So certain aspects such as the layouts or the font size or color and other visual elements of the UI need a human eye to verify that they look and feel correctly. So which means the visual feedback is more prioritized than the automated ones. So these are few necessary points or need for doing the manual testing. Now we'll take a real-time example and check how this manual testing is done. So imagine that we are actually testing a new email service very similar to Gmail or email, okay? Now our main job or intention is to do manual testing and the functionality of the composition and sending a mail. Now you have, when you develop an application very similar to Gmail, this is how you get, right? You will have to give the to address or subject, or there will be a space where you can compose your email. So before that, the very first step that you do is test preparation. What happens in this test preparation? The user will have to access the email application. He has to have that access credentials with him. Now create 2 email accounts for testing. So one account will be from the sender side, another account will be for the receiver end. So we will call it as test account 1 and test account 2. The second step is test execution. Now in this test execution phase, there are n number of tests to be done. One is the login test, the second one is compose email test, and then email sending or the functionality test will be done, and then reply to email test will also be checked, and error handling test will also be done, and then UI or UX test will be done. Now we will see what these are. Okay, the very first one is the login test. Now to log in into your test account 1, you have to give your credentials. So you will give your credentials and you will log into your account 1. And now verify that the login works with the correct credentials. Of course, when you give correct credentials, it will work and you will log in. Now attempt to log in with correct credentials and verify the error message. If your credentials is correct, you will be login. If it is wrong, of course, you will get an error message. This is your login step now. Second step is to compose email test, which means now you have logged in into your account. That is the test account 1 account. There now you will compose your mail. So you will have a compose button. There you will click on the compose button and you will start composing your new email. Then after writing your mail, what do? You will verify that the compose window actually opens. When you click on that button, it will open, right? And then you will type your recipient address, that is to address. There in that to address, you will be typing the address of the test account 2. You should actually give that account's email ID. That to address should be proper. Then you'll actually add the subject to your mail. Maybe whatever the subject you want to give it as, you will give it there. And then you will add the content in your space that is given to compose your data or the mail. Then you will add a small attachment if required. So there will be an attachment symbol at the bottom here. Okay, and then if you want to attach a file, you can do that attachment also. And after doing everything, you will click on send, right? So you will send the email. Now verify that you get a notification that the email was sent. Once you do that click, of course you will get a notification on your screen if it is said that you have sent the email now. So this is your compose email test phase. Next is nothing but you have to check whether the email sending functionality is working or not. Now, which means you have sent, but now we have to check whether that mail has received to that particular receiver or not, right? So now log into that second account. So log into your test account too to check if the email has been received or not. Then verify that the email appears in the inbox only. Then check that the subject of the body are same as what you sent from the test account 1 account. Then ensure that the attached file is same as the one you sent and can be downloaded or opened. You should be able to download that file that was sent. Next is the reply to email test. So once you know that the inbox has the mail that was sent by the sender, next is that you should test whether that you can reply to the receiver or not from this account, that is test account 2. Now reply to the email from the test account 2 only. Verify that the reply function populates and the to field with test accounts 1 address. In the to address, you will put the test accounts 1 address there, and then you will send the reply. Or once you send the email, you will log back into your test account 1 to ensure that the reply has been received or not. So now we'll go back to our test account 1 account and we will check whether we have received or not. So after doing all that, we also have to concentrate whether there is some error happening or not. So now try to send an email without the recipient and check what happens. Definitely you will end up with an error. It will show that you have to give an recipient address to send the email. You may also encounter one more error where it will actually give you error when you try to send an email with an invalid email ID. Say suppose you give a wrong email ID, it will again give an pop-up notification that this is an error because it is not an appropriate sender. So like this, you can also do some error checking or error handling tests to verify whether error is also being handled in the software application or not. Or sometimes there will be a circumstance where even if you give a wrong ID, if you don't get a notification and it goes off, you will not know that it is an error, right? So that also should be handled. So that is an intention of including this error handling test. Then is your UI UX test. So here verifying that all the buttons are positioned correctly or not, and then ensuring that the typing is done in the compose window only and is responsive and there are no unexpected lags. When you are typing, whatever you are typing has to reciprocate on your compose window. Then the test the readability of the font and that all the icons are intuitive and functional. All the icons that may be attached or the font size if you want to increase, there will be a tab where you can do all the font variations. You have to check whether all features are working or not. And then check the responsive of the application on different screen sizes. So all this user interface test is also done. Now, after doing all this test execution, there is one more phase where you do actually the test reporting. Here, the document is nothing but the outcome of each test. So, you will maintain a document and you will report it. So, what happened in the login test phase, what happened in the test phase, execution phase, and all of the other phases that we understood will be documented now. If a defect is found or if an error is found, then we have to report it. So report it with the steps to reproduce the expected result, the actual result, and any relevant screenshots can also be added in your report. The last step is the follow-up. So if bugs or errors are reported, retest those functionalities after they have been fixed. Once the errors have been removed or bugs are removed, you also have to retest it to check whether they are still giving errors or is it resolved. So that is nothing but the follow-up. So these are the stages where, or the tests where the manual testers will do in order to check a software. Now, the manual testing is a process. So the very first step is planning. So test plan. So now the testers will have a plan ready in order to test the software. So testers will prepare the test plan which outlines the testing strategies. So what are the strategies that are used in order to test the software, or objectives that are involved, and they will also give some estimated deliverables and resources that are required for testing. So all those criteria will be planned by the tester even before to start the test of the software. The next one is the design phase. As we already know, these are the phases that are involved in the overall software development life cycle. The testing phase will also have a number of cycles or the steps present in it. So the second phase is the design phase. So as the name suggests, a design is made in order to test the software. So testers actually develop something called as test cases and test scenarios that cover all aspects of the software functionality. So the test cases are written, or the structure is made or designed in order to check the functionality of the software. So the next phase is execution. As the name only tells, it is executed, right? So the testers actually execute the test cases and check manually by step, following the step-by-step outlined in the test cases and comparing the expected result with the actual result. So as you know, in the design phase, the tester would have written the test case. So using that test case, execution will be done. And based on the output or the outcome, the actual output or the result is compared with the estimated output. So we already know what should our output be, or what is our estimated output. So that output will be compared with the actual output that we got after the execution. So the execution phase is all about comparing the actual result with your expected result. The next phase is documentation. Once the execution is done, you will document it. What was the output given, or what was the output that was expected, and all of that will be documented. So the results of the test cases, including any bugs that you encountered or issues that was encountered, are also documented. This documentation is then used for the development team to fix the bugs. If there are any issues or errors, that also will be present in the document, so that the testers or the developers can use that in order to remove that errors or the bugs. The next phase is defect logging. So when a tester finds a bug, they report it in a defect tracking system with as much detail as possible, including the steps to reduce the bug or error, screenshots and severity levels. So which means, for example, you have a logbook where you have the details of your login and logout. Similarly, if there is an error, that will be logged in that logbook. So that is called as logging. Your error will be logged and entire detail about that error will be given at that column. And what was the error, that screenshot also will be accompanied with that particular explanation, so that it will be easy for the developers to know what the error is and to remove that error. So this happens in this particular defect logging phase. The next is the regression testing. Regression testing, to be very simple, you have an application. So it keeps on changing. You keep on incorporating few methods or few things into your application. So every time you add, every time that should be tested. So that is called as regression testing. After the defects are fixed, the testers retest the specific functionality to ensure the defects are resolved. As we know, something called as retest will happen. They also perform regression testing to make sure that new changes have not affected the existing functionalities. As I said, when you add new features or new methods into your present or existing application, new changes should not spoil your existing functionality, should not affect anything to your existing functionality. So that is called as regression testing. So that is also maintained, or that is also done in order to check that your manual process is also a vulnerable process. then is your review and closure. So once everything is done, or after doing the entire testing, we have to do something called as review. We will review at the last stage. Once testing is complete and the software is stable, the testers prepare a test summary report, which is reviewed by the team. If the software meets the acceptance criteria, the test phase is closed. Only when it meets, the testing phase will be closed, or else it will wait for the re-corrections or retests to happen in order to close the test. So this is the entire process or the overview of how the manual testing will be done, or the phases that are involved in the manual testing process. Now we will understand two basic testing methods. So one is static testing, the other one is dynamic testing. We will understand what these testing methods are. So first we will understand the static testing method. It is also called as verification. For example, say suppose you are logging into Facebook. So you will give your username and you should give your password. So the verification happens here, whether your entered credentials are valid or not. So whatever you have entered, your name, your Gmail or your name and your password will be verified. This is called as verification. It will be verified, and if it is correct, you will be logged in. If it is wrong, you will get an error of that you have forgotten your password or username or whatever. So this is one example. So the very first step is verification. So now we will understand more about static testing. So static testing involves the examination of the software document and then the configuration without actually executing the code. So we don't know that what is happening in the background. The code will not be known. So only it will be tested at your initial stage. That is the static testing phase. It is also referred to as verification because it's about ensuring that the software is being developed properly or correctly according to the specified requirements and the standards. This form of testing can identify errors early in the development cycle. Next, we will understand what are the activities that are involved in the static testing. The first one is reviews. Formal or informal assessments of the documents by one or more individuals is taken care here. So the reviews will be done. Reviews can be peer reviews where developers look at each other's work, or they can be conducted by a separate team. So reviews will be done quite often. It can be formal review or it can also be an informal review, and then that review can be done by the peers, or there may be a separate team is what review is all about. Then the inspections will be done. There are more formal reviews and usually involve a step-by-step systematic examination by a designed inspector who actually follows a defined process to uncover the defects, which means there will be an inspector to actually inspect the errors. So that it comes under more than formal review. A person will be designated for that particular inspection. So this is inspection. The next one is walkthroughs. So a walkthrough is a form of peer review where the author of the document guides participates through the document according to the predefined process and collects the feedback. So it's just nothing but a person will be there to collect the feedbacks and he will be guiding throughout the process. So document actually guides the participants through the document according to a process. There will be a predefined process already set, and according to that he will be guided. So that is walking through. For example, when you join a new job or a new college, you will be walked through what happens exactly in that process, right? So when your internals will be there, when you have to attend labs, when you have to attend classes. So you'll be walked through. Similarly, in this phase, a person will walk through you about the entire process that is going to happen. The next thing is the desk checking. This is a manual inspection of code or algorithm by the developer before it goes into the formal testing. So here the desk checking is nothing but I can call it as the first stage of testing. So your code or your algorithm that you write will be actually done as a blank check, or it will be done as a small checking. So that after that only that will be sent to your formal testing process. So that is called as the desk checking. Next is your audits. So formal type of static testing conducted by an independent body to check whether the project follows all the standards and the policies and the procedures that are required to be followed. This is again a feature where it is important to follow by the audit. So there will be an auditor who will actually check whether the process is followed according to the procedures or the policies. So these are few activities that actually happen in the static testing. So there are few advantages of doing this static testing. So it identifies the defects at the early stage, which actually reduces the cost of fixing them at the later stages. Then it also improves the quality of the software product by encouraging a disciplined approach to code and documentation or further processes. It is a preventative method that actually offers or leads to a cleaner design and better compliance with specifications. So it's a defined process and hence it has a proper design at the initial stage only. Next, we will understand what dynamic testing is. It is validation. It is also called as validation. So once you are giving your credentials, you will be validated whether you have given a correct credential or a wrong credential. Based on that, you will be validated. So this is called as dynamic testing. Now we will understand more about dynamic testing. So dynamic testing, in contrast, involves executing the code and validating the output against the expected behavior. Your code will be actually executed in this particular testing. There it was only without your coding knowledge or without having to include coding, the execution will be done. But here it is completely with respect to coding. So this testing confirms that the software product functions correctly in a dynamic environment and interacts with other components like databases or the network or other systems that are involved in the process. Now we will see the activities that are present in dynamic testing, that is nothing but the unit testing. So testing individual components or pieces of code for the functionality is called as unit testing. As I said, each unit will be tested separately. And then the integration testing. It ensures that the integrated components or the system work together. All the units that are present in the system now, they are collaborated or they are integrated to do this integration testing, whether they collectively work properly or not. Next is the system testing. So the system testing involves verifying whether the entire application meets the specified requirements. For example, we have been developing the Ola application as an example, right? So what is the purpose of that application? It has to help the end user to book his ride from one place to the other, right? So that is your output or outcome that the application should actually be of, right? So that entire process should be tested. So that is called as system testing. So once that application is actually helping to book a ride, then it is giving a proper output or the purpose is met or the requirement is met. So that is called as system testing. So entire system will be tested to ensure that the required or specified intention is met or not. Next is the acceptance testing. Validating the end-to-end business flow. This is usually done by the client to ensure that the system meets the agreed upon requirements, which means here there will be a requirement phase, as we already know, right? So in that phase, few requirements will be agreed upon or it will be specified in that particular stage or phase. Now that has to be included in your entire system so that it will be tested whether all the requirements is present in your system or not. So that validation of end-to-end flow will be checked in this acceptance testing. Next is your performance testing. The name only suggests checking the software behavior under various conditions like load, stress, and scalability scenarios. For example, if you consider that Ola app or the software, the main intention is to book a ride. So irrespective of the location, maybe 50 kilometers or 100 kilometers, whatever the range is, the application should do the same job. it shouldn't change, right? So that performance will also be a criteria to test a software. So the entire behavior will be tested under various conditions. In spite of checking it under various conditions, it should give us the desired output or the specified output. Only then the performance is better, right? So that is done in this particular performance testing phase. Now we will see few advantages that are present in this dynamic testing. So first one is it validates the functionality of the software in the real world scenarios. So your application or the function of your application will be tested or it will be validated in the real world scenario. So it has to actually work properly in the real time examples. And then it ensures that the product actually meets the user requirements and the expectations. It also identifies the issues that may not be detectable throughout the static testing, such as runtime errors and concurrency errors will also be present even after doing the static testing. So this dynamic testing is very important to ensure that these errors are not present in your software after the testing process. Now we will understand what a software is. So a software refers to a collection of data or computer instructions that instruct the computer on how to work. It also is considered as a non-tangible component of a computer system that provides functionality as opposed to hardware, and also which refers to the physical components of a computer system. Suppose, for example, we use softwares in our day-to-day life. Example, you will be working on your system, right? And your computer system will have a software in it. It might be Windows, it might be Mac, these are all called as operating systems. So these are also called as softwares, right? So there are n number of softwares that you use in your daily basis, and without your knowledge, you are using a software. So we all know we are using a software and we don't know whether this software was tested or not, right? But for sure, if you are using an open source software or a built-in software or whatever it is, it will be tested for sure. So we will see what are the different types of software that we know and we use. So one is operating systems that I already told you. So Microsoft Windows is one operating system, Mac OS is the operating system, Linux is another operating system, Android on your phone. Android software is always there on your Android phones, and iOS is also a software which is on your iPhones. So these are all considered as different operating systems. And then we have office suites like Microsoft Office, Word, Excel, PowerPoint. All these come under the office softwares, and LibreOffice and Google Workshop is also a software. And the web browsers that you use in your daily life, that is the Google Chrome, Firefox, Microsoft Edge, all these are all again the softwares that are considered as the web browsers where you can actually browse the information from. And we also have media players, like on your phone, you have this VLC media player, Windows media player, iTunes, Spotify. All these softwares will help you in listening to the music, right? So these applications or softwares are considered as the media players. And we have few graphics and design softwares also, which is used for graphicking or photoshopping your photos, pictures, editing, and all of that stuff. So Adobe Photoshop, Adobe Illustrator, Corel Draw is again a software which is used for editing, graphic designing, and all of that. And Autodesk, AutoCAD, and GIMP is nothing but GNU Image Manipulation Program. So again, this is again used to edit your pictures and adding graphics into it and all of that. So these softwares come under graphics and design. So there are few antivirus and security softwares also, like for example, McAfee, Norton Antivirus, Avast Antivirus, Windows Defender, and Bitdefender. So all these softwares are used as an antivirus in your system to protect your softwares. So next we will understand the testing phase that is involved in the software development lifecycle. So when I say software development lifecycle, software will be developed from scratch, right? Any software, for example, you take your Gmail, for example, it will be a software Even before developing, I'm talking about. So it is a software. Or consider this example where you are developing an application or a software for yourself. You actually start the development of the software from scratch. So you will do your small research, you will do some design, you will then do some planning, then implement, and then write code, and you will test it, and then you will develop it. So there is some process that is followed in the development of the software. So in that process, or in that software development life cycle, there is an important phase, or there is an important step, you can call it as, and that is called as testing. So that is what we are studying, right? Manual testing is a part of testing, but we have to understand what and why this testing came into picture first. So this is where I can elaborate in making you understand about what happens in the software development lifecycle and where this testing comes into picture. So very first step is requirement analysis. So what happens in this phase? In this phase, the project goals are determined, and then the feasible study is conducted, and the requirements of the software are gathered through consultations with stakeholders, including customers, end users, and project sponsors. So for example, in order to develop a software, there will be n number of people involved in that particular process. It may be stakeholder, or it may be end users like us who may use the product, and there will be people who will actually sponsor some amount in order to develop a software. So they'll also be a part of this process. So considering the requirements from all of them, the requirement analysis will be done. And once the requirement analysis is done, all the requirements will be jotted out in one place, and the required features or the required softwares or required platforms will be collected and placed together in order to carry out the further process. So requirement analysis, as the name suggests, is nothing but analysis will be done of what all is required in order to develop the software. So the next phase is nothing but the planning phase. So what happens in planning phase? After collecting all the required criterias or the documents or the softwares or whatever, the next step that a developer will do is planning. So this involves defining the project scope, resources, timelines, and cost estimations. It also includes planning the overall project management approach and identifying the project risks. What happens in planning phase is that, for example, so you are using a Ola application, for example, in order to travel from one place to another place. So you will be the end user. But to develop that software, the requirements will be collected. So what are all the requirements now? For example, application related to your payment, for example, Google Pay or Phone Pay will be added into your requirements. And then location. So where exactly you're there, or where exactly the the Ola person should come from, the driver should come from. So to detect all of that, you require something called as location platform, right? Or the criteria. So these are all requirements now. So to develop that particular application, now planning will be done. So planning will be done based on the end user or the driver, or what are the requirements now. The phone should be there, internet should be there, and few back-end programming also will be done. So all that will also be included in this planning phase. So something will be planned in a way that using the requirements, your entire process will be planned now. So deadlines or the timelines to complete that particular software also will be decided in that particular planning phase only. And the amount that is required in order to develop the software will also be estimated in this particular phase. So once planning is done, the next phase is the design phase. So now we as an end user, we can see an application of Ola, right? So we know how it looks on our mobile phone or on our screen, but there is some design involved in it, right? So at the back end, there is a code running, and at the front end, we have the PHP, right? So we have that buttons, we have places to click, we have places to type. So all this comes under the web application or the PHP coding and all that. So to do this design phase, the software architecture will be created here in this phase, and then this involves defining the overall system architecture, how exactly the software should look after the development is done. So how it actually appears at the end, that architecture will be built here. So, and they also will create detailed design specification for the features and the components of that software. For example, we have to give location, we have to give the destination, from where to where, right? So from where you're starting your journey and where you want to reach your destination, and you'll have a number of check boxes or the click boxes or the buttons in your application. So all that features or the planning of that features and the design of that features, where what should come, will be done in this design phase. Then once the design is done, we have to actually set up the test environment. So this phase typically refers to the preparation of the environments necessary to support the development, testing, deployment, and maintenance of the software being created. So we all know, we understood that an environment for testing also is crucial in order to do the testing now. And then the execution happens, which means implementation, or it is also called as execution. The actual source code is written in this phase. The software design is translated into the machine readable form, and developers work to build the software on the design document. So exactly the coding and all will be implemented and it will be executed in this particular phase. And then the final phase is nothing but the testing here. So now we have to understand what testing is. Once the software is developed and all of that, it is now time to test it. So the software is tested now to ensure that it is bug-free and meets the quality standards as expected. This also includes a range of testing methods such as unit testing, integration testing, system testing, and acceptance testing. So once the software is developed, it has to be tested, and that testing will not just be a one-time testing, or it's not just 1 minute testing. There will be n number of testing methods that can be followed. For example, unit testing, it's nothing but in one particular application, you'll have n number of small parts or small applications integrated in one application. So each unit will be considered as a different phase or a unit, and that can also be tested separately. So that is called as unit testing. Like this, there are n number of tests that will undergo in one particular application. So this is all about the testing phase now. Next, we will understand the different types of manual testing. There are three main types of manual testing. One is white box testing, black box testing, and gray box testing. We will understand more about these particular testing methods. The very first method is your white box testing. White box testing is also known as clear box or glass box testing. White box testing involves looking inside the box or system, which means that the source code is exposed to create and to execute the test cases. The testers need a deep understanding of the internal working of the application, including its code structure, its logic, and its design. So everything is very important, or it is seen to the tester. So that is why it is called as white box testing. It is clear, very crystal clear, like a glass. The tester can see all the information, or he should have the knowledge of all the information. That is why it is called as white box testing. The second one is your black box testing. As the name suggests, black box is nothing but it focuses only on the external or the end user experience of the software. It is not involved, or it has no interest in the coding aspect at all. So the testers do not need to have any knowledge of the internal code structure. Instead, they test the software's functionality by inputting data and examining the output. That is it. They give some input and they will check the output. This type of testing can be applied to virtually any level of the software testing. For example, it may be unit testing, integration testing, system testing, and acceptance also at times. So these are few testing methods that actually use black box testing. So the third testing method is nothing but the gray box testing. So gray box testing is an hybrid approach that actually combines the elements of both black box testing and white box testing. Testers have practical knowledge of the internal structures also, which they use to design the test cases. Gray box testing is particularly useful in areas such as integration testing, security testing, and penetration testing. So these are the areas where the gray box testing is actually used. So this is a combination of both black box and white box. The testers will have a little knowledge of the internal structure, the code and all of that in order to prepare the test cases. They actually prepare the test cases and keep it ready so that they will check the software according to the test case that they have written. So these are the three main types of manual testing that we actually have to understand in order to understand everything about manual testing. So we will see and understand more about each of these testing. So having to start with, we have to understand what white box testing is now. So white box testing, as we already understood the definition, it is all about the clear or open or transparent box testing. It is a methodology in software testing where the tester has full visibility of the internal workings of the software, including the code, the infrastructure, the algorithms, the flow charts and everything. So he has knowledge of everything that is actually happening in the internal structure. In the white box testing, the tester writes the test cases that check the application from the inside out, which means having the knowledge of the code, he will write the test cases and he will make sure that the application is checked from the inside out. From scratch to the end, it will be checked. They require knowledge of the code and thus they are typically conducted by the developers who are familiar with the code base. So here the testers will actually have the background of the developers. So the tester should have the knowledge of the coding. Any language for that matter, he will have the knowledge in order to do the testing here. If I have to give the overview of white box testing, these are few criteria where the white box testing comes into picture. The code coverage. So testers ensure that the testing includes all the parts of the code, often aiming for a high level of code coverage, which means the high level language should be entirely understood by the tester here. The unit testing. White box is often used at the unit testing level where individual units or the components of the software are tested. It is very self-explanatory. Unit testing is a part of testing and here in this unit testing, this white box testing comes into picture. Optimization. White box testing can identify unnecessary code paths and optimize the performance and efficiency of the code. They can increase the efficiency here. The security and integration testing, it also helps in identifying vulnerabilities in the code and also to test the integrations between the components of the software. So the security and the integration testing both comes into picture. They are collaborated and they collectively use this white box testing method. There are few tests that are involved in the white box testing. We'll see what they are. The very first one is the path testing. So as the name suggests, it is something to do with the path, right? So path testing is a method that is used to ensure every possible routes through a given part of the code is executed at least once. So your entire code, it is executed at least once. So this type of testing is very thorough as it looks at all the possible paths, including loop paths and conditional paths in the code to identify any potential errors. So you can have loops like you can have while loop or for loop. It can go up to 100 times, but still this particular testing will test each part of it. In path testing, flowcharts are created to illustrate that the execution paths through the code and each independent path is systematically tested. So for example, you have a program here, say suppose you write a main and you have n number of functionalities like A function, B, C, D, E, F and G. So every path is executed here, nothing is missed out. So if A is tested first and then from A to C and A to D also will be tested. From main, if this is tested, function B, from function B, G also is tested. Like this, each of the function will be covered. It will be executed at least once. So every path is met or every path is executed. So this is the path testing method. Next one is loop testing. So loop is nothing but if you write a loop, for example, a while loop, and if you give a condition of doing something for 10,000 times or 50,000 times, then here the loop will also be tested for 50,000 times. So this is a disadvantage I can tell. But still, the loop testing is a specific type of path testing that focuses exclusively on the validity of the loop constructs. It is used to test loops for their correctness and to ensure that the loop works as expected. This includes testing for loops that are not executed a fixed number of times, and executed more or less indefinitely. Here, the loop will be, if at all it has to be tested for n number of times, it will be tested. So the loops will be executed and it will be tested based on what the expected output should be. The goal of loop testing is to uncover potential defects within the loop constructs, including infinite loops where the loop never terminates. For example, if there are infinite loops, that also should be tested. So this is a kind of disadvantage that has to be overcome in manual testing. So we'll see what and how it is done. There are few generic steps that are followed in white box testing. So very first step is design and prioritize the test scenarios and cases. So begin by crafting or comprehensive test scenarios and cases that actually encompass all functionalities of the software. Here exactly whatever the design phase should have will be mentioned here. Then the prioritization of these test cases should be done, and it is based on their criticality, with high priority numbers assigned to those that actually address the most crucial and impactful parts of the application. So here, not only the design is important, prioritizing of which test case or scenario to be executed will also be decided. So this is our first step. The second step is analyze the runtime code and resource utilization. So conduct a detailed analysis of code during the execution to monitor whether the resource is used, and that resource may sometime be the memory and the CPU. And then identify the sections of the code that actually remain unassessed and evaluate the time efficiency of various methods and operations, which means there are few parts of the code or sections of the code which are actually not touched at all or not executed also. That has to be accessed, as we understood that in white box testing, no code will be left alone. It will be executed at least once. So that also should be assessed, right? So that undergoes in this particular step. Step 3 is test internal subroutines. Perform in-depth testing of internal subroutines, which actually include the private methods and interfaces. Verify that these components can actually handle all expected types of data correctly and robustly, ensuring that their reliability and performance is maintained. So this is nothing but the internal subroutines should be maintained properly. So that is taken care in this particular step. The next step is evaluate the control structures. Control structures is nothing but the switch or for or if and all of that, right? So that focus on rigorously testing control statements such as loops and conditional statements should be checked. Assess the effectiveness and precision of these structures across a range of data inputs, ensuring they operate efficiently and correctly. The next step is conduct security testing. So after everything, you should also focus on the security testing, right? In the final phase, undertake the security testing to scrutinize the code for potential vulnerabilities. So security is also very important. Examine how the code actually manages the security aspects to uncover any weaknesses that could be exploit, thus ensuring the software's resilience against the attackers. So which means there may be attackers who actually hack your code or copy your code or whatever it is. Security is also a criteria to be considered. So that is done in this particular step. There are few advantages with respect to white box testing. We will see what those are. Very first one is the error identification. So identification of hidden errors that are not visible through black box or functional testing is done here. Next one is the code and structures. Thoroughness in testing the code parts and structures within the application is maintained in white box testing. Improved design, which actually helps in optimizing the code and improving the design and usability. So design can actually be improved in this white box testing. There are few disadvantages of white box testing, that is nothing but the time consuming. So it is a lot of efforts to be put in. It can be time consuming and expensive due to the detailed knowledge of the code required. So the developer would have developed a code. So that has to be understood by this tester, right? Because each person think differently. So your tester should actually understand what the developer has developed, and he should understand the entire code and then start doing his test cases and then start with the testing process. So that is a bit time consuming. So that is one disadvantage. And then improve analysis. It may not detect missing functional requirements because it focuses on the software's current implementation. So it might go wrong sometimes. So because the current implementation will be focused on and something gets off the beat, so it gets slipped off. So that is also again a disadvantage. So next we will see what are the techniques that are actually used in this white box testing. The very first testing is the data flow testing. This testing actually ensures that the data flows correctly throughout the code and that no incorrect or unintended data is being passed through the application's variables. Second one is control flow testing. It actually analyzes the execution paths within the application using the control flow graphs. So as the name suggests, there will be some control over the flow. It also verifies that all the paths can be traversed and that each function operates as expected. The next one is branch testing. So specifically targets every possible branch on control structures such as decision points like if else statements or else statements and so on, to ensure that all branches are reachable and work as intended. So branch testing is something to do with the branch that we write in the code. The next one is statement testing. It is used to achieve a basic level of code coverage and to ensure that there are no obvious errors in the code. Next one is the decision testing. It examines the decision points in the code such as logical condition and loops to ensure that all possible outcomes of decisions have been executed. So these are few techniques that are involved in the white box testing. Next, we will understand what black box testing is. Black box testing is a software testing approach where the internal structure, design and the implementation of the item being tested are not known to the tester. We already understood the definition. So the tester here will have no knowledge about the code or the internal structure of the software. The next one is the tester focuses on the execution of functions and examination of the output responses without knowing how the software internally work. This method is applicable to higher levels of testing like system, acceptance and sometimes integration testing as well. So these are the testing phases where this black box testing is actually used. Now we will see the overview of the black box testing. The very first one is the functionality focused. It is concerned with what the system does and not how it is done, which means you are not involving yourself in understanding what is written or how it is done. You are just understanding of what the output is. So that is the functionality focused. You are just focusing on the function, not about how the function is actually getting executed. Next one is applicability. It can be applied to all levels of software testing methods like unit testing, integration testing, system testing and acceptance testing, as we already understood. The next one is test coverage. Testers often use techniques such as equivalence, partitioning, decision table testing and state transition testing to ensure a wide coverage of the software's functionality. So a wide range of software functionality is actually tested here in this particular black box testing. User's perspective. So testers are designed from the user end's perspective to ensure that all intended functions work as expected and that user requirements are met. So here the testing is actually done keeping in mind of what the user actually wants. So his perspective, the user's perspective will be equivalent to the tester's perspective. So based on user, he will be actually testing the software without any knowledge of the tester. He will actually test the software based on what the user wants in that particular software. The next one is the tests that are involved in black box testing. The very first testing is the functional testing. Functional testing is the most common type of testing that we actually understood in our black box testing. It involves verifying that the software functions are expected and according to the requirements. So based on the requirements only, the software should function. Testers create test cases from what the software is supposed to do, ignoring how it does it. Next is non-functional testing. This tests the non-functional aspects of the system such as usability or performance and reliability rather than specific behaviors or the functions. So other factors like usability, performance, it is not considering all of this at all. Rather, it will be very specific to the behavior or the function. The next one is usability. Focuses on users' ease of using the application. Here, how the software is helpful to the user is very important. So it should be very flexible or easy to use for the user. So all that is handled and it is controlled, and the ability of the system to meet its objective is tested in this particular method. Next is the performance testing. It involves testing the performance and scalability of the system under a particular workload. So based on whatever the scenario or the situation is, the software should perform properly and correctly. So that is checked in this particular testing method. It includes subtypes like load testing, stress testing, and volume testing. You increase anything, but still it should give your proper output. So that is all about the performance testing. Next is your compatibility. So ensures that the software actually operates correctly in different environments, including various browsers or database versions, other software or operating systems, mobile devices or networks, whatever it may be. So it should be very compatible in any scenario or platform. Regression testing, we already know any changes made to the software should not affect the existing one. So after changes are made to a system such as bug fixes or any feature that is added, regression testing ensures that the new changes haven't adversely affected the existing functionality of the system, as we have already discussed. So next we will see what are the generic steps that are involved in the black box testing. Very first step is nothing but the reviewing requirements. So the process actually begins through a very narrow or check of what the requirements actually is, which is very essential as a black box testing is heavily dependent on what the software should do or what it is expected to do. Then the testers actually examine these requirements or the documents, specifications or the user stories and use cases to actually understand the desired behavior of the system. So basically whatever the requirements is collected in the requirements phase will be reviewed. The next step is designing these test scenarios. The test cases will be written and which includes both positive and negative test cases. The positive test cases are those where the system is expected to process the input correctly, while negative test cases are designed to ensure that the system handles the errors or unexpected inputs gracefully. So negative test cases should accept both positive and negative also, which means the errors should be handled in this particular step. Next is developing test cases. So test cases will be written based on what the output should be expected, right? Based on the design test scenarios, detailed test cases are created. Then these test cases may employ various black box testing techniques such as decision table, equivalence partitioning, error guessing, and cause effective graphs, which means the test cases are actually written using these techniques such as decision tables, such as SQL and all. They have concepts of decision tables and they have equal partitions. This also comes in SQL only. So all these techniques are used in order to write the test cases in the black box testing. And then these test cases are randomly used or blindly used in order to check your softwares. So developing test cases is one more step or the stage in your black box testing. The next step is test execution. Once the test cases are ready, of course, your software will be executed using that test cases. So it's very self-explanatory. The testers create the test scenarios that include both positive and negative test cases that we already saw. Positive test cases are those where the system is expected to process the input correctly, while negative test cases are designed to ensure that the system handles errors or unexpected inputs gracefully. It is same. It is same for both white and black box testing. Test execution is nothing but the test cases are executed here. Comparing expected versus actual result is your next step. So what happens here is that you have written a test case and you will execute your software. Now, whatever output you are getting should be compared with the estimated or expected output. So that is done in this particular step. For each test case, the expected result is compared to the actual result obtained during the test execution. Any deviation from the expected result is identified as an error or as an defect. Next step is defect logging and retesting. As I told, it will be logged. When we understood the manual test process, we understood something called as defect logging and retesting phase, right? So your errors will be logged and along with the explanation or the screenshots, and that will be retested. So that happens in this particular step. So if discrepancies or defects are found, then they are reported to development team for rectification, or they will do the retesting process here. Once the developers address these issues, the testers retest the specific cases to ensure that the defects have been resolved and that no new issues have been introduced, which means whatever the issues were there or present, or the errors that occurred, will be sent back to the developers and they work on it and refix it. Once they refix it or solve the issues, it comes back to the tester and they retest it. Once retesting is done, we should have the expected output. It should not again encounter with errors, right? So that is done in your step 6. There are few advantages with this black box testing. We'll see what those are. There is no need for code knowledge. As we already understood, testers do not need to know programming languages or how the software has been implemented, which actually allows even non-technical testers to verify the functionality. Next is the specialization. It allows the specialized testers to focus on specific areas of testing like user interfaces, APIs, or database systems, often resulting in more thorough testing in these areas. So they will be very domain specific. Parallel development and testing. Testing can be done in parallel with development since the focus is on testing the user interface and inputs outputs rather than the code itself. So these are few advantages of black box testing. There are few disadvantages of black box testing as well. One is limited coverage. It is possible to miss certain test cases or scenarios since testers are not looking at the actual code. This means there are some paths through the code that may not be tested at all. So this is very limited coverage, which means the code will be limitedly covered in order to do the testing. Difficulty in identifying certain types of defects, which means defects that are hidden deep within the complex logic of the code are not exposed in this black box testing at all. So these are few disadvantages of black box testing. Next, we will see the techniques that are involved in black box testing. One is equivalence partitioning. It divides the input data of the software into partitions of equivalent data from which the test cases can be derived. The next one is boundary value analysis. Tests the boundaries between partitions. Here, the errors are frequently found at the edges of input value, which ranges. So, testing is focused on the boundary values. Decision table testing, which means useful when dealing with complex business logic that can be represented in a tabular form. Exploratory testing. The tester actively controls the design of the tests as those tests are performed and uses information gained while testing to design new and better tests. So this is nothing but exploring something new. Next is use case testing. Involves creating test cases from use cases or user stories that actually describes the system's interaction with the end user or with another system. Next, we'll understand what gray box testing is. Gray box testing is a software testing method that is actually a combination of black box testing and white box testing methodologies. The gray box testing is actually aiming at testing the application with a limited knowledge of the internal working of an application. Here, in gray box testing, the tester need not have the complete knowledge of coding, but he will have a little knowledge. He will have a limited knowledge to the coding or the internal working of the application. In gray box testing, the tester has access to detailed design documents and the database schemas, but does not have full knowledge of the source code. As we understood, the design documents or the database that is present in the application or the software, all these details are known to the tester, but not the source code or the actual code that is written by the developer. This approach is particularly useful in integration testing and the network security testing. So these are the two main domains where the gray box testing is actually used. We will see few tests that are involved in the gray box testing. So the methods or the types of tests that are used in gray box testing are, one is the matrix testing. So the tester checks whether all the methods and the data of an object are used properly by examining a matrix that shows their interactions, which means the tester will check all the methods or the functionalities of that particular data, and he will make sure he's examining this by a matrix. He will have his own matrix present which actually shows their interactions, means the software developers interactions in it. So this is something related to your gray box testing. It has a limited knowledge with respect to the tester. Regression testing, we already know this. Regression testing is nothing but there is an application, you make some additional changes to it, the existing functionalities should not be affected. So after changes have been made in the code base, testers verify that the modifications haven't affected the existing functionality. So this is the regression testing type. Next one is the pattern testing. This involves examining the code for known patterns that have been previously identified as problematic. So previously it would have been appeared or identified as a problematic code or a problematic part of the code. So that will be examined here. That is called as pattern testing. Next is the security testing. As the name suggests, security is maintained here. So this involves testing the application for security flaws using knowledge of the systems architecture and potential attack vectors. Next is API testing. It is nothing but the application programming interface. Testing the application programming interface endpoints to ensure they actually handle input correctly and they return the appropriate response by taking into the account the known system architecture, which means the known architecture will be next to the tester, and having that as a rough sketch or a document, the API endpoints will be tested. And while testing the API endpoints, they actually ensure that the input is handled correctly. Next one is integration testing. So integration is nothing but integrating or collating different testing methods. So testers look at the interactions between integrated components or systems using their knowledge of the systems architecture. So they already have a knowledge of an architecture or the system architecture. So having that, they will actually compare it or look into whether the interactions between the integrated components or system is carried out correctly or not. So this is about the integration testing. So having understood about the types of tests that are used in gray box testing, now we will understand the advantages that is present in gray box testing. One is comprehensive testing. Gray box testing allows the testers to design the test cases based on both high-level design and low-level technical details, leading to more thorough coverage, which means having half knowledge of the code or the database schema knowledge, the tester here will develop the test cases right from the high-level design to the low-level technical aspects or the details that is present in the software. So this is called as comprehensive testing. So second one is efficient integration testing. So knowledge of systems architecture makes it very easy for the tester to actually design the test cases for integration testing. Next one is better security testing. So here access to architectural documents will help the testers to identify the potential security vulnerabilities that black box testers may overlook, which means sometimes black box testing will only fail when it comes to in identifying the potential security. But then the security testing is actually implemented or maintained in this gray box testing. Next one is non-intrusive, which means since gray box testing does not require access to the source code, it is less intrusive and can be performed without the need for the detailed programming language. It does not require the entire source code. It just needs to have, the tester just needs to have the basics of what is happening in the software. The next one is intelligent test cases. Using that intrusion, he will write the test cases very minimalistic or by using the minimum knowledge or limited knowledge that he has. So with some understanding of the internal structure, testers can create intelligent test scenarios that are more likely to find hidden bugs than the black box testing. So sometimes writing a intelligent test case can detect the internal bugs that are present in the software, which are actually missed out by the black box testing also. And then it reduces the test redundancy, avoids the redundancies of both white box and black box testing by enabling the testers to focus on the most important aspects of both. So there will be no redundancy when the testing is done, when the gray box testing is used. Now we will see a few disadvantages of it. One is tools limitation. There may be very limited in terms when it comes to the availability of the testing tools that can accommodate the mid-level access provided by the gray box testing. Next is communication gap. There could be a communication gap between the testers and the developers, since the testers do not fully engage with the code base. So developers would have written something in their code and that will not be communicated to the testers completely, right? So that gap is always there. And then dependency on documentation. So gray box testing is heavily dependent on the quality and completeness of existing documents. So maintaining the document is very important here. Next, we will understand how to write the test cases. In our previous slides, we were constantly talking something called as test cases when we are actually doing the manual testing, right? So now we will understand how to write the test case. So test case structure is very important to be known in order to do the manual testing. So we'll see the structure of it. So very first step or the criteria here in this structure is the test case ID. So for any test case that you're writing, you should give an ID. Each test case should have a unique identifier. The second step is test description. So whatever test case you're writing, you will add a description about the test case. A brief description of what is being tested will be written in this particular step. Third one is preconditions. Any requirements that must be met before the test can be performed here. It can be mentioned here. So that is preconditions. The next one is test steps. Here the detailed process or the detailed steps for the tester to be followed will be mentioned in this particular step. We'll see what it is, taking an example. Next is your test data. So the specific data to be used in the testing will be mentioned here. Next is the expected result. So the anticipated outcome, if the system functions correctly, will be written here. Actual result. The outcome that is actually observed when the test case is executed is written in your actual test step. Next is your post condition. So after the test is done, what is the state? So that will be written here. So the state in which the application should be after executing the test is your post conditions. Next is the status. This is marked as pass or sometimes fail or sometimes blocked, whatever, etc. after the test execution is done. So the status will be written here. Comments. If there is any additional comments or information or observations that were made, will be written here in this comment section. So these are the 10 steps that are present in any test case structure you write. It should be followed in this manner. Now we will take few examples and check how to write the test case. So the very first example is, we will write a test case for the feature where the user can successfully log in with valid credentials only. Say suppose you are logging in into your Instagram account. So you should give your valid username and valid password in order to actually have the access to your account, right? So we will see what it is, okay? So the very first step that we have to write is the ID, right? So the test case ID, test case TC is nothing but the test case login, okay? So here the login is the activity. So the next is your description. Verify that the user can successfully log in with the valid credentials. As I told, you should give the valid credentials to actually log into your Instagram account. So that will be written in your test description step. So the next one is preconditions. So user is at the login page. So even before logging into your account, for any account for that matter, you will have a login page. There you will get two boxes to type your username and your password, right? So that is called as login page. So that is our precondition. Where are we? We are at that page. So precondition is nothing but user is at that page. So the next step is nothing but your test steps. So here you will enter the valid username in the username field only. So in that username field, you will write your username. Next, you will actually enter the corresponding password in the password field. There you will be giving the correct or valid password in that particular box. Then what you will do, there will be a login button. You will click on the login button. So these are the steps that you have to follow in order to log in, right? So this will be written in the steps where the test has to be made. So it is called as test steps. So the next step is the data. So what is the data? You will be given the username and you will be giving the password. That is the data. So that will be written in the test data step. The next one is the expected result. Now, user will be redirected to the home page or the dashboard or to the Instagram, as we have taken example of Instagram, after clicking the login button. Yes or no? So once you give the valid username and valid password, you will be clicking on login button and you will be directed to your Instagram page. So that is your expected result. Actual result is nothing but to be filled after the test execution. So once the test is made, we will check if we are actually reaching the Instagram login page or not. So that is your actual result. After the test is made, the actual result will be specified in this particular step. Next is your post condition. So user is logged in and can see their dashboard. So that will be your post condition. So after your username and password is valid or validated, you will be directed to your home page. After going to your home page, what is the post condition? After the test, what is the condition? You will be at that page. So that you will be writing in your post condition. The next one is the status. Status is nothing but successful, right? So that will be written here to be filled after the test execution. After the test is made only, you can fill this particular point. Next is your comments. If there are any additional comments that you want to give or observations, you can give. If there was a pop-up in between or any mismatch or whatever when you are actually testing or executing the software, if you find such errors or such points, you can or observations, you can write it in comments. So this is one example. Let us consider one more example and see how it works. So this time we will actually consider an example where a user actually updates their profile information in an application. Say suppose you want to change your DP in your particular Instagram account. Now we will consider that is the scenario. Now what are the test cases that we have to write? We will see. What is the test case structure that we have to write? So very first thing is always the ID. So you will be writing test case update profile. So you will be updating your profile picture, for example. So that will be your test case ID. Next is test description. Verify that a user can update their profile picture. As I said, we have to verify whether the user can update his profile, his or her profile picture or not. Next is your preconditions. So now there are two preconditions. One is user has logged into the application. Yes, you can change the profile picture after logging into your application only. Without logging into your application, you can't change your profile picture of your Instagram, right? So very first precondition is you should be inside your application. You should have been logged in into your account. Next is user is on the profile update page. So on Instagram only, you cannot staying on the dashboard or staying on the page, you can't change your picture. You have to go to that particular profile, right? So user is on the profile update page. He should go to that profile page in order to update his profile picture. So this is the precondition that is required for this particular scenario. So next is your test case or the test steps that you have to write. So first thing, if you have to change your profile picture, you have to click on the current profile picture, or you have to click on the update picture link, right? So you will first click on that. Then you will choose a valid image file from the file picker dialog, or from the phone. If you're changing it from the phone, you will go to your gallery and select a valid image from there. Then you will click on the upload button. There will be a button called upload in order to upload your new profile picture. So you'll click on that upload button to actually upload your new picture. Once you click on the upload, it will come onto your profile page, but until you save, it will not change. It will be as a old picture only. So that save button is very important here. Now you have to click on save changes in order to apply the update of your profile. These are the steps that you have to follow in order to change your profile picture. So this detailed description will be written in the test steps phase. Next is test data. So what is the data? It is the picture, right? So profile picture, new profile picture that is in JPEG form will be your data here. Next is your expected result. Now the picture should be updated successfully. A confirmation message also should pop up or display that your profile picture has been updated successfully. That message also should be displayed. The new profile picture should be visible on your user profile page, right? So that is also important to actually expect as a result. Changing our profile picture is only the expected result. So all that you will be writing in the expected result part. Next is your actual result. So you will be filling this after your test execution is done. Once your test execution is done, you will check whether whatever we are expecting is appearing at our actual result or not. That you will write or fill once the test is made. Then you will write the post conditions. So after the update is made, of course, the user profile should display the new profile picture and previous profile picture should be replaced. So the previous or the old picture goes off and your new picture should be appearing on your profile. So that is your post condition. Once the test is done, once the process is done, the output, whatever we get, after getting the output, what is the condition is what we will be writing in this post condition. Then is your status. It will be filled after executing your test. So if it is successfully uploading your new picture, then the status will be pass. If it does not upload and if it has some errors, of course, the status will be fail. So this is the phase that will be filled after the execution is done. Then is your comments. If you have any additional information or the updates or the observations, you can fill it in your comment section so that it will be easy for the developer or the tester to work on it. So these are the steps that actually take place in order to write the test case. We have one more example. We will see what it is. And here we are actually considering an example where the user can actually reset their password. Now, say suppose you have Instagram again. I'm taking this Instagram example so that you can relate all three scenarios. Okay. Now we have the login page. Say suppose you have forgotten the password. What will you do? You will click on the forgot password button and you will reset it. So what is the test case structure that we have to write in order to do this particular execution? So the very first step is again the ID. So reset password is what the name you can give in order to write your test case ID. Then your description here. Verify that a user can successfully reset his or her password using the forgot password feature. Of course, in order to change your password, if you have forgotten, it is always the forgot password option will be there on your page. May it be Instagram, may it be Gmail, Facebook, LinkedIn, whatever. You take whichever platform you want, you will have this option of forgot password. So that will be your description. Next is your preconditions. What is the preconditions? User should be on the login page because he don't know the password, he has forgotten. Then user has an existing account with a known email address, which means he should know his username, only then he can change his password, correct? So he should have an existing account with a known email address, in the sense, for example, your Instagram is also related to your email address. So it will send the password to your email address only. So this is the precondition. Next is your test case structure. Will have the test steps now. So what are these steps that you will be doing in order to change your password will be written here. Click on the forgot password link there and then enter the user's email address in the input field provided. So email address will be filled in there and click on submit to send a password reset request. So once you click on submit, an email will be sent to your email address. So once you do that, you will go and check the user's email inbox for a password reset email. You would have received a password reset email now. So in that password reset email, you would have got a link. So click on that link that is provided in your email. Then you will be able to enter a new password using that link. So you will be entering the new password in the new password field. Then after entering the new password in new password field, it will again ask you to confirm the new password. In that confirm new password field, you will be again typing the password that you have recently created, the new password. Then you will click on the reset button. So reset password button will be clicked on in order to set your new password. So these are the steps that you follow in order to reset your password. So that steps will be written in the test steps here. Next is your test data. So your test data will be your new password. Next is your expected result. So your expected result is after step 3, in the sense after you click on submit button that you forgot and you submit your button there, the user should receive an email with a password link. So that is your expected result. After step 8, the user should see a confirmation message stating that the password has been successfully reset and be redirected to the login page. These two steps are the expected result. Now the actual result is nothing but you will be filling this after executing the test execution. And then the post condition. User is able to log in with the new password. He should be able to log in. Then the old password is invalidated and cannot be used to log in. So even if you remember your old password later, you cannot use that in order to log in into your profile. You have to use your new login. So this is your post condition. Then your status. Status, if you are able to successfully log in, it is a success or pass, or it is fail. Comments, if you have any observations in between when you are testing your software, you can put your comments there. So this is how you write a test case structure for any test cases that you want to create or design for testing your software. But we have few best principles or few best steps that you can follow while designing your test cases. We will see what are those. The very first one is be clear and concise. So test cases should be very understandable and they cannot open to interpretations. So it should not be ambiguity. It should not have any confusions in understanding, or any tester, if he carries your project next, he should be able to understand what the test case is actually written for. It should not have any ambiguity in it and it should be very concise. That is the meaning of this particular sentence. Next is be accurate. Here, the test cases are aligned with the user requirements and our intended behavior of the application is checked. So, whatever the user requirement is should be accomplished. So, that is very simple to understand. Next is cover both positive and negative scenarios. So, the test should be both successful operations, that is nothing but the positive tests, and expected failures, the negative tests also should be covered. Next is prioritize. Focus on the test cases for critical functionalities first. So, if it is a very complex function, you have to first focus on it and write the test case rather than completing the other simpler parts of the test case. Next is use test case management tools. Tools can actually help you organize or execute and report on the test cases. review and update. Regular review should be done and update the test cases so that it will ensure they will remain relevant as the software evolves. Even if the software evolves, there should be a constant review and update on the test cases. So these are few best practices that can be followed when you are actually designing the test cases. Now we are at the end of this session, so let's briefly recap on the entire session. So manual testing requires a human tester to perform tests without the use of automated tools. We understood that manual testing requires only human tester to perform the testing process, and he will not require any automated tools. He just should have the knowledge of how to write the test case structures. Next, we understood how the manual testing allows or follows a structured approach with predefined test cases that specifies the steps, inputs, and expected results. We also have to know the expected results and the actual result that we get in order to compare the results, in order to tell that the testing process was successful or the software is giving us the expected output. Next, we also understood that manual testing remains as a fundamental aspect of the software development lifecycle despite the rise and enhancements in automated testing. Manual testing sometimes are very useful at the initial stages of the software development. Next, we understood that manual testing can be categorized into several types, each addressing different aspects of software quality assurance. Manual testing was classified into three main types, that is white box testing, black box testing, and gray box testing. We saw what these different techniques are in detail. The structure of the test case is also designed to ensure a systematic approach to test the software functionality. We understood how to write the structure of the test cases as well. When designing the structure of test cases, adhering to few principles or the best practices ensures that the tests are effective, efficient, and easily maintained. We also understood few best practices that can be followed while designing the test case structure. Now that we have covered the essentials of manual testing, where we learned to execute tests manually without the use of automated tools, let's progress to automation testing. In automation testing, we will explore how to use scripts and tools to perform tests automatically, making the testing process more efficient, reliable, and scalable. Hello everyone. Welcome to the course on Introduction to Automation Testing. In this course, you will embark a journey on discovering the automation software testing. Whether you're new to testing or looking forward to explore more on testing, this course will be a foundation in understanding the automation testing in software development process. Without any further ado, let's jump into the agenda. In this session, we will discuss firstly about the introduction to testing. Then we will learn about the automation testing. Then the need for automation testing, when to automate, different types of automation testing, tools that are used in automation testing, advantages of automation testing, limitations of automation testing, and the challenges that are present in automation testing. Introduction to testing. So before understanding what testing is, let us consider a scenario where you're working in a software company and you have been assigned a task of developing a software. So let us understand a step-by-step process that you undergo or undertake in order to develop a software. The very first step that you do is requirement analysis, which means after knowing your problem statement, you will first do a small research in order to identify the requirements that are needed in order to develop your software. The second step is planning phase, where you will plan your entire development in different steps. So you will first plan what you have to do the first task as, then you will plan your second task. Like that, you'll plan your consecutive steps in order to develop your final output or a product. The next step is design phase. In your design phase, you will design an outline of what you will be doing in order to develop your software. An outline or a sketch, you can call it as. For example, when you want to build your house, you will first design your blueprint. You will decide where your room should be, where your hall should be and all that, right? Similarly, in this design phase, you will design an outline or a sketch in order to develop your software. The next step is implementation. What happens in this implementation? After designing your entire logic of developing a product, you will implement it. You will design your code, you will execute it. You will implement the code in order to get your output. The next step is testing. This is where your testing comes into picture. After designing your code and executing it, you don't know whether you're actually getting the output or not, or the correct output or not. So that is when you do something called as testing. Testing is a phase where you will execute a testing process in order to find out whether you have actually got the expected output as per the user requirement or not. After testing, you will do the deployment, which means you will embed or you will try to deploy your output or the product. The next step is maintenance. After deploying your product, you have to maintain it. You can't just let it go as it is. You have to constantly keep maintaining your product. The last step is documentation. After getting your expected output, you will document it as a report in order to have a report on what you have developed or what your final output is. So the fifth step, that is testing, is the major role. This is what we will be understanding in our course. So what testing is, what are the types that are involved in testing, why we have to do testing, what are the advantages, what are the limitations. These are the things that we will be understanding in this course. Let us understand the basic introduction of testing here. So testing is a critical phase to ensure that the software meets the specified requirements and functions correctly. As I said, it is a very critical or an important phase in the entire software development process. We have to test the product in order to check whether it is meeting the specified requirements by the user or whether it is functioning as per the user requirements or not. The main importance of testing is that to check the quality, to debug the bugs that are present in the code, and also to have the user satisfaction, cost efficiency, and risk management. The main importance of testing is that it checks all of this in order to give the expected output by the user. The next one is, it is a systematic and organized approach for verifying and validating. So there is a proper approach in order to check whether the output is the desired output or not, or whether it is as expected by the user or not. The next one is, the testing has two main types. One is manual testing, the other one is automated testing. We'll see these two testing in detail. The first one is manual testing. As the name tells, it is something to do manually, right? So manual testing is a testing approach where testers execute the test cases manually without using any tools or scripts. Here, if I have to give an example, there will be people who are assigned as a manual testers. So they will create their own scripts or the test cases that they run manually in order to check whether the output is correct or not. So that is called as manual testing. So manual testing comes with its own advantages and disadvantages. We will have a look on it. So the very first is the advantages. So the first advantage is early testing, which means the testing can be done even before the complete deployment or the development of the product. So each stage, the testing can be done manually, having their own scripts involved. The second one is exploratory testing, which means because it is manually done, the users can have their own intuitions or the creativity in their testing. So this is one of main advantage of manual testing. Third one is flexibility. So when the user is actually manually testing the software, he can have his own creativity or intuitions based on the current or the present design, which means if he has to change something based on his real experience, he can do that. So that there is a flexibility. He can change based on the user interface. He can change it based on the output, or he can do n number of changes based on the situation. So that is flexibility. Next is user experience testing. User experience testing is nothing but it is about the user interface. So the manual testers will have the user interface readily available in front of them. So it is easy for them to design it or to have the updates or to change some updates on the user interface or to make some changes on the scripts. So these are some advantages with manual testing. It comes with its own disadvantages. So one is labor intensive, which means that it is very time consuming. Each time the manual tester has to put his efforts, his time in order to do the testing. So that is one disadvantage. Second one is human error. So human error is nothing but humans will make mistakes. They are bound to make mistakes. Nobody is perfect, right? So he will have his own errors when doing things. So that is a drawback of manual testing. Third one is limited reusability, which means each time he has to do the testing over and over again. So there is no smart way or a shortcut to do this manual testing. So there is no reusability of code. Each time if he wants to test the same product or a unit, he has to restart it from the first. That is a disadvantage of manual testing. Last one is scalability. So there is no scalability. There is no easy way in order to make your software testing suitable for all the platforms. For example, browsers, may it be different platforms. It is not easy to match the manual testing throughout the platforms. So that is one disadvantage. So having known about the manual testing, we will see how the manual testing was replaced by the automation testing. Automation testing is nothing but it involves automated scripts and testing tools to execute the test cases. So it comes with its own advantages and disadvantages. So we'll see what it is. Advantages. One is efficiency. So it is very easy to use the automated testing tools. It will reduce the time and efforts that the testers have to put in. So they can easily run the automated scripts that is readily available or that is pre-built priorly, and he will just run the code and he will test it automatically. So this is one advantage. It reduces the time consumed and it will increase the efficiency. Second one is accuracy. It will be perfect. There is no, humans can make errors, but the automated scripts cannot make errors. So it will give the correct output for the inputs that you give n number of times. Third one is reusability. You can reuse the same script or the code n number of times over and over again. It will not get bored. So that is one advantage. Parallel execution. So there is no rule that it has to execute the first script and then go to execute the second script and third and henceforth. There is no rule. It can parallelly execute n number of scripts simultaneously. So that is the main advantage of this automated testing. Complex scenarios. The automation testing helps to solve complex problems. It is easy for an automated script to resolve solutions. So this is the advantage that is coming along with the automation testing. Now let us dive into the disadvantages that are present in automation testing as well. So the very first one is initial setup time. It will take more efforts and time and resources to initially set the frame for all the automated scripts that the automated testers are using. So that is one disadvantage. So initial efforts are involved and it requires that efforts. Second one is maintenance. It is little difficult to maintain your automated scripts because when you make changes to the scripts in between, it should be reflected on the script without spoiling or affecting the existing code. That is the disadvantage. So maintenance is very difficult. Lack of human judgment. There is no human to judge whether the output is right or wrong. So whatever the automated test scripts are there, the automated testers will use them and they will execute. So there is no human judgment involved in the process. That is one disadvantage. Limited for UI changes. Any change made to the user interface should not affect the automated scripts that are already developed. So all these factors play a major role in the automation testing. So these have to be taken care in order to develop your automated scripts. This is all about the automation testing. So we'll learn or explore more about automation testing. Next, let us understand more about the automation testing. So there are n number of automation tools that are present in our current world. The very first step is select the testing tool that suits the development of your product. So that is your very first step that you have to do. You have to select a suitable tool. Second one is you have to define the scope of automation. So you have to tell what your automation process has to do in order to get your desired output. Third one is maintenance. So whatever changes that you make on your scripts that are already developed, so that has to, the changes that you make on the developed script has to reflect without actually affecting to the prior code or the script that is present. So that is maintenance. You have to take care of that maintenance part of it. And then comes your planning. You have to plan accordingly in order to get your desired output. So you have to execute the correct scripts. The testers have to make sure the scripts are executed correctly in order to get the desired output as per the user requirement. The last step is the execution. After doing the entire planning and designing the scripts that is already present, then the next step is execution. So you will be executing the test cases or the script based on the product that you want to develop, and you will get your desired output. These are the steps that you follow in order to get your output in your automation testing. So next we will see why we have to do this automation testing. What is the need? Directly we can do manual testing or we can just skip this testing phase, right? We have to check why we are doing something. Now we will see what is the need of automation testing. So the very first thing is efficiency. We have to increase the efficiency with respect to time or resources or cost. Everything plays a major role. We have to make sure the testing process consumes less time and it has to give us the proper output. So that is very important. We also have to make sure that the cost should not affect the entire process. It should have minimal cost expenses. So that is the second thing. And minimal resources as well. We can't use more resources in order to develop a product, right? So we have to take care of that also. So these are the things that are very important to be taken care of in order to improve your efficiency of your product. So that is the very first thing why we do this testing process. Second thing is accuracy. So if there are humans involved in the testing process, there will be chances of the human doing some error. But here, when you use automation testing, there is no errors that can be expected. It will definitely give you a proper output accordingly. So that is one, it will give you these accurate results. So that is another need for doing this automation testing. Then the next is that it is repeating test. So that is the next need. We'll see what it is. So a repeating test is nothing but if you have to work on the same unit n number of times. If you want to test the same unit n number of times, then there is no need of manually wasting time in order to test that unit, right? So you can easily implement your test cases related to that particular unit and you can execute that part of the code. So that repeating testing will not take time, or it will not take any efforts from the user or the tester. So that is the main need, or that is a major part of automation testing. Next one is finding problems. So the automation testers will find problems, and they will, if there are any problems present in the automation testing, they will convey the same to the software developers. So immediately the problems will be rectified by the software developers on their testing scripts, and that will be implemented. So finding problems is very easy in this automation testing. Next is tools and scripts. So scripts are nothing but it has already been developed by the software developers. The testers will use the scripts and they run these scripts a number of times in order to get the desired output. Tools. When I'm talking about tools, it is all about the testing tools. There are n number of tools with respect to testing. They can be Selenium and etc. So these are the tools that are present in our automation testing. We'll learn about the tools in our next topic. So these are the things that that are very important to know in order to do your automation testing. And then the last aspect is about quality. So when you're doing the automation testing, definitely it will improve the quality. You have to take care of the quality as well when you're developing a product, right? So this takes care about the quality as well. It can run the scripts in order to increase your quality by updating the scripts that are already present. So all these are few factors that are considered when you're doing your automation testing. So these are the things that are necessary in order to check by the developer or the tester. Reusability. Reusability is nothing but you can reuse the existing script n number of times without even developing it from scratch again and again. So you're just reusing the script that is already present. So these are the things that is the need for automation testing. When to automate. So you also have to understand when you have to use the automating testing tool. You can't simply use it because it is already present or it is easily available, right? There are certain scenarios or the situations where you have to actually use the automation testing tools. We'll see when to automate. So there are few instances or the scenarios where you can use it. So the very first one is repetitive tests. When you have to do something on a repetitive process, then you use this automation testing. So automation can save your time and effort by removing the need of repeatedly testing something. So that is the first thing that is considered. The second one is regression testing. Automated tests are excellent for quickly verifying that recent changes haven't negatively impacted the existing feature. As I said you, whatever changes are made to the scripts that are already present shouldn't affect the script that is already present. Any changes that you make to the existing script should give the positive results only. It should not impact negatively. So that is one case. So in this regression testing, you can use the automation tools. Large scale testing, which means automation helps you efficiently to test numerous combinations and scenarios. When there are complex scenarios or big problems, and when manual testing doesn't help, then this automation testing will come into picture. The next one is performance and load testing. Automation simulates numerous users interacting with software to evaluate its performance at various levels, which means it has to perform the same way even if it is executed on a various levels. So that is one criteria where we need to automate. Next is frequent execution and consistency. When there is a situation of executing something constantly and frequently, then this automation can come into picture because it gives us a consistent answer. It doesn't give different output for the same input. So that is the use of this automation testing. Data-driven testing. Automation is useful for running the same test logic with different data. It will have the same test logic or the script so that you can execute different data. So these are the criterias that helps us to understand when we have to use the automation testing. So next, let us understand different types of automation testing that are present. The very first one is unit testing. As the name suggests, it is related to a unit or a component. When you have to test individual components or units of code in isolation, then the unit testing can be used. The main purpose of using this is that it ensures that each unit of code works as expected. So the benefits of using this unit testing is it can debug the bugs initially, priorly. So that is one advantage. So it is easy for maintenance and faster debugging. So this is about unit testing. The second one is integration testing. As the word suggests, integration is nothing but integrating or combining two units, right? So let us see what is the focus of this integration testing. This testing helps in interactions between different units or modules of a software. The main purpose is that it integrates components and works together as expected. So it'll just check whether the modules are interacting properly or not. In that scenarios, you can use this integration testing. Main benefit is that it identifies the integration issues early, so that priorly detecting the issues, it will help in smoothing the communication between the modules. This is all about the integration testing. The third one is functional testing. Functional testing validates the software's behavior against the specified requirements. The main purpose is to ensure that the software's features and functions are working correctly. The main benefit is that the user requirements, or it validates the user requirements, and it helps to prevent the defects in delivered software. So this is the advantage of functional testing. The next one is regression testing. The main focus is to check the new changes have not negatively impacted the existing functionality. The main purpose is that it ensures that the previously working feature remain functional after the updates are done. Benefits are it maintains the software stability despite ongoing the development. The next testing is smoke testing. A quick round of tests to verify whether the basic functionality after a build of the software. It identifies the critical failures early in the development process. The benefits are early feedback on whether a build is stable enough for more in-depth testing or not. The next testing is stress testing. The main focus here is accessing the software's behavior under extreme conditions like memory. When your memory is low, then we have to work upon it, right? So in that situation, this testing comes into picture. The main purpose is to have the software's resilience and ability to recover from the failure. The benefits are it reveals the weaknesses that might lead to crashes or the data corruption. This has to be taken care. So this is about the stress testing. The next one is load testing. The main focus is to evaluate the software's performance under expected load conditions. The purpose is that it determines how the software handles various levels of user activity. The benefits are it identifies the performance bottlenecks and scalability issues. The next testing is performance testing. Performance testing evaluates the software's speed, responsiveness, and overall performance. The main purpose is to measure the system's performance metrics like response time and resource utilization. The benefits are it ensures that the software meets the performance requirements and users' expectations. The next one is security testing. The main focus here is to identify vulnerabilities and weaknesses in software security mechanisms. The main purpose is to protect the software from unauthorized access and data corruption. The benefits here are it helps to secure the sensitive data and to maintain the user's trust. Compatibility testing. The main focus is to test the software across different devices, different browsers, different platforms or operating systems. The main purpose is to ensure that the software works correctly and consistently in different or the diverse environments. The benefits are it provides a seamless experience for users using different setups. User interface testing. Main focus is to verify the graphical user interface's appearance and the behavior. The purpose here is to ensure that the UI elements are correctly displayed and interactable. The benefits here are it improves the user's experience and it catches the visual glitches and layout issues. The usability testing. Usability testing evaluates the software's user's friendliness and ease of use. The main purpose here is to gather the feedback on the software's and the user's satisfaction. The benefits are it helps to enhance the software's user experience and overall quality of the product. These are the different types of automation testing that can be used in order to develop your product or to test your product in the development process. The next one is tools that are involved in automation testing. There are two different types of tools that are already present. One is the licensed one, the other one is the open source. To use the licensed automation tools, you need to have the license, you have to pay the licensed amount and you have to use it or log in. The open source tools are nothing but it is free of cost. You can use it as you want as an open tool. So the very first one is Quick Test Professional. So this tool is a licensed tool. WinRunner is again a different tool that helps in automation testing. Test Complete is a different tool that helps in automation testing. Skillset, Visual Studio Test Services is another licensed tool that you can use in order to do your automation testing. Tellurium is a different tool that you can use in order to do your test. Rational Functional Tester is a different licensed tool that you can use. There are few open source tools as well. One is Selenium, JMeter, SOAP UI, and OpenSTA, which is Open System Test Architecture. Next, we will see the advantages of automation testing. The very first one is increased efficiency. So when the testers use the automation testing scripts, then the efficiency can be increased. Repeatability. Repeatability is nothing but the testing scripts are present and they can be used n number of times by the testers in order to test the product. Next one is higher test coverage. So the test scripts that are present are covered in a larger scale in terms of different domains or the operating systems and so on. The next one is regression testing. Any changes that are made to the script should not affect the existing code. So it has to be in such a way that the changes made to the script shouldn't affect the performance. So that is all about regression testing. So we have to take care of that advantage that is present in our automation testing. The next one is cost effectiveness. So here the initial setup will have some cost to be indulged in the development, but later on it gives us a best architecture or the testing tool in order to test your products efficiently. The next one is early detection of defects. So it is easy to find out the errors at a basic step or at even before the deployment or the development of the product is done. So early stage detection of errors can be done. The next one is frequent execution. If you want to execute something very frequently, you need not write everything from the scratch and then test your code. It is easily available, so you can just reuse it. So that is all about frequent testing or frequent execution. The next one is parallel testing. So you can do your parallel testing of different units. You need not complete one unit and then go to the other unit. You can parallelly test all your units with this criteria or the aspect that is present with the automation testing tools. Next one is consistency and accuracy. So this automation tools will give you the constant output and it gives you the accurate results. So that is one advantage of using the automation testing tools. The next one is data-driven testing. So having the different data, it gives you the same output. The data-driven testing is nothing but when you increase the data also, the test results will be the same. The next one is scalability. So scalability is nothing but if you want to enhance or improve or expand your existing script, then you can go ahead and do it. So that is your scalability aspect or advantage that is present. The next one is documentation and reporting. So it will be very easy and helpful in order to develop your documents or the reports after doing your automation test. So these are few advantages that are present with respect to automation testing. The next one is we will understand the limitations. Definitely anything that has advantage will have its own disadvantages. So we'll see the limitations of this automation testing. So the first one is lack of human judgment. So there is no human to judge whether the automation tool script that is readily available is correct or not. The tester has to just run the testing scripts in order to get the desired output. He will not know if there is any error technically. So that lack of human judgment is missing. So we have to take care of it in order to have the best results. The second one is limited creativity and intuition. Because this is already scripted and readily available, the same script has to be used a number of times. There is no way that you can add your creativity based on the situation. There might come a situation where a new feature or a new creativity, if added, will give justice. But that option is not present in this particular testing method. So that is the disadvantage of automation testing, because it is very limited to creativity because it is already developed and stored. The next one is ineffective for UI changes. When the user interface is undergoing few changes, then the testing script has to be made sure that it will definitely give you the desired output. But then if there is some changes made to your user interface, that will not reflect on your automated scripts that are already present. So that is one disadvantage. You have to again rework on your scripts in order to match it with your new user interface. So that is the third disadvantage. The next one is high initial investment. So initially there is too much to invest on. So you have to invest cost, you have to invest your time, you have to invest different resources to check whether that will be suitable for that particular testing tool or not. So there is a large range of or wide range of initial investments that is needed in order to have your automation testing tools developed. So that is one more limitation. The next one is script maintenance. Once the script is developed, we also have to maintain it. So maintenance cost comes into picture. So maintaining your script also plays a important role, because you maintaining the script is equivalent to get your desired output, right? So any changes made to your script has to be maintained as well, so that you can use it effectively. So the next one is unsuitable for exploratory testing. So very limited to your testing, because you can't explore any new ideas or you can't explore any new features to your script, because it is already automated and you have to use or run the same automated script in order to execute to get your desired output. So this is again one limitation in your automation testing. So these are the limitations that are present with respect to the automation testing, which can be improvised or looked upon in order to get your feasible or effective output. The next one is challenges of automation testing. There are few challenges that are present with respect to automation testing. Let us look into it. The very first one is test script maintenance. So whatever the script that is being developed for testing has to be maintained. It is not easy. When there are a few changes made to your scripts, it has to not affect the existing code that is already present. So that has to be taken care of when you are updating your script at any given point of time. So that is the very first challenge that you will face when you are using your automation testing tools. The second one is dynamic user interface. So user interface are not static or stagnant. They will be dynamically changing based on the user requirements. So that also is a big challenge, because any change made to the user interface will definitely affect the automated scripts that are already present. So that is the second challenge that is present with respect to automation testing. The next one is faulty tests, which means the test scripts will not give the same output always. Sometimes it will fail, sometimes it will pass. So that has to be taken care of. So different times giving different outputs will actually make the tester lose his confidence in using the automation testing tools. So that has to be taken care of. The next one is initial investment. So initial investment has to be done in order to set up your automation tool, right? So that initial investment should be taken care of with minimal time, minimal resources, and minimal cost. So that is again a big challenge, because it differs from scenario to scenario. Next one is tool selection. In the world of n number of tools that is already present, it is difficult to select which tool is suitable for developing your product. So that is again a biggest challenge in your development process. Next one is skill and training. Every tester should be trained based on his existing skills, and he has to keep on updating his skills in order to use the automated testing tools. The next one is integration with CI and CD, which means continuous integration and continuous deployment. The tester has to constantly work on continuous integration of different units and continuous deployment of those units. So that is again a big challenge for the testers. The next one is data management. So data management is very crucial and important role in the entire process. He has to maintain the large data, and he has to give the large effort in order to maintain that data and manage that data. The next one is parallel execution. In order to run the different units with different test cases, and executing them parallelly takes a big toll on a tester. So that is again a biggest challenge in the testing process. The next one is lack of test coverage. Based on the wide range that the tester can look upon, is again a big challenge, because different platforms and different operating systems work differently. So having the test cases to run on the different platforms and still giving the same output is again a biggest challenge. The next one is limited AI and cognitive testing. The automation testing tools are not suitable for using with the AI and the cognitive testing. So this has to be looked upon and worked better to use it with the AI. The next one is non-GUI testing. The automated testing scripts are developed to use with GUI testing, but then the non-GUI testing has to be looked upon in future to work with automation testing. The next one is initial learning curve. Initially, the learning is very difficult at the initial setup stage, where the tester will be working, putting all his efforts in the initial stage, because the initial cost, initial time, and the resources required in order to develop the testing tools is very crucial and very important, and thus it comes in the challenges. The next one is vendor dependency. The licensed testing tools are very expensive and they have to be used correctly, and the vendors of those licensed tools play a very important role in giving you the access based on the payment. The next one is the cultural resistance. These testers do not want to use the automation testing in case where they are very much adapted to the traditional manual testing method, because they lack the confidence of using the automation testing tools. They have the fear that they will be replaced by the testing tools. Because of that fear, they avoid, or they tend to avoid using the automation testing tools. So that is about the cultural resistance. So these are the few challenges that come along with the automation testing tools. Here we come to the end of this session. So let's briefly recall about what all we studied in this particular session. Software testing is a crucial process in the software development lifecycle, and it aims to ensure the quality and reliability of the software applications. We understood what testing is, what are the types that are present in testing, and the uses of it. Next, we understood that the automation testing plays a vital role in managing and testing the tasks within the software development process. We understood automation testing and the need of automation testing and when to automate and so on. Software testing involves unit testing, functional testing, and so on. We saw different types of automation testings that are present. And then we understood the advantages, disadvantages, and the challenges that the tester face in the automation testing process. So that was automation testing and its advantages in efficiency and reliability. Let's now move on to unit testing. Unit testing primarily belongs to the realm of automation testing, as it typically involves writing scripts to automatically validate each unit's functionality. Hello everyone. Welcome to the session on Introduction to Unit Testing. For example, if you have to develop a software, the development process will be in different phases. So we all know you will be starting your software development life cycle with the very first phase in the software development cycle is requirement phase. Then you will do your planning, and then you will do your designing, and then you will implement. So later, the very important phase that you do when you develop a software is testing. So testing is very important phase or a crucial phase when it comes to any development process. Unit testing is a kind of testing that is involved in testing process. We will understand more about unit testing, the life cycle of unit testing, different tools and techniques that are involved in unit testing. Why is this unit testing very important in the life cycle of software development, and many more. Without any further ado, let's jump right into the session. In this session, we will be discussing about the introduction to unit testing. So all the whereabouts of why and what is unit testing. Next, we will understand the need for unit testing. We will take a real-time example to understand how the unit testing is done. Then we will understand the unit test lifecycle. And we will move on to the unit testing tools and the techniques that are involved in unit testing and the advantages and disadvantages of unit testing, along with few program examples. Now we will understand what exactly is this unit testing and few key characteristics or features of unit testing, along with its need and where exactly the unit testing is actually done. So unit testing focuses on examining each and every individual component, or it is also sometimes called as unit of a software application. For example, you have a software. Maybe we can consider an application where we actually use in order to transfer amount from one account to the other account. So here different elements are involved, right? So you will have to use bank account details like or online transaction applications of that particular bank. Say suppose it is KBL, then you'll have a KBL app already installed. Along with that, you also have to have your other applications like Google Pay or Phone Pay. Now you connect these two different units or applications in order to transfer the amount, right? So there are different components or units that are involved in any software application at the back end. So sometimes it is known to you, sometimes it is behind the screen. So we have different components and they all come together to form a final application. So in that cases, each individual component will be tested is what the unit is. Again, in that particular unit, you will have n number of units inside. So we'll see that by taking an example. It actually represents the initial stage of the functional testing. So functional testing is nothing but it is any application that is actually working or executing a logic or a function. It is called as functional unit. So it is a very initial stage of testing. The primary goal of this unit testing is to ensure that each and every component functions as expected or as intended. So you know what exactly you want, and we have to ensure that that particular function is actually executing as per your expectation. The unit testing pertains to the examination of individual or sometimes testable segments of a software system which occurs during the development stage of the application. So this unit testing need not be done at the end of the process. So it can be done during the development process only. So any software in the development process only can be tested, and that testing is called as unit testing. And now the main objective of unit testing is to verify the accuracy of specific separate pieces of code, which means different pieces of code can be tested separately. It need not run all 100 lines of code together and give you output. Sometimes a different part in the program or function or methods can be tested separately also. Each unit corresponds to a distinct function or section of the application's code. For example, when you're transferring an amount, we will consider now the example as send or transfer. So that click or that click of the button can actually be a separate unit. Now the main intention of that send button is to do what? To send amount, right? So that function needs to be tested. So that specific function will be tested, or specific unit will be tested, whether it is working accordingly as per the expectation or not. And then developers typically carry out unit testing using a white box testing methodology, where the internal structure is known and tested. So what happens in white box testing is that, as the name suggests, white box testing is something that is used when the developer and the tester has to know something about the code. As the name suggests, white is nothing but it is transparent, right? So the tester has to have the knowledge of the code here. So knowing the code, he will write the test cases and he will test. So here the developers will have that unit testing in the process of white box testing method only. So they will have the knowledge of the internal structure and what exactly the code is for and what exactly the code is giving us the output as. So everything about the code, the tester will have the knowledge on. As soon as the application is developed and handed over to the test engineer, they begin the process of examining each component or module of the application individually. As I said, even after the entire software is given to the engineer, test engineer, or sometimes he is also called as tester. So that tester will have the knowledge of coding also. Now, what he does is, each individual component he will take and he will test it. Rather than executing it as a whole or testing it as a whole, he will take individual components and he will check whether each individual component is working fine or not. This is all about the definition or a basic information about unit testing. Now we will understand few key characteristics of unit testing. The very first characteristic of this unit testing is isolation. So as the name suggests, isolation is something to be very separate or private, right? So the individual units are assessed separately from the rest of the system. Now in a system, say suppose there are 5 units. So the entire system will contain 5 different units and each unit will be tested separately. So that is called as isolation. So the first unit will be very isolated when compared to all other units in the system. Second unit is again isolated from all the other units in the system. Like this, each unit will be tested separately. Next is automation. Unit tests are typically automated, meaning they can be tested or run quickly and frequently by the developer or via an automated build system, which means there is no manual testing involved here. It is all automated. So test cases or the test scenarios are already written and kept by the tester, having the knowledge of the code structure or the internal structure, right? So now these test cases are automatically executed or run quickly and frequently. N number of times you can actually execute that particular test case. and the output is tested. So it is an automatic process. So that is why it is called as automation. So automation is another key feature of this unit testing. The next one is documentation. So any test that is made will be documented based on the failures. If the test case that is being run and executed, if it fails, then that needs to be documented. If it gives any issues or pop-ups or any errors in between, will be noted. So that is all about documentation. So the set of unit tests can serve as a form of documentation that describes what the code is supposed to do. It will also give the entire information of what exactly the code should do, means that what should be the output, what is expected and what is actual result that we are actually getting. So that can be compared with the help of this documentation. Next key feature is regression detection, which means now you already have an application that is developed. You make some changes to it. So the changes that you are making should not affect the existing criteria or existing scenarios. So for example, they help to ensure that changes that you make to the code, such as, say, suppose you fix the bugs, remove the errors, then they should not introduce any new bugs or errors in the previously tested units, which means, as I said, any changes that you make or the errors that you remove should not add new errors or should not change the execution of the previously added test cases. So that is the meaning of regression detection. So that regression detection is very easily maintained in unit testing. That is why it is called as key characteristic of unit testing. The next one is design feedback. Writing tests often happens concurrently with writing the code itself. This can help developers to think through the design process of the software before they start coding. So it is self-explanatory. So design can be made during or simultaneously when the coder is actually writing the code. This helps the developer to think what more he can add when he is actually designing the software. This helps the tester also to understand the code better, and he will also implement the test cases simultaneously. So this is one key factor or criteria or characteristic of the unit testing. Next is granularity. They are typically very granular and precise, focusing on a very specific aspect of the software's behavior, which means very precise or very specific of what exactly that particular software unit has to do and how it affects the software's behavior. Everything is noted from scratch and in specific and in depth. So each unit will have that granularity in it or specific details to be taken care of. So that is again a key factor or characteristic of this unit testing. So these are few characteristics that are associated with unit testing, which actually helps to test the different units in a better way. Next, we will understand when and where exactly this unit testing is done, right? So, as I said, unit testing is the first stage of testing. So, after unit testing, all other testing takes place. May it be integration testing, system testing, acceptance testing. Now, say suppose we have 5 units. Okay, I will name it like this: 1, 2, 3, 4, 5. Okay, so the very first unit will be tested now. Where in this unit testing phase, very first unit will be tested. Then the second unit will be tested. Like this, all 5 units will be tested. Now, after unit testing, integration testing will happen, which means all these 5 units will be integrated together and it will be tested. So that is called as integration testing. Then is your system testing, whether all 5 units are working fine together or not. So this is considered as a system now. So now this system testing is done. Later, we will understand whether that system is accepted or not. Whether it is working fine, then it is accepted. If it is not working fine, then it is rejected. So this is how there is different levels of testing when you are actually developing the software. And the very first testing is nothing but the unit testing. Now we will understand what exactly is this unit testing doing. So software typically undergoes 4 primary levels of testing, as I said. One is unit testing, integration testing, system testing, and acceptance testing. Next, in some instances, due to some time constraints, or maybe the software will be given deadlines. So you have to develop this particular software in so and so deadline. So based on that time constraints, or due to some external factor, or the delay in the requirement phase, or some delay in the entire process will lead to this time constraint, right? So there, what the testers will do is that they will use minimum time in this unit testing. They will not spend lot of time in unit testing. So they will do it randomly in minimum time. So what happens is that after unit testing, thereby when it passes through this unit testing and goes to the next level of testing, the unit testing can result in a greater number of defects emerging during later stages. So if this unit testing is not done properly because of the time constraint, then errors will occur in later stages. It may occur in any of the other stages. That is why what they do is they, in later stages, it will be little difficult in order to remove that errors. They will not know in which unit the error is present. So that becomes a tedious task for the testers. That is the meaning of this. By passing through the unit testing can result in a greater number of defects emerging during the later stages, such as integration testing, system testing, and acceptance testing also. Or sometimes it may occur during the beta test also, which means it occurs after the software application is considered complete. So even after the acceptance testing, there are n number of tests that take place. It's not just unit testing or acceptance testing. There are n number of tests after the development of the software is completed. So in beta test, at that last stage of testing also, the error may occur. So to avoid that, you should be very careful when you are doing unit testing. Right? Unit testing sits at the fundamental tier of the testing hierarchy, which means this, the very first stage, and it is performed prior to integration and subsequent testing stages, which means it is done before integration testing and all other testings like system testing, acceptance testing, and many more. This level of testing is conducted on individual modules, diminishing the need to wait for other components to be developed. For example, as I said, if there are 5 units to be tested, even if the second unit or the third unit is not completed, but still we can carry out the testing of this first unit. That is the meaning of that. So you can actually do testing on individual modules without any dependency with the other modules. Tools such as unit testing frameworks, stubs, drivers, and mock objects provide support during the unit testing process. These are the methods, that is, frameworks are used, stubs are used, or sometimes drivers, and sometimes mock objects are also used. You'll understand it better when we move on to our hands-on and actually try to execute and implement few programs. So this is about the introduction of unit testing, of where and why it is done, and few characteristics associated with unit testing. Now we will understand what is the need of doing this unit testing, right? So the very first need is early bug detection. As we already understood in our previous slides, if you take minimum time in doing unit testing, errors may occur in later stages of testing. So to avoid that, or you can invest more time in unit testing and you can detect the errors in the earlier stage. So this allows the developers to catch and fix the bugs early in the development process before the software reaches the end users. Next one is facilitates change. So developers can make changes to the code, knowing that they will be able to quickly identify if the change breaks existing functionality. This is something related to regression testing, right? So developers will make changes to the existing code, and we should make sure that the existing changes are not affected by the new changes. So that change is facilitated in unit testing. Next is cost effective. So caching and fixing bugs in the early stages of the development process will actually reduce the overall cost of the software development. So you can minimize your cost. You can minimize your cost and develop the software because the errors are detected at the initial stages only. Next is simplifies integration. So by ensuring that each unit works correctly, the integration of these units becomes less problematic. As we know, the units are tested separately and all the units are put together or integrated together to check whether the system is working fine or not. So that will not have an hassle in integration. So that is one criteria which we can consider for using this unit testing. Next is documentation. They can provide insights of what the code is actually doing and what is the code supposed to do. So this is one easiest way of maintaining the document, and it will help in the development process. Then it is the regression testing. When the code is modified, the unit tests can be run to ensure that previously working functions are not broken by new changes. So the existing functions should not be affected by the new changes. So that regression testing is also taken care in the unit testing. Next is the design feedback. Writing unit tests can provide immediate feedback on the code's design, which means the code is written and simultaneously the test cases are written for that particular code. So that is the design feedback. And then the confidence. So this actually develops a very big confidence with respect to developers, and they can work with that peace of mind that their new changes have not affected the existing code. That confidence the developers will have. Efficiency. So the automated unit testing is often more efficient than manual testing that we already understood, especially when it comes to the repetitive testing of same units. Now we have 5 units and you want to test the third unit for 10 times. So if it is manual, then it is very difficult. Because it is automated, that particular unit can be tested not just 10 times, it can be tested for 100 times. So that efficiency is there when you are using this unit testing. Next is the quality assurance. Consistently applied unit testing improves the overall quality of the software. So the overall quality of the software is increased by using this unit testing. Now we will understand more about unit testing by taking a small real-time example. Before moving on to the real-time example, I'll give you a small schooling days example. So in our schooling, when we were kids, we were asked to attend unit tests, if you remember. So we were given a series of unit tests, maybe first unit test, second unit test, and third unit test, and only then we were attending our final exams. So what happens in unit test now? So you will be given a small unit or couple of chapters or units to prepare for, and you will be tested on those. And again, in your second unit test, it will be the next 2 units that you have to prepare for test. For the third test, it will be 5th and 6th unit for test. So all 2 units will be tested separately. You will be given test based on 2 units each. And then later in your final exam, you will be given test or final exam on all 3 units. So what happens here is all 3 units will be clubbed together and asked in your exam, yes or no. So same applies here. We will see and understand more about this real-time example of unit test now. So we will take an example of amount transfer between 2 accounts. So what will happen in the background or backend when this is happening? We will see what are the different units involved in this amount transfer. So say suppose he is person A and this is person B. Now A is wishing to transfer some amount, X amount, say suppose 10,000 to account B. Right? We will see how that is done and how that is tested in unit wise, right? So the requirements for the amount transfer entity is as follows. So what are the requirements or different criterias involved in this amount transfer? So very first criteria or the entity is from account number. So as I said, A is the user. From A, the amount is sent to the person B, right? So A is considered to be the from account number. Now, from account number, you will be writing it in a text box. So that is why I've given it as text box. Then this text box will accept only 4 digits now in our example. Okay. So the account number should be of 4 digits only. Okay, and then the next one is to account number. So B is the other person who is actually receiving the amount, right? That will be the to account number. And again, it is represented in a text box. Again, the to account number should accept only 4 digits in our example. Next, the amount will also be written in the text box. So what is the amount that we decided to transfer between A and B? It was 10,000. For example, I had taken 10,000, but here in this example, we are giving only 4 digits. So we'll remove this example that we considered. Now it is only 4 digits. So again, it should have only 4 boxes like this in order to accept your 4 digits. Again, later the transfer will have a button. So after all this, there is a send button and there is a cancel button. Correct? So after entering all these details, you can click on send so that it will be enabled, or you can click on cancel if you don't want to send. If you change your mind sometime later, then you can just enable your cancel button. So I have represented this in this block diagram now. So amount transfer is the module here in our example. So from account number, to account number, amount, your send button and your cancel button all are considered as components. So all these are considered as different components and each component is considered as a unit now, right? So we will see what exactly happens in each of it. Okay, so the very first one is from account number. So your from account number will again have values in it. So we have to check all possible values that particular unit can accept, right? So now in our example, I am considering the from account number to be 1234. So that is fixed now. So this is my from account number. Okay. If you enter that from account number as 1234, only then it will accept. Okay. If you give any other number other than 1234 like 4567 or 5678 or any other 4 digits that you give will be invalid. That is why it will display an error message as invalid account. So what other values will be considered as invalid? If you give 0000 or if it is blank, if you leave it blank, again it will give you an error message and it will tell you to enter some values in it. If you give 5 digits or 3 digits, which is not according to our example, then again it will give an error message telling that you have to enter only 4 digits. Or your account number, if it is alphanumeric, for example, if I type A, B and 3 and some symbol like this, again it will give you an error message and it will ask you to enter only digits. Then if this account is blocked, say suppose 5678 is blocked, or in other case, if 1234 is only blocked and if you are trying to add that account number, then again it will give you an error message, which is not in our case as of now. So any other account number, if it is blocked and if you are trying to add that account number, then you will get an error message. Then you can't even copy the value. For example, I can't copy this and paste it in that particular text box. I have to type it. There is no option of copy paste when you are actually transferring or testing that particular unit. So if you copy paste it, it will tell you to type the values. That will also be given as an error. Now, similar to 10, which means if you give the same account number as 2 account number, then again you will get an error message. These are few values that I have given as a boundary values. I've touched each and every corner of the boundary, and I've given all the possible inputs that a user can actually try in this particular text box. So considering all these values, the test will be performed on this particular component. That is how the from account number will be tested. Next, how is this to account number tested? Similar to the from account number, right? So to account number is considered to be 3456 now in our example. If the same number is given, only then it will be accepted. If any other number other than the one which is 3456, then it is error. So it will display invalid account. If it is blank or if it is 0, then again it will ask you to enter some values. If it is 5 digits or 3 digits, it will ask you to enter only 4 digits in it. If it is alphanumeric, again it will display an error telling that you have to enter only digits. Again, if it is a blocked account, it will tell it is an error. Copied value, again if you copy the values from elsewhere, it will give you an error and it will tell you to type the values. If it is similar to from account number, again it will give you an error. So these are few values that I am actually covering in this particular test case, and I am trying to test this particular component or unit, that is to account number. Next, we have one more unit, that is nothing but the amount component. Amount is something that you will be typing in order to send it to the receiver, right? So we will see what are the values that we can cover in order to test this particular unit. So these are few values that you can do. One is we fixed it as 4 digits. So the amount that you type should be of 4 digits only then it will be accepted. If you type the digits less than 4, it is okay. If you want to send 100 rupees is also okay. If you want to send 10 rupees is also okay, right? If you type the amount less than 4 digits also, it will work. That is why it is accept here. Now, if you leave it blank, it will ask you to enter some amount in it. If it is greater than 4 digits, or if it is 5 digits or 4 digits or whatever, if it is greater than 4 that we have already fixed as, then again it will give the error and it will ask you to enter only up to 4 digits. You can enter 2, you can enter 3, you can enter 4 digits, like that. Alphanumeric. If you enter some alphanumeric numbers, like if in case in order to type 5000, if you type it as 5AAA, of course it is an error. So it will display, it will ask you to enter only the digits. Next is your copied value. If you copy and paste the amount from elsewhere, again it will ask you to type the values. These are few values that are covered in this particular testing of this unit, that is the amount component. Next is your transfer component. So to transfer, what will happen? You have to enter the valid from account number. You have to enter the valid to account number, and then you have to enter the correct amount in that particular text box, that is up to 4 digits only. And then if you want to send, then you will click on the transfer button. That is when it will work. It will send the amount from person A to person B. It will then display a message telling that amount transfer is successful. Now there is one more component that you can test, that is nothing but cancel component. What happens here? You will be entering valid from account number, you will be entering valid to account number, you will be entering amount, say suppose 4 digits, and then if you after entering all the details, if you change your mind not to transfer that amount to that particular person, then you can click on cancel button. When you click on cancel button, of course, a message will display that all the data will be cleared and it will tell nothing has been transferred, no transaction. It will give you a message as no transaction. So like this, different components are tested by considering the values which covers the entire boundary, and it will test each unit accordingly. This is one example that is being taken in order to understand how the unit testing is done in different components. Now, until all the components have been developed, the tester need not wait. The tester can start his testing process once the from account number component is created. He can start testing that from account number irrespective of other components, may it be to account number or cancel component or even the transfer component. So each unit is tested individually. It is not dependent on any other component or units in the system, right? Hope you understood this example. Now we will understand the life cycle of unit testing. So now, the life cycle of a unit test refers to the sequence of stages that it undergoes or it goes through from its initial creation to its execution and review. So we will see what are the stages that a tester will follow in this particular unit testing. So the very first phase is called as the setup phase. So here in this setup phase, before the actual test runs, the setup phase is where you prepare the necessary environment or state for the tests. So here you keep the things ready and the environment is set it up properly in order to carry on the tests henceforth. It is just the setup phase now. Next is your execution phase. The test execution phase is the actual test methods are executed. Here, each and every method is actually tested and it is executed. Each test method usually tests a specific aspect or functionality of the code. So each function is tested in specific now. So the test execution phase is all about each function is executed and it is tested. Next is assertion. In this assertion phase, the assertions are made to check whether the actual outcomes match the expected results or not. If an assertion fails, then the testing framework marks that the test is a failure and records the details, which means you have created few assertions. Once that is executed, it is compared with the expected output or result. If that actual output is matching with the expected output, then it is passed. If it does not match, it is considered as fail. Then that failure will be noted in the document. It is recorded in the document. Next is tear down. In this tear down phase, after each and every test method is executed, there is usually a cleanup phase where you can actually undo any changes that were made during the setup or test execution phase. If you want to undo, if you change your mind, then you can do it using this particular phase, that is the tear down phase. Next phase is test reporting phase. Once all the tests have been executed, the framework will typically provide a report detailing which tests passed, which failed, and any errors or exceptions that were encountered. So here a report will be created where it will have the details of everything, which tests passed or which test failed, or if there is any error or exceptions, all that will be noted down in this particular phase. Next is the review phase. This is not enforced by the testing framework, but it is good practice to include this review phase. After tests are run And particularly if there are failures, the results should be reviewed to understand what went wrong. This may involve debugging the test code or the code under test. So review phase is nothing but you can consider any review example for that matter. After everything is done, a review phase will be there wherein they will just sit and review what was done or what was tested. Similarly, here also, after the tests are executed, then the review phase will be done. So it is not compulsory to have this phase, but if it is enforced in your testing methods or testing framework, it is a good practice to have it. Next is your maintenance phase. As the code base evolves, tests may need to be updated or extended. This phase includes adding new tests for new features, refactoring tests for readability and maintainability, and removing tests for deprecated features, which means you can add or remove any test feature that you want to include in your testing process. So these are the phases that involve in the unit test lifecycle. If the unit test is in process, then these are the steps or these are the phases where the tester follows in order to test your components accordingly. Next, we will understand few tools that are involved in unit testing. The very first tool that I can call is the Java. Java is a language that where you're using different frameworks in it. So JUnit is the first framework or the popular framework for unit testing in Java. Then the TestNG is also a testing framework that is inspired by JUnit that you're using in your Cucumber testing or any other testing, but it is introducing some new functionalities with it. Mockito is again a framework that is used in conjunction with JUnit to test interactions between objects. Next is your PHP. PHP unit is a programmer-oriented testing framework which is used for PHP coding. And Mockri is again a mock object framework that is used for conjunction with PHP unit, right? Next is your C or C++. Google Test is Google's C++ test framework that can be used to do your unit testing in C or C++. CPP unit, that is nothing but C++ is a port of JUnit which can be used again for doing your unit testing. Catch2, a multi-paradigm test framework for C++ is also used for unit testing. Next is Ruby. RSpec is nothing but a behavior-driven development framework which is used in Ruby and it is commonly used for writing unit tests. Minitest is again a simple and clean framework for writing tests in Ruby. Next is your JavaScript. Jest, a delightful JavaScript testing framework, is used for focusing on simplicity. So it is very simple to write tests using Jest. Mocha is again a feature-rich JavaScript test framework that is running on Node and in the browser as well. Jasmine, a behavior-driven development framework, is used for testing JavaScript code. Next is your Python, which we'll be using in our session. Unit test is a famous framework that is built into the Python standard library. We will see how to use this. And PyTest is again a no boilerplate alternative to Python's standard, that is unit test module. Mock is again a library for testing in Python. As of Python 3.3 version, it is available in the standard library. Swift or Object-C. So here XCTest, it is nothing but a framework that comes with Xcode which you can use to write unit tests for your iOS or macOS applications. It is completely related with iOS products. Quick is again a behavior-driven development framework that is used for Objective-C or Swift programs. Next is your Go. Go's testing package can be used, which provides a straightforward way to write tests in Go with the built-in testing package. Next is your Testify, a sacred extension to the standard testing package. This is also used in order to do your unit testing. There are few other tools and frameworks. One is Selenium. So, although primarily used for automated web application testing, it can also be used for unit testing in collaboration with other frameworks. This Selenium is mainly used for automated web application testing, but it can be used in collaboration with the other frameworks also in unit testing. Cucumber is a tool that is again which supports behavior-driven development and is often used with other testing frameworks. Mockito for Java is again used to create mock objects for the purpose of testing interaction between the components. Mock for .NET is also used to create mock objects for the purpose of testing interaction between different components. So these are few tools and frameworks that are used in the unit testing process. Now we will see few techniques that are involved in unit testing. So the very first technique is black box testing. As the name suggests, black in the sense it's dark, which means you have no idea about the internal structure or the code. White box testing, as the name suggests, it is very self-explanatory. It is transparent, which means the code is known to the tester. Gray box, it is the combination of both black box and the gray box. Boundary value analysis is nothing but you have to include all the values without even eliminating any of it. And equivalence partition is nothing but input data will be partition. We'll see in detail what these are. Coming to black box testing, tests are based on specifications and requirements and not on the actual code. As I said, there is no need of concentrating on this actual code. Only the specifications and requirements will be considered. Next is your white box testing. Here, based on the internal paths, structures, and the implementation of the source code, the unit testing is done, which means the source code is playing a major role. The tester will have the entire knowledge on what the code is and what exactly the code is doing. Next is gray box testing. Here, it is done based on the internal paths, structures, and the implementation of the source code, which means it is a combination of both black box and white box testing. So the tester will have the knowledge of the code and then he will create the test cases in order to do the testing. Next is your boundary value analysis is effective in checking if the unit handles the edge cases correctly or not, which means no case is left unattended. Next is your equivalence partitioning. Here, the input data is divided into valid and invalid partitions and tests each partition to reduce the number of test cases a manageable level, which means your input that you are giving is divided into valid input and invalid input, and these partitions are again tested so that each partition is tested separately so that it reduces the number of test cases to a manageable level. So we have few more. Next is your decision table testing, state-based testing, statement coverage and branch coverage, path testing, and mutation testing. So we'll see what these are. Decision table testing is nothing but a table is created to represent the logic conditions and corresponding actions to be taken on the particular condition. So each and every condition is tested in an easier manner because it is already in the decision table. Next is your state-based testing. Here, various states and transitions are tested to ensure the correctness. Each and every state and its behavior is tested and its transition is also tested. So that is how the state-based testing is very convenient in order to check the correctness of the unit. And then is your statement coverage and branch coverage. Statement coverage tests each line Whereas branch coverage tests every possible path, which means, say, suppose you have a number of paths to reach from A to B, A to C, and A to D. All the paths will be tested. No line of code is left unattended. Every possible path is tested in your branch coverage. Next is your path testing. A rigorous version of branch testing is called as path testing, where all possible paths are tested and coded in order to check whether it is working fine or not. This is called as path testing. Next is your mutation testing, which actually involves modifying the source code in small ways. So it will be converted into or modified into small codes or small ways so that it becomes easier in order to test it as a unit. So this is called as mutation testing. We have few more, that is error guessing, pairwise testing, test-driven development, behavior-driven development, and mock objects. So the error guessing is nothing but it relies on the tester's experience and intuition to guess the problematic parts of the application. So it depends on the tester only. He can actually suggest, or based on his intuition or assumptions, he can actually solve half of the problem. Pairwise testing is nothing but it is designed to test the software with multiple inputs using pair combinations of input values to actually reduce the total number of tests. You can pair them and you can test it together so that it reduces the total number of tests that is involved in the process. Next is your test-driven development. Writing tests before the code itself and then writing code that passes the test is one method. So you will write your test cases and you'll keep it ready even before the code is created. This is test-driven development. Behavior-driven development is a rigorous version of branch testing where all possible paths will be tested through the code. That is called as behavior-driven development. Next is your mock objects. Here, this is used to simulate the behavior of real object, or each object under the unit test will be tested. It will be interacted and it will be tested. So these are few techniques that are involved in unit testing. Now we will understand few advantages and disadvantages that are associated with unit testing. Firstly, we will start with advantages. So the very first advantage is early bug detection. The name only tells us everything. You can identify the errors or the bugs in the initial stage itself. Unit tests catch the bugs early in the development cycle, which reduces the cost of fixing them compared to if they are discovered later in system testing or after development, which means if the bugs or the errors are detected in the primary stage or initial stage, then they are easy to debug or they are less cost effective. But if they are detected in the later stage after the entire system is developed, then it is very difficult to fix them. That is the meaning of early bug detection. This is one major advantage that is present in unit testing. Next is it facilitates changes, which means having a suite of unit tests allows developers to make changes to the code base and ensures that the existing functionality remains intact, which means the existing functionality will not be affected by the new changes or new modifications that are made to the tests. That is the meaning of this particular statement. That is why the unit testing facilitates change. Simplifies integration, which means unit testing verifies that each piece of code works properly and correctly in isolation. There are different units in a system, as we saw in one of our example, and each unit of code works properly in independent. Which actually simplifies the integration of these individual parts into a larger system. So all these individual units are now integrated into a larger system, and it is easier when it comes to the unit testing process. Next is your documentation. So unit test serves as a form of documentation for the system. They demonstrate what the code is supposed to do and how it is intended to be used, which means each code has its own specific function, right? So that will be explained and saved in the document. And this helps for the tester to know what the code is actually expected to do. That is the use of documentation, and it is supported in unit testing. Next is your design feedback. So having a suite of unit tests allows the developers to make changes to the code base and ensures that existing functionality remains intact, which means the unit test allows the developers to make changes to the code base. He can make any change that he wants to the code during the design phase. So design phase will help the developer or the coder to actually write the code in a better way, and it ensure that the existing functionality will remain unaffected. Next is your improves teamwork. So which means with a shared suite of unit tests, the teams can work more collaboratively and confidently. So there is more interactions between the teams, and this will create the unity in teams. So it improves the teamwork. And then is your developer confidence. So the developer also will gain the confidence that he can work more confidently and efficiently, that their changes are verified by tests, which reduces the fear of breaking the existing features. Next is your better code quality. Regular unit testing leads to higher code quality because it encourages writing more modular, flexible, and extensible code, as these attributes make the code easier to test, which means when you test particular unit time and again for n number of times, if you test, then it is for sure you can declare a statement that it works better or it has the higher code quality. That is the meaning of this particular advantage, that is better code quality. Next, it reduces the future defects, which means a comprehensive unit test suite can catch regression defects that might be introduced when code is modified or extended, which means in case if the tester wants to extend the test case, or if he wants to include anything or add anything to the test case, then that criteria, that is the reduces future defects, make sure that the whatever code is introduced will not affect the existing code. That is one particular advantage. Next is speeds up the development process. Automated unit tests can be run quickly and frequently, which actually speeds up the feedback loop for the developers. When the manual testing is compared with the unit testing, we can tell that unit testing, or sometimes it is also called as automated testing, is way more better when it comes to manual testing. So using that automated testing process, the speed also can be increased, wherein the software will be developed at a faster rate. It reduces cost. By catching and fixing bugs early, the unit testing actually reduces the cost that is associated with larger stages of testing and post-release patches, which means when the bugs are initially detected and cleared or clarified, then it is cost efficient. So that is the meaning of reduce cost. Enables test-driven development. Unit testing is a backbone of TDD, which means test-driven development, which is an agile development technique where the tests are written before the code. So even before writing the code, the test cases will be generated or created. So later you can write the code according to the test case, or based on the code that is written by the developer or coder, you can alter your test cases. So these are few advantages that are associated with unit testing. When there are advantages, it always comes with its drawbacks or disadvantages. Now let us see what are the disadvantages associated with unit testing. The very first disadvantage is time and resources. Writing good unit tests can be time consuming and requires additional resources. So if you invest some time here in this particular phase, then rest of your development will be easy. So that is your time and resources. Next is your test maintenance. So if there are any changes that are made to your test cases, that has to not affect the existing functionalities. So that has to be maintained time and again in between, right? So unit tests need to be maintained alongside the code base. When the underlying code changes, the corresponding tests may also need to be updated or rewritten. So consistent tests should be there in order to maintain the entire process. Incomplete testing. Some aspects of the system such as UI, performance, and sometimes security are not well suited for unit testing, and they require different testing methodologies. So these are few disadvantages that are associated with unit testing. Next, we will actually try a hands-on session where we will see how this unit testing is done using Python programs. We will write simple Python programs and see how the unit test framework is actually imported into this Python programs. So without any further ado, let me teach you how to do this. So you will go to your Chrome and you will use your Python online editor. When you type that, the very first link that you get is the online Python compiler. I'm using this now. So I have my codes ready for few of the program examples, which I'll be sharing with you in this particular session. So later you can actually use these codes. So the very first program is very simple. I am actually trying to add two numbers and I am trying to test how the unit testing works in my Python program. I am importing unit test framework here in my Python code using this statement, that is import unit test. This is just a comment. So next I am writing a function or defining a function where I am taking two parameters, that is A and B, and I am adding those two numbers. For example, if 5 is stored in A and 3 is stored in B, my job is to add A plus B, that is nothing but 5 plus 3, which is equal to 8. Right? So this is my result that has to return back. So this function is doing that operation of adding two numbers. It will take two numbers and store it in A and B and it will give the result. And then the result is returned using this particular statement, return ABC. And this is again a comment. So we'll see what is this line now. So test simple math is nothing but a class name that I have given. I've created a class and unit test dot test case is now the framework, and this is actually provided by the unit test framework that I have already imported from here, right? And now inside my class, this diff test add is a method and I have named it as self now. So now these are the assertions that we spoke in our theory, right? So each assertion here, for example, self.assertion equal is nothing but I am actually assuming to add that 3 and 4 input numbers and my result should be 4. So this is my assertion that I am making. I want to test this assertion and I am writing few more. So in my second assertion, I am trying to add 0 and 0 and my result should be 0. In my third assertion, I am adding -1 and +1 and my result should be 0. These are my assertions that should be tested in the unit test case now. And then the final part of the code is if name is equal to main. This is where the execution starts from the main function, and this is actually calling the unit test framework now. So I will simply copy this and add it in my online compiler. Okay. And I will try to run this program. So you can see that output will display telling that ran one test in 00 second and it gave me OK. So after running this code, I will get the output as ran one test in 00 seconds and it gives me OK, which means the test passed here, which means the test that I have written here, I have written just one test, right? So that ran and it is OK. These are few the warnings that you can ignore. So this is my first program, which is actually running fine. And my main intention is not to teach you Python code to add two numbers and all. My intention is to show you how the unit testing is done. We are just using the unit test framework and we are actually executing the program and seeing the output, whether the unit test is working fine, is it passed or is it failed. So that is the agenda of my execution of the program here. Next is finding the factorial of a number. So if it is 3 factorial, how do we calculate it? It is nothing but 3 into 2 into 1, right? Which is nothing but 6. Right? It is our answer. So like that, you can find the factorial of any number. So here in our code, this is the function that is actually calculating this factorial result. And if n is less than 0, then it is an error. If it is ranging from, it starts for I and in range to n plus 1, which is nothing but the logic that I used here, right? So this is the logic of the program. I think you should be knowing this by now. And then writing the unit test is this way. You will be importing the unit test framework. And these are the class names that I've created. So this is the class, that is class test factorial. And this is the framework that is actually provided by unit test framework. And then this is the method test factorial self. And these are the assertions that I'm making. So factorial of 0 should be 1, factorial of 1 should be 1, factorial of 5 should be 120, and so on. And this is again a edge case where I am covering every case. I'm not leaving any unattended cases. So factorial of 0 is 1, factorial of 1 is 1. Again, these are two assertions. And I am giving one more assertion telling that self-assert raises value error and factorial -1. So these are few assertions that I have made. And again, here I am calling the unit test main function. So I'll simply copy this. My main intention is to check whether the unit test framework is working fine or not, or how is it tested. So I'll simply copy and I will paste it in my editor. So you can see the output as ran 3 tests in so many seconds and it is okay. It is not giving any warning or error. So now these are the 3 tests that it ran. One is test factorial of self, one more is test factorial edge case self, and one more is test factorial errors also. So that is why it is 3 now. Now what if I change this value? Will it give me proper output or will it still give okay? Can you see? I changed the value here. I changed it to 5 factorial as 20, which is wrong. Now it is giving an error, failures as 1. So 1 failed. Among 3 tests, one of the tests failed. So now let me re-type it as 120 and run. So now there is no error, which means any error that you make in assertions will be declared as failure. So this is one example. Let us check one more example where whether a given year is leap year or not. I'll simply copy this code that I have written and I will paste it in my editor, that is online compiler, and I will try to run this. So you can see the output as ran 1 test in so many seconds and it is okay. Now, if you give any invalid input here and run, it is still giving okay, which means the leap year is not detected by the function that is written. So let me keep it as it is. So make any changes to your logic, then it will reflect. Without logic, if you write any assertions, it will not reflect. So hope you understood the difference. We will see one more example, that is palindrome. Palindrome is nothing but you have an example. You read it from the left hand side, it is still madam. You read it from right hand side, it is still madam. Which means palindrome is nothing but the number or a word that is similar even if read from both the ends. So this is a simple palindrome program which is already ready. I have written the assertions also and kept it ready, and if I copy and if I paste it in my online compiler and if I run, again the output is passed. So it is ran one test in 00 seconds and it is okay. So this is how you can actually write your simple Python programs, and you can run it on the online compiler and check whether your unit test framework that you're writing in your program is working fine or not. You can keep your test cases ready and you can easily import it into your Python, and you can execute your unit test programs, or you can check how the unit or a component works. So this is how you can write simple Python programs and execute using the online compiler. Hope this was easy. Please try and explore more programs in the similar form. After understanding what unit testing is, the life cycle of unit testing, and the tools and techniques that are involved in unit testing, including the advantages and disadvantages, now that we are at the end of this session, we will quickly recap the entire session that we understood. Unit testing is a process where individual software components are tested separately for proper operations. The main aim of unit testing is to confirm that each code segment works as intended, typically done by developers to catch the bugs in the earlier stage. The unit testing lifecycle is iterative, involving regular updates and retesting of unit tests to maintain code quality with each change. So the unit testing lifecycle was also explored. The tools and techniques contributes to creating a robust unit testing process that can actually catch the issues or the errors early and improve the maintainability and reliability of the software. Unit testing is also very crucial for catching bugs early, refining design, and securing code reliability, aiding refactoring and integration while documenting functionality. So these were all the advantages of unit testing that we understood in this particular session. The advantages of unit testing has its own drawbacks. So that was also discussed in this particular session. A simple Python programs can be developed and then the unit tests are created for it using the unit test framework. We saw how the Python code can be written and how the unit test framework can actually be imported into the Python programs, and we executed and we saw the output of the unit test process, right? In unit testing, we will focus on testing individual components of the software in isolation to ensure each part functions correctly before integrating them into the larger system. In unit testing, we focused on testing individual components of the software in isolation. Now, let's move on to the integration testing. In integration testing, we will ensure that these individual units work together as a cohesive system. Integration testing can belong to both manual and automation testing depending on whether the tests are executed manually or through automated scripts.
Hello everyone, welcome to the course on integration testing. Let's check on the agenda. We will first learn on what exactly is integration testing. We will see the difference between unit testing and integration testing. We will also explore the difference between integration testing and your system testing. We will look into the benefits of your integration testing. We will see what are the different types of integration testings. We will see what are the entry and exit criteria which are required for your integration testing. We will explore the integration testing test cases. We will see the how do we automate your integration testings, and then test cases. We will try to explore some of the test cases for your integration testings. We will see what are the challenges which are there for your integration testing, the best practices of integration testing, what are the different automated integration tools which we have for integration testing. And in the last, we will explore a case study on integration testing. Now, coming to introduction to integration testing. When we say integration testing, the word integrated is what is giving you the full meaning, right? You are trying to integrate two or more modules and trying to check the functionality of it. When I say modules, I'm not talking about the hardware modules. Yes, of course, integration testing is required for your hardware systems as well. But now here we are talking in context of your software applications which are being built. So your integration testing is an approach where different modules or components, you can say, of a software application are tested by combining it together. So you have different components, you have different modules, you're trying to combine those different modules, integrate those different modules, and then you're trying to have those integrated modules being tested. That is what tested for what? For the functionality for which it is being designed for, whether it is working properly or not. So that is what is your integration testing. Now you run your integration test regardless of whether one or more programmers code these modules, right? It might be that you might have four modules A, B, C, and D, and all these modules might be developed by four different programmers or developers, right? So now, regardless of who the programmer is or what the code is all about, what the functionality is all about, you are trying to integrate these modules, and then you are trying to check on how the system or the software application is working, right? And then before a release, a software application undergoes different operations. What are those operations? Such as extensive testing iterations. There are a lot of testings which are done, lot of iterations which are done on the testings. How the exception handling is done for identifying if there are any bugs or if there are any errors, which will help us in trying to make the product business ready or market ready, you can say, right? So before the release, there are a lot of testings which will happen by the testers, by manual testing, by the automation testing, which will help us in trying to make the product or the software market ready. Now, integration testing is one of the primary phase of your software testing process, where testing is done at the development stage. When you're trying to develop your softwares or your applications, you're trying to have those software integration testings being done at your development stages. Now, more on your integration testing, it is a type of your software testing where the components or the modules of your softwares are progressively integrated and then tested as a unified group, right? So you have there is an hierarchical way of trying to have your applications being up and running, right? Say for example, if you're trying to build a website itself, your website will have a login page. Your website will have, say, if you're taking an example of a Gmail, you have a login page and then you have your inbox. You have different components, like if you want to compose an email, you have a compose mail, and then the compose mail, after you have sent, you need to, all those mails have to be there in the outbox, and then it has to come to your sent mail. So these are different components, you can say, which are there. So your integration testing is helps you in trying to progressively integrate these modules and test them in a unified way. And then these components are up and working well individually, but they may break when integrated with other components. So your login page might work individually, and you have tested your login page, you have tested your compose module, you have tested your outbox module. All these things you have tested, okay? But when you are trying to integrate it as a single module, it may so happen that they might not work properly. So that is why integration testing is one of the important test in your software testing paradigm, which will help you in trying to have those integrations being done across the modules, which will help you in trying to check the readiness of your software development or your product. Okay. With integration testing, testers, the persons who are trying to test the softwares or your applications are called as testers, and then these testers find defects that may be due to the code conflicts between your software modules when they're integrated with each other. It could be, as I said, there might be different programmers who are working on different modules. There might be some code conflicts. So the job of your tester will be to have those bugs being identified when the integration between the different modules is happening. So what are the conflicts between the software modules happen? What are the reasons, you can say? Incompatibility between the subsystem versions, okay? And then data format conflicts or different processing logics being used by the different programmers or the developers who are trying to develop the same system or the software. Now, what does your integration testing do? Your integration testing actually pinpoints the communication issues between these software components, right? As I said, your login page might work perfectly, but then when it is integrated with your inbox or your compose page, it might not work. Your login page should give you the landing page of your Gmail, right? If you're taking up the example of your Gmail, but if it doesn't do that, then there is a bug, there is a flaw in your application integration, right? So your integration testing basically pinpoints those communication issues between your software components. Now, integration testing occurs after unit testing and before your system testings. So there are 4 levels of testing, you can say. One is your unit testing, that is individually the modules or the units or your components are tested. That is called your unit testing. And then you have your integration testing, wherein 2 or more modules are integrated. And then they're trying to check the functionality, whether the functionalities is working fine or not. That is your integration testing. And then you have your system testing as a system whole, whether it is actually defining the purpose for which the system was built or the application was built. And then you have the acceptance testing. These are the 4 levels of your software testing paradigm. Now, more on your integration testings, we will see the importance of your integration testings, why exactly this integration testings is required. So, identifying and fixing any issues arising during testing can provide users with a reliable and seamless experience. Any person who is trying to use your product or your services or your applications would want error-free and bug-free environment to work with. Nobody wants bugs, nobody wants issues, nobody wants problems when they're trying to have your products being experienced, right? So the importance of your integration testing includes that it is essential to make sure that individual software modules created by different developers with different understandings and programming language function together seamlessly. Obviously, as I said, if there are 4 modules in a system or a software, and each module is being created by different developers who have different understandings and who have different programming logic, bringing that together to work as a whole, the system or the functionality is actually difficult. So your integration testing will help you in trying to fix the compatibility or communication between these essential components, you can say. Okay. And it is needed when client requirements change during module development, as these new aspects might not have been individually tested. Obviously, you would have created the modules with specification A. Now the specification A has changed to A 1.0. Now, based on the client requirements, you have changed some of the aspects, and that needs to be individually tested as well, right? And integration testing has to be considered based on the newly added specifications which the client has done. So your integration testing will help you with that as well. And then it is used to identify the bugs that may arise in the interactions between your software modules and the databases. And then it will help you in trying to discover potential issues that might occur in external hardware interfaces. Also, your integration testing will help you mitigate problems caused by insufficient exception handling. Now, coming to the differences between your unit testing and your integration testing, right? As I said, your software testing has 4 levels. One is your unit testing. The first one is your unit testing. The second is your integration testing. The third one is your system testing. And the fourth one is your acceptance testing. Now, coming to the difference between your unit testing versus your integration testing, I said that there are 4 levels of your software testing. One is your unit testing, first one is your unit testing, the second one is your integration testing, the third one is your system testing, and the fourth one is your acceptance testing. So, your unit testing is a white box testing process. When we say white box testing process, the design, the structure, and the implementation process of how the unit is being built or the functionality is being built for that module or the component is known by the tester who is trying to test your software. Okay, but in your integration testing, it is a type of black box testings wherein the functionality, the design, the structure, and how it has been implemented is not known by the tester. And your integration unit testing is performed by the developers, your integration testing is performed by the testers. Your unit testing helps in finding defects, is easy, as each unit is tested individually, right? As I said, login page, whatever errors it has in the login page, it is trying to detect those errors and we are trying to fix it in that module itself. Finding defects in your integration testing is hard, as we are trying to integrate different modules and then we are trying to test the functionality together whether it is working properly or not. Hence, trying to detect in which module the issue happened or the bug happened is quite difficult when we are trying to perform your integration testing. Your unit testing is always performed first before going through any other testing process. Obviously, when you have your module or your component being ready, then unit testing is the first level of testing which is undergoing for your software development. And then your integration testing is performed after your unit testing and before your system testing. That is the sequence of the levels of testings in your software testing as I just discussed now. And then developers are aware of your internal design of your software during your testing, as I said. That's why it is called as your white box testing process, right? And then here testers are not aware of your internal test design of your software. As I said, it's a black box testing process wherein they don't know the internal structure, the design, and how it has been implemented. So that's the difference between your unit testing and your integration testing. Now, coming to the difference between your integration testing and the third level of your testing, that is your system testing. So, your integration testing, it ensures all combined units can work together without errors. That's the actual outcome of your integration testing, that you're trying to interconnect all the components and then you're trying to check on the functionality whether the components are working together well or not, right? So, your integration testing, you're trying to ensure whether the combined units are working together without any errors or not, right? Whereas your system testing, you're ensuring that the total build fills the business requirements and the specifications. The purpose, the specifications, or the purpose for which the system was built, the software was built, or the application was built, whether it is fulfilling or not, is what is being tested or ensured in your system testing. Your integration testing is your black box testings, as discussed. The internal structure, the design, the implementation is not known by the tester, but your system testing, it is a combination of white box testing, black box testings, also called as or a gray box testing, which is a combination of white box and black box testings, wherein some of the specifications, some of the internal structure, some of the functionalities is known by the testers, you can say. And then your integration testing does not fall in the acceptance testing class and performs functional types of tests, right? If you have functional types of tests, like if you have a login page, the only thing it has to do is it has to take up the input as the name and the password and provide you with the landing page. That is your inbox page in case of Gmail, or in case of e-commerce websites, it needs to land you to the product pages, right? But whereas in your system testing, it falls in the acceptance testing class and performs functional and non-functional tests also. When we say non-functional tests, it is based on the scalability, the maintenance, the availability, the reliability. So based on these non-functional criteria also, you are trying to check the system. And then it is level 2 testing, integration testing, and your system testing is your level 3 testing. And then your integration testing identifies majorly your interface errors Obviously, since you're trying to interconnect the different modules or components, it is trying to focus more on your interface errors, whereas your system testing identifies your system errors. Now, let's look into the benefits of integration testing, right? All this while we were talking about what exactly are integration testing, what is the difference between integration testing, unit testings, and your system testings. Now, integration testing is essential to identify the potential defects that may occur when integrated components interact with each other during your testings. So, when you are trying to integrate your components or your modules, now you need to see how the interaction is happening, right? And based on those interactions, you are trying to identify whether there are any defects, whether there are any bugs, or whether it is running smoothly based on the functionalities. You need to check that, right? So that is what you are trying to do with your integration testing. So your integration testing is very much essential, as it is helping you to identify the defects which may occur when the integrated components are interacting with each other when you are trying to test those components. It makes sure that integrated modules work correctly as expected, right? After you have identified the potential defects or the errors, what's the next step you do? You try to fix those errors, right? Or fix those bugs. So, with the help of your integration testing, you are trying to make sure that the integrated modules work correctly as expected based on the functionalities for which they are created or generated, right? And then it is a quick testing approach. So once the modules are available, the testers can start testing them, right? So you have module A and module B up and running. You have finished your unit testing done for your module A and module B. You can combine these two modules and you can quickly have your integration testings. You, with the help of your tester, you will be able to start testing your module A and module B. You don't have to wait for the complete modules to be created, developed, and then you are trying to integrate the whole of the modules, and then you are trying to test them, right? So it is a quick testing approach. So once the modules are available, the testers can start testing them. Now it detects all errors that are related to the interface between the modules. Obviously, when you're trying to integrate it, you are trying to have those interfaces, interconnections, communications, how it is happening. You're trying to test that, right? So it will detect all the errors that are related to the interfaces between the different modules or your different components. So it helps modules interact with the third party tools or your different APIs if required. You're creating an application which requires the integration of third party tools or different APIs to be used. It will help you in trying to have those modules interact when properly when you are trying to test with the help of your integration testing. And then your integration testing is more efficient because it covers a large system volume, and then it increases the test coverages and improves reliability of your tests. Since you're trying to integrate modules and then you're trying to test, the it improves the reliability of your test, and you're trying to fix the defects which you have encountered, and then hence the reliability will increase, right? It is suitable for simple and small size systems with low levels of dependencies among software components, right? It does not require planning beforehand. Obviously, planning is not required. So it is easy to set up since all modules are integrated simultaneously, and management and coordination efforts are minimized since there is only one major testing phase. So these are some of your benefits. The first main benefit which you need to remember is that it will help you in trying to identify the potential defects that may occur when you're trying to integrate components which are interacting with each other based on the functionalities for which it was created for, right? Now, coming to the different types of your integration testing, there are two types of integration testings, two main types actually. That is your big bang approach, and then you have your incremental approach, right? So we will look into detail what exactly is your big bang approach, your incremental approach, and we will see what are the different advantages and disadvantages of these two, right? Further, your incremental approach is classified into bottom up approach, you have your top down approach, you have your sandwich approach. We will see that in detail in the upcoming slides. Now, what exactly is your Big Bang integration approach? Your Big Bang integration testing approach is in which all modules are integrated and tested at once. That is, you have completely created the system or the application, and you have integrated that system, and the system as a whole or an application as a whole is what you are trying to test as a singular entity. That is your Big Bang integration, right? Wherein all modules are integrated and tested as a one module. And then the integration process is not carried out until all components have been successfully unit tested. As I said, say for example, you have 4 modules to complete a system, right? So your Big Bang approach is all the 4 modules are completely created and unit tested, and then you're integrating all the 4 modules and then as a single entity, and then you're trying to test that as a system as a whole. So that is what is your Big Bang integration testing. Now, what are the advantages of your Big Bang integration? It is suitable for simple and small sized systems with a low level of dependencies among your software components. If there is low level of dependencies between the integrated components and a small size system like four modules or 2 modules are integrated together, then this is Big Bang integration approach is a apt approach for those kind of applications which are being built, right? It requires little or no planning beforehand. Since it's a small size system, you require no or less planning is beforehand is required. Easy to set up all the modules and integrate it simultaneously. As you have less number of modules, it is easy to integrate all the modules and test them. And then management and coordination efforts are minimized since there is only one major testing phase, right? That is your integration testing phase. So these are the advantages of your Big Bang integration. Now coming to the disadvantages of your Big Bang integration. So, the first one is it is costly and time consuming for large systems. Say you have 10 components or 10 modules which you are trying to integrate. Say if you are taking a e-commerce website, you have a login page, then you have the landing page, then you have the customer is trying to browse the products, and then it is trying to add it to the cart, and then you have the payment gateway, the checkout process, and then trying to track the order, right? These are some of the scenarios which I'm trying to give when you're trying to build an application. If you have these set of modules like large systems which you're trying to build, then you are trying to wait till the modules are created and then you're trying to integrate it as a single entity. That is actually time consuming and it is costly. You'll not be able to start your testing till the completion of all the modules are being completed. And then waiting for all modules to be developed before testing also means late defect detection, right? Since it is time consuming and then later you are integrating everything and then you're trying to test for the defects, then it is late defect detection and hard to isolate and pinpoint bugs in definite modules. Now you have integrated 10 modules. Now you have got defects, okay, bugs, errors. Now you need to figure out in which module was that error, whether it was in module A or whether it was in module C or D. It is actually difficult because you've already integrated it. So trying to pinpoint where that bug or occurred is actually difficult in your Big Bang approach. And then hard to debug due to the complexity of the multiply integrated modules. As I said, since it is complex, since you've integrated everything and then you're trying to test it, it is the complexity is increased, right? Now, what are the best practices when using your Big Bang testing? First thing is you need to clearly define the interactions between each unit or your functions before testing to minimize missing defects. This is one of the approach which you can take. Okay, the second one is perform extensive logging for more accurate fault localizations. When you're trying to have your unit testings done for each module, try to log all the errors which it has. Okay, so that you will be able to figure out if there are any duplication of errors which happens when the integration is happening, and then perform Big Bang testing for simple applications. So these are the best practices which you can undergo for your Big Bang testing. Now coming to your incremental integration, right? It involves grouping and testing 2 or more modules with closely related logic and functionalities as a starting point. okay, two or more modules which have the same related logic or your functionality, you are trying to club them together, and then that forms the building block of trying to start your integration testing. That is an incremental way of trying to have your integration testing being done. So it progresses gradually to other groups or modules rather than testing everything simultaneously. It continues until all modules have been integrated and tested. Like say for example, you have module 1 to 10. Now you have integrated, you have developed module 1 and 2. So you are integrating module 1 and 2 and then you are trying to check the functionality of it. Say module 5 has the related logic and functionality of module 1 and 2. So you are integrating module 1, 2 and 5 and then you are trying to check the functionality. So this is your incremental way of trying to have your integration testing being done. So it represents a strategic approach, contrasting with the all-encompassing nature of your Big Bang testing, right? Now coming to the advantages of your incremental integration. Now, early defect detection compared to Big Bang testing, since the modules are integrated and tested as soon as they are developed. As soon as you have developed one or two modules, you are trying to integrate them and then you are trying to test them. But whereas in your Big Bang approach, what are you doing? You're waiting till the modules are created uh, and completed, and then you're trying to integrate all the modules as a whole and then you're testing. So, detection of defects is in the later stage in your Big Bang approach. But in your incremental approach, early detection of defects is happening since you are integrating the modules as soon as they are developed. And then your quality analyst teams do not have to wait until all modules are available for being tested. As and when, as I said, module 1 and 2 is ready, integrated and then tested, right? Okay, easier fault localization since the modules are tested in relatively smaller groups, as it's smaller groups 1 2 and then 1 2 and 5, you're just testing in a smaller groups, and then you'll be able to figure out which module has bugs or which module has faults, right? And then the strategic nature of incremental integration testing can be leveraged by the project management. For example, you can say that your QA managers can choose which module to test first based on the priorities, based on the urgencies, and whatever resources which are being available. Based on that, you will be able to take up decisions like which modules have to be tested first and which modules go next. And then the risk of encountering failures is also significantly reduced since issues are addressed early on the route, right? You have unit tested, and then the modules you're integrating is of similar logic and functionality, and then you're trying to check those errors. So risk of failures are significantly reduced with this approach. Now coming to disadvantages. So one of the disadvantages is it requires thorough planning beforehand. As we said that quality analysts need to have a plan like which module goes first, which modules are integrated together and goes first. So it requires a little bit of planning beforehand. And then the total number of tests to perform can be huge depending on the scale of the project. If it is a large scale project, the number of tests, the number of integrations it is going on, the number of iterations it is going on will actually be more, requiring significant organizational resources. And then coordinating a large integration testing project with this approach may become very complex. And then it requires a complete definition and logic of a system before it can be broken down into small units, right? That's true actually. You need to actually know what the system is doing. You need to know the functionality of it. You need to know the logic behind how the system is going to work. Only then you will be able to break down into different modules, or which module will be integrated with which module, the decisions can be taken there, right? And then in early stages of your project, certain system functionalities may not yet be available, leading to the dependencies on stubs and drivers. We have something called as stubs and drivers. What exactly are these? These stubs and drivers are mock components, dummy components, you can say, that will be used as substitutes for your actual components. Say, for example, you want to test module 1, 2, and 5 together. Okay. Now, module 2, 1 is ready, up and running, module 5 is ready, up and running, but you do not have module 2. So, with the help of your mock components, that is your stubs and your drivers, which will replicate the functionality of your module 2. You'll be able to combine or integrate these components, and you will be able to actually test those components, right? So the lack of system functionalities in earlier stages, if not carefully documented, may even lead to system blind spots later down the road. Okay, so you need to actually check on the functionalities at the earlier stages, and you need to document them as well. Now, coming to the further classifications of your incremental integration approaches, right? We said that there are three smaller approaches for your incremental integration. That is your bottom up approach, your top down approach, and your hybrid approach, also called as your sandwich approach. Now, what exactly is your bottom up approach? Performing testing for low level components first, then gradually moving to your higher level components is what is your bottom up approach. And then your top down approach is perform testing for your high level components first, and then gradually you move down to your lower level components is what is your top down approach. And your hybrid approach is you're combining your bottom up and your top down approach together. We will see in detail these approaches. So, as we said that your bottom up approach is you're trying to test the bottom levels, that is your lower level units first, followed by your upper level units. So, in this approach, the test drivers are needed to simulate higher level units, which may not be available during the initial phases. So, there might be functionalities which you want to test of your higher level units. That is where the functionalities of your stubs and drivers come into picture. Those are your mock components which will actually replicate the functionality of your higher level components, right? So you, with the help of your drivers and stubs, you will be able to mock those functionalities, and you will be able to test your lower level components, right? So what are the advantages? Fault localization is much easier based on the application's control flow. And then this approach allows you to develop and test simultaneously to meet your customer specifications efficiently. So this approach allows you to develop and test simultaneously to meet your customer specifications efficiently. So with the help of your lower level units, you're trying to actually meet your customer specifications, and you're trying to incorporate your customer specifications and see whether it is trying to work properly or not. And then by the end of your testing cycle, you can quickly identify defects between the interfaces, right? As I said, you're trying to first check your bottom level units, and then you're trying to check your upper level units. So if there are any defects which are there, you will be able to quickly identify those defects between those interfaces. Now it has few drawbacks also. So what are those disadvantages? So all modules except the top control need to have test drivers. As I said, stubs and drivers, stubs for your lower level components and drivers for your higher level components. So all modules except the top control need to have test drivers. And then modules that control the application flow are tested last and may contain defects, right? So individually you're trying to test the lower level modules, and then with the help of your drivers, which are mock applications which replicate the logic, you're trying to have those functionalities tested. Then your higher level modules are tested individually, and then you're trying to integrate your lower level modules and your higher level modules, and then you're trying to have those integrations being done, the testings being done. So modules that control the application flow are tested last. That is your higher level modules, right? And may contain defects. Your high level modules may contain defects. So this is one of the example you can say, like you have your user interface layer, you have your business logic layer, and then you have your database layer. So bottom up approach is when you're trying to have your database layer functionality being tested first, and then you have your business logic layer being tested next, and then you have your user interface layer being tested in the final stages. So if you have any problems in your top level layer, it will actually delay the process of your testing, because it has to detect the bugs in your higher level, which will hamper the functionality of the system as a whole. Okay, now coming to your top down integration testing approach. This approach involves testing your top level units first, and then you are testing your lower level units, which are tested step by step, right? Okay, test stubs are needed to simulate lower level units which can't be available during your initial phases. So you have the functionalities up and running for your higher level components. But what about your lower level components? They might not be up and running. So you are trying to use stubs, which are mock components, and then you are trying to have those testings, integration testings being done, right? So what exactly are the advantages of it? It requires little planning. Okay, it is convenient for small systems, right? Wherein two or three modules are there, lower level modules are there, and you're just trying to integrate that. It is convenient for smaller modules. So it covers all the modules, right? So these are the advantages of your top-down approach. What are the disadvantages? It is not recommended for large scale systems as fault localization is complicated, right? So you will not be able to know where exactly the fault lies, whether it is in the top level components, integrated between the top level components, or it is in the lower level components. Okay, as the prerequisite of this approach is completing all modules, the testing team remains extremely time bound when executing the test. So, the time limitations happen there, right? So, that is one of the disadvantages of your top down approach. So, one of the example here you can see that with the top down approach, testers start with the higher level modules and then gradually move to your lower level modules. So, here my higher level module is module A, module B, module P, and module T are my lower level modules, and even these are my lower level modules, right? So, what are we trying to do over here? So, for example, the diagram illustrates the modules required for a ride booking application, right? So, module A is your user authentication, and then module B is your driver information. Okay, so we have the user authentication functionality being defined in your module A, and then module B has your ride booking functionality being defined here. Now we have a stub DR, that is the driver information, right? We do not have these lower level module being defined. So what do we use? We use the stub over here, right? Which will replicate the functionality of your driver information. And then we say that we have payment processing module, right? We have a payment processing module, and then we have payment by cash module, right? Which is ready, okay? But then we don't have payment by card, okay? That is payment by card or debit card or so. So what do? We create a stub over there which will replicate the functionality of it, and then we start testing. And then we do not have the functionality of ePay also, right? We will create a stub for it, and then you have your module T, which is up and running, that is your ride tracking. So as you can see over here that you have a few of your higher level modules being ready, but you don't have your lower level modules for which you require the stubs. And then with the help of your stubs, you're trying to have those higher level modules being tested, right? But then this is actually a little bit time consuming, because when the actual module is being created and then you're testing again, there might be some defects. So what exactly is a sandwich approach? So this approach is known as hybrid testing, right? Sandwich approach, also called as hybrid testing, which is the combination of your top down and your bottom up testing approach. So in this strategy, what exactly happens in this? The low modules are tested in conjunction with the higher level modules and vice versa. Okay, so lower levels along with your higher levels and higher levels along with your lower levels are together tested. So this strategy uses both your stubs and your drivers. If your higher level modules are not ready, up and running, you use drivers. If your lower level modules are not up and running, you use your stubs, and then you try to integrate those components, and then you try to have your integration testing being done. So that is what is your sandwich approach. So what exactly is your advantages? So it allows parallel performing both top down and bottom up approaches. So um, you are having the functionality of your top level components being up and ready, as well as your bottom components being up and ready as well, right? Parallelly you're trying to perform those operations, and then it is suitable for your large scale applications. So what is the disadvantage? Is it is expensive approach, right? Why is it expensive approach? Because if the top level components are not there, you are trying to use drivers. If the bottom level components are not there, you're using stubs. So obviously it is an expensive approach over here, and then it is not suitable for your small sized applications, right? So that's the disadvantage of your sandwich approach. Now, how exactly is your integration testing being done, right? So we said that your integration testing is critical in your software development, right? And it will ensure all your applications components perform correctly. Now, to make things easier, firstly, what you're trying to do is you prepare a test integration plan and the required framework. First thing you do is you try to create an integration plan. You try to have a required framework on how the integration testing has to be done, right? And then you try to decide on the testing approaches, right? We saw the different testing approaches. Big bang approach, you have your incremental approach, which is further classified into your bottom up, top up, and your sandwich approaches. So, based on your plan, you are trying to decide on your integration testing approaches. And then you design the test cases, the scripts, the scenarios. What is going to be the input? What exactly is the output going to be? What is the expected results? You're trying to design that. And then you deploy the chosen components to run the integration testing, right? Which component is to be integrated with which component, you try to deploy them, and then you try to run those scenarios with the help of your integration testing. After you have done that, the next thing you need to do is you need to track and record the testing results. If there are any errors or bugs, or if the test goes bug free, also you have to record them, right? So that you need to record, and finally you must repeat the same process until the entire system is tested, right? Maybe you are doing integration testing to module A and B, but the whole system is module A, B, C, and D, right? So you need to repeat that process of planning, trying to have your test approach, having your test cases being ready, and then choosing the right components to run your testing scripts, and then track and record your testing results. Now, what exactly are your entry and exit criteria for your integration testing? Your integration testing has both your entry and exit criteria that one should know before you have started your integration testings. So, what is your entry criteria? The first one is your approval. So, what do you mean by approval? The integration test plan document has to be signed off and approved, right? So, so as we said, the first thing is your integration plan, testing plan has to be created, right? But after you have created your test plan, the first thing is you need to get the test plan approved and signed off by the managers or the persons who are responsible for these testings. And then preparation, that is integration testings can, the test cases have to be prepared, the scenarios, the scripts which we said. So the preparation has to be done, and then the test cases has to be prepared. Like as I said, what is the input going to be, right? What is the outcome, expected result it has to be. So that has to be prepared. And then data creation, test data has to be created, right? So if you're trying to have your login page being tested, right, you need to have a couple of valid test cases wherein the username and password has to be matched, wherein the username and password has to be not matched, unmatched, you can say, right? So that test data has to be created. And then unit testing has to be done for each developed module component is complete. As we said that integration testing is the second level of testing. So you need to have your unit testing being completed before you start off with your integration testing. And then dealing with defects, all the high priority and critical defects needs to be closed. And then test your environment, that is you need to have your test environment setup being done for your integration testing. So these are the steps you need to follow as your entry criteria for your testing before you have started your integration testing. What is the exit criteria? So all the integration test cases on different parameters have to be successfully executed. As I said, the test data what you have for login page, not only it needs to have the success data, it needs to have the failure data as well. So all the different parameters have to be successfully executed for the test cases. Your success, your failure, what exactly happened, all that has to be taken care of. Okay, all the critical and priority P1 and P2 defects are to be closed, and then the test report has to be prepared, right? So this is actually important. The test report has to be prepared, which will help us in trying to analyze what went wrong, where it went wrong, and how the bugs were fixed, and whether the system is functioning properly based on the logic for which it was created or not. We are talking about integration testing, right? So, is it that integration testing is to be done manually? The answer is no. we can have your integration testing being automated as well. There are different automated integration tools which can be used for having your integration tests being automated. So we will see how do we automate your integration testing. So choose an automation tool. As I said, there are n number of automation tools. We will try to discuss in the upcoming slides what are the different tools which are there which will help you in having your integration testings being automated, right? Choosing a tool aligned with your specific use cases. Okay, so as I said, there are n number of tools based on your use cases. You can use between the different choices you have for your automation tools, right? Ensuring ease of use for your team, right? So that choose a automation tool which will be easy for your team members also to use, verifying that the tool offers a return on investment within your defined time frame, and then considering end-to-end testing solutions such as test sigma, your selenium, or apm as your potential options. Some of the options for your automation testing tools is your test sigma, selenium, etc. Okay, and then your next thing for automating your integration testing. First thing is choice of automation tool. The second thing is you need to create your test scripts, right? So develop test scripts to emulate your software component integration. Now, what does your test script need to include? It needs to include your test data. It needs to include what are the defined actions, what are the expected results it needs to have, whether also it needs to include the reporting mechanism with the scripts, right? So you need to develop test scripts, and these test scripts needs to include your test data. It needs to have the defined actions, what are the expected results needs to have, as well as the reporting mechanisms. And then you use the scripts to assess the components and you analyze their status post your test. So you try to give these test scripts to your tool, and then later, based on your reports, you will try to analyze the status post your test. The next thing is, after you have created your test scripts, you run your test scripts. After the test scripts are in place, use the automation tool to run them. They will assist in discovering any flaws as soon as possible. So they will try to run the script and try to get you if there are any defects or errors or bugs in your integration testing. And then the next stage is analyzing your results, right? Analyze the results after executing the test scripts. As you know that your test scripts include what exactly is the data you're giving, right? As well as the expected output it needs to have, right? And then desired result, you can say, right? So with the help of that, you will be able to analyze the result after executing the test scripts to find any identified problems or flaws in your test cases, and then repair the problems and repeat the testings until all the components are properly integrated. So there are 4 steps. One is you need to choose the right tool, right? And then you need to create your test scripts. Third one is run your test scripts, and then you need to analyze the results. So that will help you in automating your integration testing. As I said, we'll look into some of the tools, right? So there are a lot more integration testing tools. We've listed a few over here. Like you have your Selenium, you have your PyTest, RFT, Citrus, Smart Integration Test Escalator. You have your Rational Integration Tester. You have your Steam. These are some of the examples of your integration testing tools. We will see a few of them, right? So your automated tools, what are they? They are actually now a great impact on your integration testings for various modules on your software applications. So this will help you in trying to simplify the process and make the process more agile, right? And then some of the testing tools, as I said, Selenium is one of your automated testing tools. So what exactly is Selenium do, or what are the features which Selenium has? So you can say that Selenium is a leading large-scale open source test automation framework, which will help you in trying to automate your integration test suites for your web applications. Okay, and then some of the important features which your Selenium have, which will help us in trying to pick Selenium as one of the best choices, is it supports different languages, like you have your C hash, you have your JavaScript, PHP, Java, Python, Ruby, Perl, right? Different language support it gives. And then it runs on various system environments, like you have your Mac, you have your Windows, Linux, and it works on most of the popular browsers, like you have your Firefox, Chrome, Safari. And then worldwide 3 consortium standardizations makes testing and scripting easier in your Selenium. Also, it allows running parallel tests with different hybrid test data. So these are some of the important features which make Selenium a top popular tool for your automation integrated testing. Now coming to PyTest. This is also one of the automation tool. So the PyTest is widely used for writing and running test codes for Python automation testing, right? PyTest, Python automation testing. So it can also scale up and work perfectly while testing complex libraries and your applications. So what are the features which your PyTest will make it a good choice for your integration testings? First thing is your PyTest can reduce the overall testing time by running tests parallelly. Okay, you will be able to run the test scripts parallelly, which will reduce the overall testing time. And then if test files and features are not directly indicated, PyTest will actually automatically define them. You don't have to explicitly worry on that. So it has an inbuilt feature wherein it will try to take up the features and files automatically. And then PyTest has built-in command line support and test discovery support as well. Okay, so these are a few features which will make PyTest as an excellent choice for automated integrated testing. Okay, now coming to RFT, your RFT stands for IBM Rational Functional Tester. So it is one of the popular tool that makes creating scripts which are similar to that of a human tester. Okay, and then it enhances your testing experiences, and IBM offers different software solutions that you can integrate with your RFT automated testing tool. So what are the couple of features which RFT provides? So storyboard mode simplifies editing and test visualizations, especially through your screenshots. And then your RFT also has applying recording tools that makes testing scripts easy. And then data-driven testing for the same series of actions using varying test datas. And then for collaborative software development lifecycle management, it allows integration with other softwares as well. So these are some of the features which your RFT provides. And then coming to another testing tool, LDRA, it drives the market for software tools that can effortlessly automate code analysis and testing for safety, mission, and business critical needs. LDRA will help you in that. And then what are the features it provides? Customer focused certification services it provides, consultancy offerings it provides, and it is a tool to achieve early error detection and eliminations, and then tracing requirements through dynamic and static analysis to unit testings is one of the feature it provides, and then verification of various hardware and software platforms also this testing tool will actually provide. Now coming to another testing tool, that is Citrus. So it is a test framework written in Java that assists in your automated integration testing of message-based application and your data formats. So what data formats it validates? It validates your JSON, XML, as well as your plain text messaging request and response data formats it validates. And what are the features it has? It is open source and licensed under Apache License 2.0. And then set sequence of messages. It creates error messages. It helps you in managing your message header validations. It helps in sending and receiving your messages. So these are some of the features of your Citrus. Now this is an example of your integration test cases, right? So as you can see, we have 4 things over here. So this is how the test cases are written actually. You have the test ID, you have the test description, you have the input, what is the expected result it is going to have. Okay. So this is my TS is my test case 1, test case 2, test case 3, and test case 4. So what exactly is the description I have in my test case 1? So testing integration between payment gateway and the booking system. So what is the test case I'm doing? I'm trying to test the integration between the payment gateway module and the booking system module. So what is the input I'm going to have here? That is user books a service and makes a payment, right? So that is how I'm trying to have the integration between my payment module and my booking module, wherein the user books a service and it is trying to make a payment for. So what is the expected result it needs to have? That is payment is processed correctly and the booking is confirmed, right? So this is what is the expected result going to be. Now this needs to be tested for the scenario. Now coming to my test case 2, test integration between the messaging system and notification system. So 2 systems are being tested over here. or you can say modules. One is my messaging system module and the other one is my notification module, right? So what exactly is the input I'm going to get over here? Here the user is sending a message and receiving a notification, right? So what exactly should be the expected result over here? That the message has to be delivered appropriately or correctly to the correct user, right? So the message is delivered correctly and the user receives the expected notification. It should not be that user A message is going to user B message, right? The notification is going somewhere else. So this needs to be tested appropriately. Now coming to your test case 3, that is your test integration between the billing system and your accounting system. So two systems, your billing system and your accounting system being integrated and being tested. So what is it tested for? It is tested for system generated a bill and sends it to your accounting system. So your billing system has generated a bill and that bill has been sent to your accounting system for processing. So what should happen here? What is the expected result over here? That is, the bill is correctly processed and recorded in your accounting system, right? And then what is my test case for? Test integration between the search engine and the recommendation engine. Two modules, my search engine module and my recommendation engine module, right? So user performs a search and receives recommendation, right? User is performing a search and it is receiving the recommendations which it is searching for, right? So the search results and recommendations are accurate and relevant to the user's search query. So this should be apt. It should not be like the user is trying to search for product A and the recommendation is for product B, right? So this needs to be tested here. So this is a sample scenario which we gave as an example for your integration test cases. Now, what exactly your integration test cases focus on? First thing is it focuses on the data transfer between your modules, components that are already unit tested, and how the interface is happening between the modules and how the interconnection or links is happening between these integrated components. Now, say I'm taking another scenario of a LinkedIn application, how the test cases can be generated for, right? So, first thing is verifying the interface link between the login and home page. So, I have two modules over here. One is the login page and the other one is my home page. So this means that when a user enters the correct login credentials, it should be directed to the home page. This is my test case, right? So what is my input over here? The user is entering the correct login credentials. So what should be the expected output over there? So it should be, the expected output should be there, that it needs to be directed to the home page. So I am been testing over here, right? Integration testing between my login module and my home page module. Now next test scenario, verifying the interface link between your home page and your profile page. Two components again over here, my home page and my profile page. So when the user selects the profile option, the profile page should open. So what is the input over here? The user is selecting the profile option. So what should be the expected output? The profile page should open. Okay. Now verifying the interface link between your network page and your connections page. So again, two modules, network page and your connection page. On clicking the accept button of for received invitations on your network page, it should show the accepted invitations on your connection page once clicked, right? So that's one of the option which your LinkedIn profile gives, right? So verify the interface link between the notification pages and say congrats button, right? So on clicking the say congrats button, the user should get directed towards the new message window. So these are some of the test case scenarios which your integration testing is doing. So here you can see that two modules are tested for some test cases and the expected result which it needs to show for. Now coming to another test cases for an e-commerce website, right? There can be several integration test case scenarios over here, right? Verifying the interface link between get started page and a login page. So two modules, get started page and a login page. Once a user enters their credentials, it is expected that the system will check if their credentials are correct. And if they are correct, the user will be directed to your get started page, right? So you have your get started page, checking and login page credentials are correct, get started page is popped up, right? So this is one of the expected result it needs to have. And verifying that the user inputs their information into the form, the right data is sent to the right place in the right format, right? And then verifying that the changes to the user profile are reflected in the order history and your confirmation mails. If some profile has changed, like I might edit my phone number or so, right? So it has to get updated in my history or in my profile details, and then a confirmation email has to be reached to me that this edit has happened, right? So this is one of the functionality which an e-commerce website will have actually. and then verify that products are marked as out of stock when their inventory reaches zero, and that they become available again when it is restocked. Obviously, there's no point in having a product whose inventory is zero, and people are searching for it and trying to add that to the cart, right? So this is one of the functionality wherein the inventory reaches zero, and then it is marked as out of stock, and then they become available again when it is restocked. Now, a few more test cases scenarios for your e-commerce website. You can say that verifying that shipping information is accurately provided to users and tracking updates are correctly displayed. And then one more scenario, you can say that verify that the selected products are correctly added to your shopping cart and that the final order is successfully processed, updating inventories and generating an ordered confirmation. So there are different integration components over here. That is, your cart is updated, the inventory is updated, the order is generated, payment gateway is enabled, payment process is happening, checkout is happening, right? So you are trying to create test cases for these integration tests. Now, coming to the test case for integration application, wherein we are trying to take a case of a banking application. We took an scenario of an e-commerce application, we took a scenario of LinkedIn application for you to understand how the integration test cases are being written, how the test cases and the description and how the expected output is being verified for. So, some of the test cases you can say that verifying if the balance of the user is detected by the correct amount that they sent, and if the balance of the recipient increased by the correct amount after accounting for the fees. Like if the debit and credits are happening appropriately based on the user's interactions with the credits and debits for its accounts, right? And then verifying the transactions, that is your deposits, withdrawals, accurately update the account balances and reflect your transaction history. And then verify that your account statements are generated correctly and display the transaction history and interest earned. Verify that the data consistency is maintained and transactions do not lead to unexpected conflicts and errors. And then there are few more test cases which you can add for your banking applications, assuming that the bank has bonus point systems, and integration can verify if they have increased bonus points after the certain activity has been recorded, right? So these are some of your test cases for your banking applications. You can have more test cases for your banking applications, as banking applications is a very critical application, and there are a lot of security aspects which needs to be checked when you're trying to have your test cases being written for your banking applications. Now, coming to what are the challenges which are there for your integration testing. The challenges, you can say that integration testing management is complex sometimes because of various factors, like you have your databases, you have different platforms, you have different environments. So it can be very challenging. It can also be challenging because there are different developers who are working on different modules which have different mindsets as well, right? And then integrating a new system into one or two legacy systems requires a lot of change in testing efforts, right? So that's what you're trying to do. You're integrating a system which requires a lot of change, and testing efforts are actually more when you're trying to do that. And then compatibility between system developed by different companies is quite challenging for programmers, right? Trying to use different tools, different frameworks for your applications which are being created by different companies, right? That will be challenging because the compatibility issue would come there. Okay, there are many different paths and permutations to apply for testing integrated systems. As we saw the testing scenarios, there are a lot more things which you need to have your thought process move about so that you can get the system up and running. And then cost is more because of manual testing. Developing and performing integration tests can be expensive, right? So you are trying to find errors, you're trying to fix those errors, you're trying to integrate that system, you're trying to integrate smaller systems, and then you're trying to integrate two or more modules, and then the complete whole system as a whole, you're trying to test that. So you can say that it is integration testing is quite little expensive because of manual testing. Now that we have a lot of integration testing tools which will help us in trying to automate the integration testing, that will actually help us. Now, what are the best practices for your integration testing? We have been telling about planning your integration testing. The first thing is your plan. Determine what and how you will test to guarantee you're testing the proper items and avoiding delays. First thing is that. And then second thing is start early. Don't put off testing till the conclusion of your development process. Begin testing as soon as possible to uncover problems before they become more challenging and expensive. Like if you have two modules being created, right, try to test them. Don't wait until the whole system is ready or you have two or more modules being up and running, right? So start off early. Use real test data, right, to detect flaws. They may not be seen with manufacturer simplified data. So test data should be realistic and indicative of the data your system would encounter in the actual world, right? So use real world data for having your test cases data being ready. Okay, use automations. That is, automation can make integration tests more practical and economical and time consuming, and it can also eliminate the time factor as well there, right? So it can be conducted faster and more reliable than human tests and can help identify problems that manual testing cannot do. So use automations, start off early, plan. These are some of the best practices for your integration testing. Few more best practices you can say that you need to define clear objectives and expectations for your integration testing. That is, you need to understand what needs to be tested, what is the scope of your integration testing, what are the desired outcomes you need for your integration testing. That needs to be clearly defined. The objective needs to be clearly defined for your integration testing. And then the test environment, so you need to create a test environment that is more closely related to your production environment, right? So that is one of the important factor or best practices which you need to follow. And then regularly run integration tests, especially when changes are made to components or modules, to ensure new updates do not break existing integration. That is, you have found any defects or errors in your integration test cases, right? So after you have fixed them, try to run those integration tests again and again so that you will not miss out or break the existing integration tests, right? So that has to be followed. Now coming to the case study of an integration testing in an e-commerce applications, few of the test cases we did see in a banking application, we did see in an e-commerce applications and LinkedIn applications. So here we are trying to generalize in terms of your e-commerce applications. Like I'm not trying to take Amazon or not trying to take Flipkart. I'm just trying to take, say, we have a company called as ABC, and then it is an e-commerce website, a popular online retailer which is aiming to enhance your e-commerce platforms. And then the development team is responsible for implementing several features. What are the features it is trying to implement? That is real-time inventory updates, right? So as and when the inventory is reduced, it needs to check, or out of stock is there, that needs to be updated, right? And then payment gateway integration and user account management. So these are the three modules which we are trying to look into it, right? And we'll see what are the challenges, and we'll see what are the test cases which needs to be encountered. Real-time inventory updates, payment gateway integration, and user account management. These three modules is what we are trying to focus for this e-commerce application development. So what are the challenges? So multiple development teams, right? Obviously, one person cannot actually build the whole application, right? So different teams are responsible for implementing various features, leading to potential integration issues. Different teams will be there. There will be team A who will be looking into inventory updates. There will be team B and C who will be looking into payment gateways, right? So integrating them, trying to have them integrated will actually be a difficult task or challenging task. And in third party integration, the application relies on external payment gateways and inventory management systems. Obviously, payment gateways require a third party intervention tool which will allow them to have the payments being processed, right? So that will also be a challenging factor in how the third party integration is being done. And then data flow, data must flow seamlessly between the user interfaces, databases, and your external systems. The third party um, systems, your user interfaces, your own databases, how the data flows will also be a challenging factor. Now, what is your integration testing strategy which you need to have so that you will incorporate all the challenges there? So, to ensure a seamless user experience and prevent integration issues, the development team implements integration testing throughout your development process. It's not like one time you plan and then you finish off. It's not like that. You need to continuously have your integration testing throughout your development process. Every module is being developed, every module is integrated and tested. You have your integration testing being implemented and planned throughout your development processes. Now we'll take up some scenarios for your test cases. Like I said, 3 modules we are focusing on, that is real-time inventory updates. We'll take the first one. So what is the test scenario here? Ensure that inventory levels update in real time when the customer places the order. Okay, that's the scenario here. So what is the test step here? So simulate a user placing an order while monitoring the inventory database and verifying the update. That's the test step. That whenever the user is trying to uh, update the inventory levels in the real time, and the customer is trying to place the order, the inventory needs to be updated. So what is the expected result over here? The inventory level should be reduced as the customer is trying to place that product into the cart, right, and trying to check out. What it has to happen, it has to reduce one of the product from the one of the quantity from the inventory, right? So that's what the approach we use for. So inventory levels should decrease in a real time after order has been placed. So this is one of the scenario. And then the second thing is your payment gateway integration. What would be the test scenario here? Verify that payment transactions are processed correctly through the integrated payment gateway, right? So we are using a third party intervention over here, right? So what is the test step here? So simulate various payment scenarios. Like we have credit card, we have UPI Pay, right? You have Amazon Pay or something like that, right? So simulate various payment scenarios for successful payments or failed payments, and then validate your transaction records. So this is what you are trying to test there: your success, your failure, right? And then what is the expected result you're trying to have over here? Successful payments should result in order confirmation. So after you have paid, the order has to be confirmed. If it is failed, then you need to have error message that the order has been declined, right? So this is the expected output here. And then the third module which we are considering for today is user account management, right? So what is the test scenario here? Ensure that user account information is correctly synchronized between the user interface and the databases, right? So when the user is trying to create, update and delete your user accounts through the application, that needs to be changed in your database. Validation has to be done in your database. So what is the expected result over here? Changes needs to be made for that user account, and that has to be reflected and accurately in the databases. So this is the expected outcome it is going to take. So these are the test scenarios which we are trying to talk about for your e-commerce applications. So what is the outcome over here? So integration testing helps the development team identify and resolve several critical issues before deploying and the updated e-commerce platform, right? So obviously you're trying to integrate the modules, so that will help you in trying to identify the bugs and the defects, right? And actually solve the critical issues which the application is going to have, right? So it ensures that different components in third party integrations work seamlessly together, providing a smooth shopping experience for your customers. Ultimately, customer is the goal. User experience should be high when you're trying to have these applications being built for your customers, right? So what are the benefits? So early issue detection. So if you have planned your integration testing, so you'll have early issue detection, right? When you have early issue detections, then your integration testing catches issues before they reach your production, right? So after the production is done, then it is very difficult for us to go back and have the production stopped and have those issues being resolved. And then it improves your user experience, ensures that all features are integrated, they are working very good, and user satisfaction is enhanced and all that. And then cost savings, that is prevents costly errors that could impact sales and reputation if not addressed promptly. Instead of going into the production and then trying to figure out what the error was and trying to fix the errors, it is better in the testing stage itself you are trying to have those errors being fixed. So the cost saving is done there. Now coming to the summary point. Okay, so the main objective of your integration testing is actually to ensure that the entire software system works flawlessly when it is put together, right? So that's what we are trying to do over here in your integration testing, that ultimately the software has to work smoothly without errors, right? And then we said that your integration is a systematic approach wherein you have different integration test cases which will help us in trying to define the functionalities and how the desired outputs is going to happen, right? And then we saw the different types of testings, right? So we have a big bang approach testing and we have incremental testings, and we saw that your incremental testing is further classified into bottom up approach, top down approach, and your sandwich approaches, right? And then we saw some of the uh, disadvantages and advantages of all these approaches, and we saw how the test cases are being written, like test case 1, and what are the description, how the input has to be, and what is the expected result has to be. And we also saw a few of the different automation tools and its features, which will help us in trying to choose the different automated tools, as well as we saw a case study on e-commerce applications, which will help us in trying to understand whole how the integration testing will help us in enhancing the quality of the product or the service or the application which is being built.
Now that we have covered integration testing and its role in ensuring different software modules work together seamlessly, let's move on to API testing, where we will focus on testing the interfaces between these modules and external systems. API testing is generally considered automated testing, although it can be performed manually using tools like Postman. Automation allows for more efficient, reliable, and repeatable testing by writing scripts that programmatically interact with the API to validate its functionality, performance, and security. Hello learners, welcome to the session on Introduction to API Testing. First, let us understand what testing is. We all know that testing is a process or a step in the software development process, right? The steps involved in software testing are planning, analysis, design, implementation, and then the testing comes into picture, right? We'll understand what API is now. API is a software which helps the two different software components to communicate with each other. So it is an application program interface, which is very important in the communication within the organization or across the organization, right? So now this application programming interface also needs to be tested, right? That is all about API testing. Let's get started without any further ado. In this session, we will discuss about the introduction to API first, and then the introduction to API testing, and the tools and the environment setup that is done in API testing process. And then the authentication and authorization is very important aspect when we are doing API testing. Testing methods that are involved in the API testing. API testing approaches and its test cases are also discussed. Automation frameworks are also understood. And we will also understand how to test our API. The data validation and performance testing is also understood, along with error handling and security testing. Documentation and reporting is also explored. The best practices that are involved in API testing is also discussed. The difference between API testing and unit testing is brief. The challenges and the pitfalls are also explained. The ethical and legal considerations that are important when we are doing the API testing is also discussed. The future trends and the emerging technologies are also explored. Now let us understand what is API. Application program interface are the tools that facilitate the communication between two different software components by providing a predefined set of definitions, or it is also called as protocols. So all that definitions or the protocols are followed when the communication is actually taking place. APIs actually provide the set of rules, protocols, and tools that developers can use it to access the functionality and the data of another software system, service, or a platform. It is actually a structured form where the request and the response is transferred between the server and the client. So this is possible by integrating various services and functionalities into one application without having to build anything from the scratch. So as I said, you can actually incorporate or integrate a technique or a tool from a different platform to your own application. So that is the advantage of using API. So next we'll understand what exactly is API and how it works with an example. Say suppose you want to book a ride using any application that you are using, may it be Uber, Ola, or any such platform. So what are the different applications that is running behind the scenes? For you as a user, it appears as a single application. But technically, at the background, n number of applications are actually working together to make your application work efficient. So let us see what are those applications. So the very first platform or an page that appears is the user request, right? So user request is nothing but a page appears and you will select your ride or the location or the destination where you want to reach to. So that is done with the help of what? The user request. So the next API is the map API. So map API helps in actually routing your destination, the path or the route from your location to your destination. To find out the exact route or the map or where the driver is or how long the driver will take to reach your current location, all comes under this map API. Then driver matching API. So you request for a ride, you send a request to the server. So the server will now decide or try helping you with matching the drivers to your destination. So that matching or to find the drivers for your ride all comes under the driver matching API. The next one is payment gateway. This payment gateway API helps in making the payment. Once the ride is confirmed, you make the payment initially, right? It is all achieved with the help of this payment gateway API. Next one is real-time tracking. So real-time tracking helps in identifying how long you will take in order to reach your destination. So it will show you how many kilometers are needed to cover your ride or the time or the duration that it takes to reach the destination is all tracked. And you'll also be able to track the driver if in case if he's getting late to reach your current location. All that real time tracking is done. So in case if there is some alternative route or an alternative time that you can to reach your destination, then this real time tracking comes into picture. Then the notification API. So you will be getting few notifications during the ride or before the ride or after the ride as well. So all that notification aspect is taken care by your notifications API all in the background. The last one is rating and feedback. If you want to give the rating to your ride and all that, it is taken care by the rating and feedback APIs. So all these different APIs come together in order to form a single application. So this is how an application program interface actually works. So this interface appears as a single application, but at the background there are n number of applications that are running together in order to make your application work better. So this is how an API works. So in API, two types of APIs, that is RESTful API and SOAP API. We'll see what RESTful API is, how RESTful API testing is done, what SOAP API is, and how SOAP API testing is also done. So we'll see what RESTful API is. RESTful is an architectural style and a set of constraints or a designed network application. So this application is used to maintain a set of constraints. It has its own specific style, architectural style, in order to make your application work. This RESTful API will get a request from a client. In RESTful API, each client will send a request to the server, and that request should contain all the information needed to understand and process the request. So the server needs all the required information in order to process it. So that is taken care by the server further. So that information is provided in this RESTful API. In REST, the sources are identified by its unique ID, that is nothing but a unique URL, that is uniform resource location. So in REST, the resources will definitely have this URL. And then the REST actually uses the standard method, that is nothing but the HTTP method. Like a few HTTP methods like get, post, put, delete, etc. are used to perform few actions on the resources. So get will help to retrieve the data, post will help in creating the data, put will help in updating the data, and delete will actually help in deleting the data. So these HTTP methods help to perform actions that are specified on the resources. Then the RESTful APIs are relatively simple and easy to understand. So that is the basic criteria for using this RESTful API. Next, we'll understand what RESTful API testing is. RESTful API testing is an essential part of the software development. So these RESTful API must be tested. The best practices for testing the REST API are, the very first one is understanding the API. API should be understood completely. So the API endpoints should be understood. Endpoints is nothing but a digital location of an API where it receives the or retrieves the request. So that has to be completely understood along with its authentication and authorization rules, and even sometimes the framework requirements and everything. So completely the API is understood, should be understandable. The second one is the set up the testing environment. It is nothing but the environment should be set up in such a way that it should be able to use all the tools and libraries that are available in that particular API. The next one is the testing types. Different types of testing methods can be used. It may be unit testing, integration testing, functional testing, or performance testing as well. So these are the different types of testing methods that can be used. Then the API authentication. API authentication is nothing but it will have a key or a authentication password or a user name that it has to use in order to prove that it is an authenticated user. So these are few things that has to be kept in mind when you are doing the RESTful API, along with few more that is nothing but API testing techniques. So methods like get, put, delete, and post. These are few techniques that can be used when you are actually doing the API testing. Data validation. So data should be validated later to know that the proper execution or the API is properly tested. Then the error handling and the performance testing. Error should be handled in any given testing methods, right? When you test a software or an API, if it encounters an error, it should be handled in a better way. It should be resolved even before implementing it. So next is the performance. The performance also should be maintained even when the errors are occurred. So the performance can't go down in case if you're solving or using that particular API. Then the continuous testing and security testing is also important. Continuous testing should be maintained because few changes or incorporations of the other resources or the applications into your current application shouldn't make any difference, or it shouldn't change your current application. So that also should be maintained. So to do that, continuous testing can be done. Along with that, security testing also has to be done because you cannot keep your APIs in danger, right? So it shouldn't be easy for attackers to misuse it. So it should also have some security in it. So that aspect also should be maintained along with documentation and reporting. So the test cases, the number of tests that is being performed on a particular API also should be noted down. How many errors occurred, how many issues occurred. So all this has to be documented and then it has to be reported so that any further changes that a tester wants to make can understand the prerequisites better when he is actually developing the testing methodologies further. So these are few concerns that is related to the RESTful API testing. So the next one is SOAP API. So now we'll understand what SOAP API is. So a simple object access protocol is a protocol for exchanging the structured information in the implementation of web services. So this is mainly used in the web services. And SOAP API is an interface that helps to communicate with each other using the SOAP protocol. It will help the applications to communicate with each other to actually exchange information. This is done using the SOAP protocol. And then SOAP is used for sending messages between applications over various protocols, including HTTP, SMTP, and many more. SOAP also helps in providing mechanisms like security, including encryption and authentication, which can be essential in enterprise level applications. So having learned about the definition of SOAP API, let's understand what SOAP API testing is. Testing a SOAP API is essential to ensure the correctness of the functionality of a SOAP-based web service, right? So that is very important. And it is a protocol which is used for exchanging structured information in the implementation of the web service. So we will see what are the best practices that are involved in actually doing the SOAP API. The very first thing is understanding the API. So it is same as our RESTful API testing. It is nothing but you have to understand the API better. So here in SOAP API, you should understand the method. You should also understand the available web services that are present and also the authentication requirements as well. So the next one is the set up the testing environment. Here also you should make sure your environment is set up in a better manner, like including your tools and libraries. The next one is testing types. It is again about the unit testing and the functional testing, the performance testing, and so on, right? So all these has to be maintained or performed when you're concentrating on the testing type. Then the authentication. Authentication is also very important because only the authenticated client should be making the request to the server and so on. So all this comes under the SOAP API testing, along with few more, that is the request structure, the SOAP request structure. Now, as the name suggests, the request should have its own structure wherein the entire information is maintained, like the header, the body of the information or the element. So like this, each and every information it should contain. So that is the request structure. Same with our SOAP response structure. This also implies that the response should be in a structured way. That means it should have all the details like the header, the body of the element, whether it is an authenticated user or not, and so on. So all this has to be maintained in the SOAP response structure. The next one is data validation and error handling. Data validation is nothing but the data should be validated when you're actually using your API, and then the error should be handled. So when there is an issue or when there is an error, it should be handled in a better way. Then the continuous testing and security testing is also important to maintain when you are actually doing your SOAP API testing. Along with that, documentation and reporting. So how many test logs were done, how many test cases were used, what are the errors what were the issues that encountered. So all these information should be documented and it should be reported. So these are the concerns that are actually looked upon when you're doing your SOAP API test. So we'll see the simple difference between SOAP API and the REST API. So SOAP API is the full form of SOAP API is Simple Object Access Protocol Application Programming Interface, and REST is nothing but Representational State Transfer API. And the purpose of SOAP API is it is a protocol that is used for the communication between the applications, and REST is an architectural style for designing communication interfaces. And when it comes to design, SOAP API exposes the operation and REST API actually exposes only the data. When it comes to protocol, SOAP is independent and it can work with any transport layer. But when it comes to REST API, it works only with HTTP methods, HTTPS methods. The few more differences are data format. So when you're using SOAP API, the data is always in its standard format. It is nothing but XML format. But when it comes to REST API, it can support formats like XML, JSON, plain, and HTML as well. When it comes to performance, SOAP messages are larger, which makes communication slower. But when it comes to REST, it is giving us the faster rate in terms of performance. Scalability, when it comes to SOAP, it is very difficult to incorporate changes or to scale the existing APIs. But when it comes to REST, it is easy to scale. When it comes to security, SOAP supports encryption with additional overheads. But when it comes to REST, it supports encryption without actually affecting the performance. So these are few differences between the SOAP API and the REST API. Next, we'll understand what API testing actually is. So API testing is a software that actually validates the application programming interfaces. application program interfaces that we studied all this while is actually validated. The main use of this API testing is to check for the functionality, the reliability, the performance, and the security of the programming interface. So, the functionality, the performance, and the security that is present inside the interface, that is the application program interface, has to be validated. It has to be checked, and that is done by API testing. Instead of using the standard inputs like keyboard and outputs and so on, a software can be used to send calls to the API to get the output and note down the system's response. A model-driven development approach is also used to map out how the software system should work before the actual coding begins. So the source code or the actual code is not important. So before that, even before going into that actual coding, the other software system or the criteria should work better. So that is tested by a model-driven development approach. So in this diagram, we can understand that in the presentation layer, GUI testing is done. That is the graphical user interface testing is done. But where exactly is the API testing done? It is done in the application UI. That is nothing but the business layer. So API testing is always done in the business layer. So next we'll understand the tools and the environment setup that has to be made in any API test. Setting up the testing environment for API testing involves preparing the necessary tools, the configurations, and the resources that are present to facilitate the efficient testing. To actually make your testing better, these criteria has to be maintained. The very first one is choosing an API testing tool. So the choosing the tool is a very important criteria. You have to choose a correct tool for testing your API. So there are different tools. For example, Postman. Postman is a tool that is used to create and send API requests and also to manage collections of requests and to automate your testing, not dealing with any of your manual testing. And the Insomnia is a different tool that is actually used, which has a similar features of Postman, but the only difference is that this tool can be used on different interfaces. And CURL. It is a command line tool that is used for making HTTP requests. It helps to work with APIs via the terminal. It always works as a command line tool where you have to give commands. So the very first step is to choose your API wisely, API testing tool wisely. The next one is installation and configuration. So based on whatever tool that you have chosen, the installation has to be made. So when you want to install the tool that you have chosen, local machines have to be installed first along with its configuration. This helps in setting up the environment variables, the authentication and authorization credentials, and other preferences that is actually involved in testing. So the next step is your API access and authentication. When working with real world APIs, the API credentials are very important. So those credentials may be like API keys, tokens, or many more. These are obtained from the API provider. So all this access information and the authentication or the authorization information is very important when you are actually working on any API testing process. The next one is test environment setup. This is a very important step that is actually followed. So you have to set your environment, right? So the test environment setup actually focuses on the configuring the chosen testing tool to work with the specific API they are testing. The very first one is defining the API base URL. The root URL where API endpoints are located. So we all know what API endpoint is. It is a digital location where the requests are actually sent in an API, right? So that is actually maintained or defined in this particular step. The next one is configuring headers. So setting up request headers, including the authentication tokens and types, for example, which format, JSON or XML, and The custom headers that are required by the API is also configured. The next one is variables and data. Setting up the variables like the dynamic data, like the timestamps or user IDs are all important. They are done to be used in the test case. Environment management. So this is nothing but managing different environments like development, staging, or the production to facilitate easy switching between API instances. So this is all about the test environment setup. The next one is the version control. So the Git is the tool that is actually used to track the changes in the API test script. So if you have a API test script, the changes can be made, the modifications can be made, or few extra incorporations can be made. So that has to be tracked or that has to be maintained, right? So that is nothing but it is a version control. You have to maintain or control what is happening in your current version of API script, right? So that is maintained by the Git. And this actually collaborates with the help of team members, and a history is maintained, right? Of what? The script version. The next one is the test data management. So data used in API tests should always be available and it should be consistent. They shouldn't vary, they shouldn't change. It also includes creating test data sets using databases or employing data generation tools. So the last one is the collaboration and teamwork. The name only tells it all. Teamwork is nothing but entire team has to work together to make the API work better. So API test collections, collaborating with team members and integrating API testing with project management and issue tracking tools like Jira, GitLab and Trello should be known for every tester who is actually working on API testing. So these are few tools and the environment setup that is made with respect to the API test. So next we'll understand what authentication and authorization is. First, let us understand what authentication is. Authentication is the process of verifying whether the user is a valid user or not, or whether the user can access the application or not. So that is the authentication process. There are different methods to do this authentication. The very first one is the API. A simple and common authentication method where a unique key is provided to the client. So client can actually use that unique key in order to request for the service. So that based on the request sent, the server will actually verify whether it is the request has come from the authenticated user or not, or authenticated client or not. The key is included in the request header to authenticate the client. So this is one method. The second one is Auth 2.0. So a more secure and flexible method for authentication is this. It involves applications to actually access APIs on behalf of the user without actually exposing the user credentials. The user credentials will not be displayed or it will not be shown to the server. Without showing that, credentials will be maintained in a secretive way. So these are the different methods that are involved in the authentication process. The next one is authorization. Authorization actually determines what action should be performed by the user or the application once they have been authenticated. Once the user is authenticated or the client is considered as an authenticated client, the authorization is a process where it will tell or define what action has to be performed. So we'll see what are the authentication and access control. Access control lists. These are the lists of permission associated with the API endpoints, specifying who can actually perform these specific actions like read, write, or delete, update, and many more. The next one is role-based access control, which means a more advanced authorization mechanism is provided, which actually assigns the roles to the users or applications and controls the access based on those roles. It will not give any extra work or the task with respect to whatever it has been assigned. So nothing more, nothing less. Whatever is being assigned as a role is actually maintained. So that is about the authorization process. Next, we will understand few testing methods. There are different testing methods that are involved in the API testing process. The first one is manual testing of APIs. We can actually easily understand by the name that is manual testing that something is done manually, right? So manual API testing is a method where testers actually interact with an API directly without the use of the automated tools or scripts. Directly the human is making the testing done, or he is validating physically or personally. So that is about the manual testing of API. Testers actually verify the behavior of the API by crafting and sending various types of requests to different endpoints. And then they provide different input data to observe how the API actually responds. They also check for the current status codes, response data, and adherence to the API documentation. Manually evaluating the API performance, error handling, and security. Basically, the manual testers are actually working manually in order to evaluate the API testing method or APIs. So API performance, if in order to test an API, the manual tester should actually consider the API's performance, the errors that were involved or the issues that were handled along with its security. So all these information is maintained manually by the manual tester. The next one is the automated testing of APIs. So automated API testing is a process of using specialized testing frameworks. So the frameworks are used and scripts are used in order to perform the testing tasks automatically. So to do this automatic testing, there are few tools involved, right? So we'll see what are those. The first one is Postman. Postman is a tool that allows the user to create automated test scripts using JavaScript. So the testers actually can use this setup and collect the requests and write test scripts to validate responses and to verify the API's functionality. The next one is REST Assured. A Java-based testing framework for REST API is used, and that is called as REST Assured. It provides a set of methods for sending requests, validating responses, and writing the test cases in a programmatic way. Because this is automatic or automated testing process, something should be written and executed automatically, right? So that is a programmatic way of actually validating the API. The next one is Karate. So a framework that combines API testing with a BDD, that is behavior driven development approach. It uses a simple syntax and allows the writing test scenarios in human readable format. So this approach actually has a syntax, a standard syntax, which is very simple, so that the writing test scenarios are allowed in order to, which is actually easy by the user or which is in human readable format. So we'll see few advantages of using this automated testing method, right? So of course, we all accept that automated testing method is more convenient when compared to manual testing. So we'll see few advantages involved in it, that is repeatability. So automated tests can be repeated. It can run as often as needed, ensuring the consistency and repeatable results. So it has to give us some consistency in maintaining the data, and it shouldn't give us the wrong or the incorrect output for same inputs, right? So that is repeatability. Then the speed. Speed is an important criteria which has to be considered. So automation can execute a large number of test cases much faster than the manual testing. Of course, we all can easily understand that the automation testing is much faster than the manual testing. The next one is continuous integration. So automated API tests can be integrated into the pipelines for continuous validation of API changes. So anything is changed or any new integration is done to the API, that has to be tested continuously, right? So that continuous integration is done. Regression testing. Automated tests are valuable for checking the new changes to the API without having to affect our existing functionality or the prior functionality. So that testing is also being included in our automated testing. So next we'll understand API testing approach and its test case. So the API testing approach is very important and simple when compared to any other testing process or an approach, right? So API testing approach is a predetermined strategy or a method that is actually used by the QA team, that is quality analysis team, to conduct the testing on the API once the build is prepared. After the entire construction of API is done, then the QA team comes into picture and it will test. The API testing is done. This form of testing does not involve examining the source code. So the source code is not touched in this particular phase. If not the source code, what else is actually tested is our next point. So API testing approach actually aids in gaining a deeper comprehension of the functionalities and the testing methods that are involved in the process, the input parameters, and the process of the existing test cases are all checked in this particular approach. So, what are the advantages of using this particular testing approach, or what are the test cases that has to be considered in order to do this particular testing? So, this testing actually helps in gaining the insight of API programs operation and precisely outlining the program scope. It will give us the entire information or outline of what actually the API program operation is. The next one is utilizing these testing methodologies like equivalence classes, boundary value analysis, and the educated guessing of formulate test cases for the API helps us to have the efficient methodology or an approach. The next one is it is very crucial to plan this particular approach and to establish the input parameters that are involved in this particular API. The next one is to perform the test cases and the expected outputs with the real results is a tedious task. So this is also maintained in this particular test. So these are few pointers that has to be considered when you are actually doing your API testing. We'll now see the test cases that are involved in API testing. So the very first one is return value based on input condition. So this is nothing but it is a relatively easy to test, and as the input can be defined and results can be authenticated. Because of this authentication process that is present, the return value is always should be based on the input condition. Does not return anything, which means when there is no return value, a behavior of API on the system is to be checked. When it does not give any output, then the behavior of that particular API should be checked. The next one is trigger some other API, which means if an output of an API triggers some event, which means it's an interruption, then those events and interrupt listeners should be tracked. It should be maintained. The next one is update data structure. Updating data structure will have some outcome or effect on the system, and that should be authenticated. The next one is modify certain resources. If API call modifies some resources, then it should be validated by accessing respective resources. Next, we'll understand about automation framework. The automation tests that are done on the API needs to maintain few frameworks. So we'll understand about the frameworks of this automation testing. So the very first thing is that the API testing frameworks are pre-built structures that actually offer reusable components. We all can understand that when it is pre-built, then we can use it, right? So that reusable of components, guidelines, and a structured approach to creating automated API tests are maintained. The next one is frameworks actually help the testers efficiently to create and maintain the automated tests. These frameworks actually helps in maintaining different types of API testing frameworks and they are data driven, keyword driven, and behavior driven development frameworks. These can be any type of frameworks can be used in order to test your API. And then the frameworks like Postman, Rest Assured, or Karate, or tools like Selenium are a few popular frameworks that are actually used in the current automation test. So next we'll see how to test an API. So we have an API, we have to test it. We know we have to test it, but how is our next. So we'll see there are different types of testing methods that are used in order to test our API. We will actually understand different types of testing that are involved in testing our API. The very first testing is the exploratory testing. So as the name tells, something is actually outlined or something is actually explored. We'll see what it is. The testing team should manually perform a series of API calls as outlined in the API documentation. This involves confirming that a specific resource exposed by the API can appropriately be listed, created, and deleted. We all understood that the resource is exposed here by the API. So that is why it is called as exploratory testing. The next one is usability testing. So in this type of testing, it actually helps to determine whether the API is not only fully functional but also user friendly. That is why it is usability testing. It is called as usability testing. It should be very user friendly. It accesses how well the API integrates with other platforms. So the integration also should be understood. So it should be very easy to implement those integrations, right? That comes under this particular usability test. The next one is security test. This phase of testing actually involves evaluating the authentication. That is why it is called as security testing. The authentication methods are required by the API and the sensitive data is encrypted when transmitted over HTTP or any other protocols. So the next one is automation testing. API testing should conclude with the development of a set of scripts or testing tools that can be used for routine API testing. So it should have some predefined scripts or tools so that it can be continuously used whenever it is needed. So that is called as automation testing. Some process is automated, which can be conducted automatically. So that is about the automation testing. The next one is documentation validation. The testing includes ensuring that the documentation accompanying the API is comprehensive and provides sufficient information for users to effectively interact with the API. So in order to interact with the API, the user should know what exactly is the API all about, right? So sufficient information should be documented. So that is why it is called as documentation and validation. So this is how different methods of testing can be used in order to test an API. Next, we'll understand what data validation and performance testing is. After doing everything, data has to be maintained. After the testing is done, the data has to be maintained. And the performance testing also is involved in this particular process. We'll see what it is. The data validation is nothing but the API testing data has to be validated. So it is done in different methods again. So the response data validation is nothing but it is an API testing and it is very crucial to validate the data received in an API response, correct? So we have to validate. So that is called as response data validation. All these criteria or key points come under this response data validation. We'll see what are those. Very first one is schema validation. So we can easily understand that it is something related to the schema that is present, right? So in this validation is nothing but it ensures that the responses that is received at the API adheres to some predefined schema or contract such as a JSON schema or XML schema. The formats are also verified. So that is about the schema validation. The next one is data type validation. Verifying that data types like integer or float or the strings in the response actually match the expected types. Whether the data is the expected data or not is actually validated in this particular phase. The next one is the field existence and content. Checking if the specific field exists in the response or not is very important. Every field should be filled, and whether that particular field is filled or not also should be checked. So that is done, and the response and their content that is present in that field is also checked, and it is checked whether it has met the expectation or not. So that is about the field existence and the content check. The next one is the boundary value. So validating values within a specified boundary is very important. So the boundary all tells all about it. And the next one is error and exception handling. So the testing the response for error messages or the exceptions is that it indicates issues with the APIs. So error messages and or the exception that occurs are all actually giving the clue of what errors is present with that particular API. So these are the things that is that comes under the data validation. The second type of data validation is nothing but handling the JSON and XML data. So APIs often use this format, that is the JSON and XML, for data exchange. So we'll see what are the key features that comes under this particular data validation, that is handling JSON and XML data. The very first one is parsing and serialization. So converting the data from JSON or XML format is very important. So that is from JSON or XML. So converting these JSON or XML format to the format that can be processed by the testing tools is done in this particular phase, that is parsing and serialization. The next key feature is XPath and JSON path. Using XPath for the XML or JSON path for JSON to navigate and extract specific data elements within that particular response. So that is taken care in this XPath and JSON path separately. The next one is the data transformation. Converting data from one format into another format is needed, and it is done in this particular phase, that is data transformation. Data comparison is also a feature. So comparing the expected data and the actual data to validate the correctness is done in this particular feature, that is the data comparison. So these are the things that come under the data validation concept. Next is about the performance testing. So performance testing, as the name suggests, it is to do something with the performance, right? So load testing is one thing that actually involves in accessing the API's performance under expected load conditions, which actually helps identify different bottlenecks and the performance issues. So we'll see what are the different features that are present in or the phases that are present with respect to performance testing. First one is nothing but the load levels. Gradually increasing the number of number of concurrent users or requests to gauge how the API behaves under normal load is done under this load levels. The next one is the stress testing. Subjecting to API to loads beyond its capability to identify the breaking points and the potential failures is very important. And the next one is virtual users, using tools to stimulate virtual users, making requests to the API, mimicking real world usage, all has to be considered, and that is done in the virtual and that comes under virtual users. The second type of performance testing is monitoring, analyzing API performance, which means API performance is monitored and it is also analyzed. So we'll see what are the methods or different aspects of doing this. Set performance metrics is used, which actually defines the key performance indicators, that is KPIs, such as response time, throughput, and the error rates are also measured. Continuous monitoring should be done. So continuously observing the API performance and analyzing the trends over time is also very important to uh, state that the performance is improved. The next one is profiling and profiling tools. Profile the API to actually identify the resource intensive operations and to remove the bottleneck. The next one is load balancing. Verifying the efficiency of load balancing mechanisms in distributing incoming requests is important, and that is done by load balancing. So the load should be balanced. It cannot go haywired, right? That is maintained by in this particular aspect. And scalability testing. Test how well the API actually scales by adding resources or replicating the components under load. So these are few uh, considerations to be made when it comes to performance testing. Next, we will understand how the error is handled and how the security is maintained in testing. Security is maintained in API testing. The very first one is error handling, handling API errors and exceptions. Here, the API test should actually include scenarios to validate how the API will actually handle the errors and the exceptions. This actually involves triggering errors, which means intentionally triggering errors by providing invalid data or by making an incorrect request to the API. So, like by triggering these invalid requests or making the invalid request, this method is actually used in API testing. The next one is appropriate error codes and messages. Here, the error responses from an API should provide clear and meaningful information to both the developers and the end users. This actually helps in solving the issues or troubleshooting and resolving issues efficiently. The next one is security testing, identifying security vulnerabilities. So here, SQL injection is used. So this helps in accessing the API to actually be very vulnerable to SQL injection attacks, which can manipulate or retrieve sensitive data from the database. The second method is the data exposure, which means it will check if the API exposes or reveals the sensitive data or information such as personal or confidential data to the unauthorized users. The second one is security API endpoints, which means security testing also involves verifying that security measures are in place to actually protect the API endpoint. Next, we'll understand more about the documentation and reporting. So when it comes to documentation, the word only tells it should be something should be documented, right? So it is nothing but when you are doing a test, API test, you have to maintain or you have to document whatever comes your way. So the very first thing that you will be documenting is your test plan. So what are the plans that you are actually making in order to implement your testing methodology? So that has to be documented. The second information is the test cases. So what are the test cases that are actually implemented or that will be implemented in future in order to do the API testing? So that test cases also should be documented. Next one is the test data. What exactly is the data that has been tested? So the entire data should be documented again. And the next one is test scenarios. What are the scenarios that you encountered when you were doing the API testing? Should also be documented. And then the documentation of API endpoints. So API endpoints are very important aspects that has to be documented so that you will know what are the digital locations of that particular API that is being used. So these are the things that you will be maintaining in your document in order to make your API testing method simpler and efficient. Next, when it comes to reporting, again you have to keep few information in order to report what tests were done. So that comes under reporting. So the very first one is test execution. So how the test was executed, what are the methodologies that were involved in executing. So all these informations comes under reporting. The next is the test log. So what are the logs or what are the test logs that were implemented in particular testing process should be logged, should be maintained in your documentation. So that again comes under reporting. Next one is test matrices. So all the test matrices that were involved in the process of testing should be maintained or should be reported. So that is test matrix is nothing but what are the methodologies, what are the processes that were involved, what are the errors, all that will be reported. And then the test summary report. So entire data should be converted as a summary. Summary should define everything. So that summary report also should be reported. Last is nothing but the continuous monitoring. Once your process is maintained as a document, you can't leave it as it is. Say suppose you make extra changes to the particular underlying application, then that also should be added. Then you make some other integration and some other changes, then that also should be added. So that continuous monitoring, whatever changes has been made to that particular API testing process should be documented and maintained. So that continuous process or continuous monitoring should be maintained. So that is all about the reporting. So these are the few reporting, documentation and reporting aspects when it comes to API testing. Now let us understand the different practices that are involved in order to do your API testing. The best practices that are involved in API testing are, the very first one is API test cases. So organize the API test cases into distinct categories for clarity. Keep your test cases in a way that it is very clear for a tester to do the testing even in your absence. So that is about the API test cases. The second one is declarations. So the declarations also should be very clear. Begin each test with clear declarations of the APIs being utilized. What all APIs are being utilized. So all that declarations or information should be maintained correctly. Next one is the parameters. So explicitly state the selected parameters within each test. So what are the parameters that you have selected? What are the parameters that are actually involved in that process? So everything about the parameters should be maintained. So that has to be considered. That is one of the best method in order to do your API testing. Next one is prioritization. Prioritize what sequence the API function calls have to be made. So prioritize the sequencing of API function calls for the convenience of the tester. So the tester should know what has to be done first and what. So next is the independent. Strive to ensure that each test case is as self-contained as possible. It cannot be dependent. It should be independent with minimum dependence. That is the independence concept. The next one is the development process. Refrain from creating interlinked test chaining within your development process. Make sure your development process is defined properly and the chain of what test has to be made should be mentioned properly. Only then the development process will be very easy and understandable by any tester who is actually involved in that particular test. So the next one is the handling function. Exercise extra caution when handling one-time call functions like delete or close window. So all these functions are just used one time, right? So you should be very cautious when you're using that. So you should know how to handle these functions. So the next one is execution. Plan and execute the call sequences thoroughly and thoughtfully and methodically. So these functions should be executed in a manner where it is actually planned and executed efficiently. So that has to be planned. So execution of these sequences of functions or call for these functions should be maintained. And then your test coverage. So to guarantee the comprehensive test coverage, create API test cases that encompass all the potential input combinations for that particular API. So these are few practices that can be made priorly even before doing your API testing, even before performing any API testing. Next, we'll see the difference between API testing and unit testing. So, the very first difference is unit testing is actually done or performed by the developers. But when it comes to API testing, it is actually performed by the testers. It is not done by any developers or it is not done by end users. It is actually done by the testers. The next difference is that in unit testing, separate functionality is tested. Different functions is tested differently. But then in API testing, end-to-end functionality is tested. Then the source code can be accessed by the developer in unit testing. But when it comes to API testing, the source code cannot be accessed by the tester. The tester should not involve in the source code at all. His job is to just test the uh, functionalities and not to do anything with the source code. Next is that UI testing is also included in unit testing. But when it comes to API testing, only the API functions will be tested. And when it comes to unit testing, only the basic functionalities are tested. But in API testing, all the functionalities or functional issues are tested. The unit testing is limited in scope, but the API testing is broader in scope. You can actually utilize that particular API testing in a broader aspect. These are few differences between the unit testing and API testing, and how better is to use the API testing is understood. Next, we'll understand the challenges or the pitfalls that are included that comes under this particular API test. The very first challenge is to decide your parameters. So the parameters combination, the selection of parameters, or the calling of these particular parameters or sequence of functions is very difficult at times. So proper prioritization should be given so that it will be easy for the tester to do the actual testing. The second one is absence of GUI. Graphical user interface is not present, and which is actually a disadvantage when it comes to the API testing. Next one is verifying and validating on different systems. So the platforms are not same, the systems are not same. So validating and verifying on all these different platforms is sometimes challenging. The next one is parameter selection and categorization. As I said, the selection of parameters is only difficult. Based on that, categorization is even more difficult. And the next one is exception handling function. So few functions to handle exceptions are difficult at times. The next one is the coding knowledge. Having coding knowledge is always a boon, but that is always a challenge when it comes to a tester, because tester is always testing the APIs using just the script. He should also have some coding knowledge, which will be beneficial. So these are few challenges or the pitfalls when it comes to API testing. Next, we'll see the ethical or legal considerations to be made when you're using the API testing. The very first one is respecting API usage policies. So policies also should be maintained. So API providers often have terms of service and usage policies. So these have to be followed to avoid any violations that may lead to legal consequences or suspensions of API. When you don't follow the policies or the services that is already termed by the API providers, then your legal consequences should be faced. Then you have to face the legal consequences, or suspension of API also can be done. The second one is data privacy and security. The data privacy and security plays a very important role. So the testers should be very cautious when working with the sensitive data or the personal data through the APIs. So it's essential to handle the data in compliance with privacy regulations such as GDPR or HIPAA, and to avoid data breaches or exposure. The next one is rate limiting. Many APIs have rate limits to prevent abuse and ensure fair usage. Testers must be mindful of these limits to avoid overloading of API server and potentially disrupting its services. The next one is consent and permission. If the APIs involves user data, it's essential to obtain proper consent or the permission or the request for actually using the user's data even before testing. The data ownership. Understanding of who actually owns the data is very important. Testers must be aware of copyrights and intellectual property rights and respect data ownership rules. You cannot actually use the copyrighted data, right? So that ownership of the data also should be considered. Compliance with regulations. So different industries and regions have specific regulations and compliance requirements. The testers must be aware of these and ensure that the API testing process actually aligns with legal obligations. The next one is data masking and anonymization. To protect sensitive data, considering usage or data masking techniques in test environments to prevent exposure of confidential information is very important. You have to protect your data either by data masking or anonymization, which actually masks your data, and it will prevent the exposure of your confidential data or the privacy in your data. So this is very important to maintain as a or to understand as a tester. The next one is reporting vulnerabilities responsibly, which means if testers discover security vulnerabilities during testing, it's important to report them to the API provider that so and so has happened, and promptly and responsibly rather than exploiting them, which means you cannot misuse the data. So all that is to be taken care or understood by the tester even before doing the testing. There are few future trends or the emerging technologies that are coming up with respect to the API testing. So we'll discuss few of them. The very first one is the GraphQL. GraphQL is an alternative to REST API for building and consuming APIs. The second one is gRPC, which means it is a high performance language agnostic framework for building the APIs. The next one is IoT APIs, which means the Internet of Things is rapidly expanding and IoT devices often communicate via APIs. So these are few future trends or the emerging technologies that are actually being developed or explored in current trend of API testing. There are few references that are being added. We'll just try one of it. So JSON placeholder type code.com. So here there are different tools that you can actually use in order to create your scripts for doing your API test. So these are the scripts that are written in the JSON format. When you run the script, it will give you some data. So like this, you can actually research more on this particular website in order to understand how these scripts are written or how different tools, these are the different tools to actually do your API testing. So we'll see a different URL again. So I'm taking this URL, the third URL. So I'll just try to open it in the browser. So the second one is this. So I'm demonstrating this. So here in this GraphQL that we saw and the REST API for testing is again a different website that you can actually use to run or to learn how to write these scripts for doing your API testing. So this is a URL that I'm using. So when you click on that, it gives a script in your JSON format. So this can be used in order to test your APIs. So all this can be explored and you have few endpoints also, GraphQL endpoint that also you can actually refer to. And there are different versions also to know how many versions are there when you are doing your API testing also. So these are few things that you can refer to. We'll see one more URL. So if I am actually opening the last URL, so it takes me to a different page, and here you can find different APIs. So here you have detailed API documentation. You can just click on that and it will lead you to a different page where it will actually have scripts. So this is all about the RESTful API, and this is again the URL that is related to your request that you want to work on or action that you want to perform. So it is different for post, it is different for get, it is different for see, you can see it is different for get, and so on, right? You have a number of actions to be performed, and these are the scripts that are written, and you can easily use these scripts and run on your Visual Studio and know how the API can be tested. And these are few parameters that are already present. So these are the parameters. So parameter name along with the type and the description is also given so that it is easy for the user or the learner to understand. These are the few links to the website that helps you to learn or understand more about the API testing. So you can just try and explore and learn more about how to write scripts, how these scripts are written in JSON, and how these are executed, and how these helps in testing the API. As we have come to the end of this session, let us quickly recall about what all we studied in this particular session. So APIs are the tools that facilitate the communication between two different software components. We also understood how different API tools and the environment setup is done, along with its authentication and authorization. And we also studied about different testing methodologies that are involved with the API testing approaches. And we also saw different frameworks for automation testing, which helps the testers efficiently to create and maintain the automated tests. Next, we also understood how the errors are handled and how the security testing is very important in API testing, along with how to document and report. And we also explored different practices or the best practices for comprehensive and secure API testing, ensuring thorough testing methodologies and transparent reporting. Next, we also understood the difference between the API testing and the unit testing, and also explored different challenges and ethical and legal considerations to be known by a tester. And we also had an insight of how the future trends and emerging technologies are involved in API testing. Now that we have explored API testing, where we tested the interfaces between different software components and external systems, let's move on to Cucumber testing. In Cucumber testing, we will focus on behavior-driven development to write test scenarios in plain language for better collaboration. Cucumber testing belongs to the realm of automation testing, as it involves writing automated scripts to validate the behavior of the software based on these scenarios. Hello everyone, welcome to the course on Cucumber testing. Cucumber testing is a widely used open source testing tool which is used for behavior-driven development. Is a process which encourages the different domains like testers, non-testers, or the developers to collaborate with each other when they are actually testing a software. That is understandable by all the members in the process of software development. Before understanding what exactly the Cucumber testing is, we all already know that testing is a process that is involved in a software development process, right? So given a scenario in your company, say suppose you are asked to develop a software, what are the steps that you follow in order to develop the software? You first collect your requirements, and then you do the planning, and then you will do the design phase, then you will design your entire project, then you will implement it. After implementing it, of course, you are going to test it, right? Testing is a phase where you actually test your software that is developed, right? So we'll understand more about testing, how the different types that are involved in testing, and what and where the Cucumber testing came from. Without any further ado, let's jump right into the course. So the agenda for this course will be, you will understand the definition of testing and what the automated testing is all about, and the benefits of using automation testing, and different tools and frameworks that are involved in automation testing. And from there, you will understand the Cucumber testing, the history and the background of Cucumber testing, and also few benefits that are involved in Cucumber testing. You'll understand more about the key features or the concept that is involved in Cucumber testing, and that is nothing but Gherkin and step definitions. And along with the basic understanding of these concepts, you will be able to understand how to use them in your Eclipse, and we will have a hands-on session on how to actually use your Cucumber testing tool. Next, we'll understand what testing actually is. In the software development process, testing is a systematic and controlled process of evaluating a software application to identify the errors or the defects or sometimes even the issues. So this testing process can be controlled. It is in the hands of the testers. So we'll see what next. Testing is a crucial phase in the software development life cycle. As I said, given a scenario in order to develop a software, we actually follow a step-by-step process in order to develop a software. At the same time, we have to make sure whatever is developed has to be tested. So testing plays a crucial role in the software development process. The primary goal of testing is two things. One is verification and the other thing is validation. Verification is nothing but it is a process in the software development to make sure that the software functions according to the defined requirements and the specifications. During the requirement phase, the user would have given the requirements. Based on the requirements only, the software will be developed. We have to make sure this at the end of the software development, the software is actually giving us the output of what the requirement set was. So that is very important. That is called as verification. We have to verify whether the developed software is fulfilling the requirements or not. The next one is validation. Validation is nothing but it is a process of ensuring that the software not only conforms to requirements, but also it should meet the needs and expectations of the users. It is not just okay if it fulfills the requirements. It should also be a expected output as well. Correctness is also important. So verification and validation is the two main goals in the process of testing. So as I said, in the software testing process, the very first step is nothing but the requirement analysis. The requirement analysis is nothing but you talk to your peers and understand what the requirements actually is, and the user also would have given you few requirements of what he or she wants. So based on that, you will frame the requirements. So analysis of that requirements will be done. The next step is nothing but the planning. So whatever requirements you have collected will be maintained along with the reference of what the requirements are. You will start planning for the development process, right? So you will be writing your sketch or the outline of what your planning actually is, what and where you have to start from. So all that planning will be done in this planning phase. Next is nothing but the test design. So what happens in your test design phase? So you will be designing the test cases, right? So whatever the planning is done, based on that, you will start designing your process. So first, what you have to design, what you have to then look into the environment. You will set up that environment. Then you will use the tools and the frameworks or few other, you will be able to incorporate the tools from elsewhere or the other platforms. All that process will be done in this design phase. You will exactly design which unit has to do what. So all that will be done in the design phase. Next, after the design phase, you will go to set your environment. So you will set up the entire environment of based on the requirements or the planning or even sometimes the design. Keeping all these three things in mind, you will set the environment. You will decide which tool to be used at the end, or which platform you will be using, or what are the softwares that you will be utilizing, or you will download all those softwares and keep it ready. You will set your environment ready. You will import all the packages. You will import all the files. You will keep everything ready, and that is called as setting up your environment. From there, you will move on to your test execution phase. You will write few test cases, or you will write few methodologies in which the process will be tested or the application will be tested. So that is nothing but the test execution. Something will be executed at the background. That is all about the test execution phase. Then is your final testing phase. So finally, you will run whatever application is required at your back end and the front end, and you will test your developed software or an application. So this is a simple life cycle of how a software is tested. So we'll see what more can we understand in this particular testing concept. Next is your different types of testings that are involved. There are n number of testing methodologies or types present when you're actually testing your software. I have defined few types of testing here because that will lead us to understand about the cucumber testing. So very first testing type that we all know is the functional testing. So functional testing is a methodology which is used to actually test your functional units. So there are again sub-testing methodologies like unit testing, integration testing, or sometimes the functional testing, and many more in order to test your functional aspects of the application. The second one is the non-functional testing. Here again, as the name suggests, non-functional aspects of your software will be tested using this non-functional testing. The next one is the main testing methodology that we all know, that is nothing but the manual testing. As the name suggests, manual testing is nothing but a person will be involved in the testing process. He himself will test the software or an application manually. That is why it is called as manual testing. The next one is a very interesting one, and that is nothing but the automated testing. As the name suggests, something is automated, right? So it is nothing but the testing is automated. When I say it is automated, it is nothing but there is no involvement of a manual person or a tester to work in the testing process, which means some scripts or the structures will already be written and kept ready by the developers. So that will be used by the testers in order to test the software or an application. That is called as automated testing. Automated testing is nothing but there are few scripts or tools that is already present, and you will be using those in order to carry out your testing process. That is the reason it is called as automated testing. The next one is regression testing. Regression testing is nothing but when you are using your automation testing, you will use few scripts in order to do your testing. Say suppose you make some changes to your script. So the underlaid script will have some modifications and changes in it, right? So that has to reflect in the process. So that is the regression testing. So regression testing is a process where the automation testing is involved. When you make some changes to your application, say suppose you import few tools or the techniques from different platforms into your underlying application, when you test that application next, it should give you the correct output. The changes that you have implemented in your software also should reflect in your testing. If that modification is not reflected, then the testing is called as unsuccessful, right? So that also should be taken care of. Anything that is modified to your existing software or an application should give you the best result or the correct output when tested. So that is called as regression testing. When you want to test such applications, then you should go for regression testing to get better results. So these are few testing types that are involved in the process of testing your software. Now we have understood something called as automated testing, right? So we'll understand more about automation testing. So when I said automation testing, I also mentioned something about test cases and the scripts, right? So test cases are nothing but they are already developed and written and developed by developers. So the testers will use these test cases or the scripts directly to check whether the software is working properly or not. Automated testing is nothing but it utilizes these specialized software tools and scripts to automate the execution of test cases. You already know what test cases are. It actually replaces the manual execution of tests. When the test cases are easily available or the tools or scripts are easily available, the testers will use it directly to test softwares, right? There is no requirement of the manual testers here. So that is the meaning of the statement, that it replaces the manual execution of tests. Automated testing is practically useful for repetitive and regression testing. We already understood what regression testing is. So the changes or the modifications that you do to your application or software should also reflect in the process of execution, right? So in those situations, this automated testing is very useful. Test automation is the word that you have to actually understand. So test automation is the use of these specialized software tools and the frameworks to perform test cases and to verify the behavior of a software application or a system or a component without manual intervention. So it is very easy to understand. So you are testing something using the test cases without the manual intervention. That is called as test automation. We will understand few benefits of this method that we are using. The very first benefit of using automation testing is efficiency. The automated tests can be executed much more faster than the manual tests. So if in case a manual test is compared with automation test, of course the efficiency is more in automation testing, because manually there is no need of any person to test the process, right? So it is automated. If something is automated, it is of course efficient. So that is the main benefit of test automation. The second benefit is repeatability. Automated tests provide consistency and repeatable results. So it will always give you a constant answer even if you test it n number of times. Given a sequence of where the process is tested n number of times, but still the result will be consistent. That is repeatability. The next one is scalability. And software applications grow in complexity. The number of test cases increases. So, which means the number of test cases that increase, of course, the scalability increases. So, if there are n number of test cases that is already present, of course, the scalability is increased, right? So, you can also write a test case and add it to the repository. So it increases the scalability. So there is some addition to the test cases or the structures already present. So the next one is the frequent testing. Automated tests can be executed as often as needed, allowing for continuous integration and continuous delivery, which means you can test n number of times. There is no any drawback in it. So you can keep your script and your test cases, and you can keep on testing your software n number of times. Or you can also use the same test script whenever you need it in a different situation. So frequently you can be using it, and it is easy also, right? So that is one benefit. The next one is regression testing. Automated tests are ideal for regression testing, where previously passed test cases are rerun on your system to make sure that your new changes made to your software is also working efficiently. That is called as regression testing. So that is also a benefit that is present in the automation testing. Data-driven testing. Automation allows for data-driven testing where the test cases are executed with different sets of input data. So you keep different sets of input and execute your software or a problem or an application. It should give you the correct output, right? So it doesn't depend on what set of input data you give. The output should always be right. So that data-driven testing is also an added feature or a benefit in our automation testing. The next one is parallel execution. So many automation frameworks are designed in such a way that it allows for parallel execution of tests so that the testing time is very minimal. So parallelly, when you're running different tests, it is always beneficial, right? So it reduces the overall testing time. So that is the benefit of having parallel execution in our test automation. Cost savings. When you're using automation testing, the cost actually reduces. I'll tell you how. So when you're using a manual testing process, there is manual people involved in it. So you will be investing on them in order to do your testing. You have to pay them. Manual testers are always required in order to do your manual testing. So each time you want to repeat your testing process, you'll end up paying them. But when you use your automation testing, you will already have your test cases or the scripts or the tools available in the repository. You can directly use them and you can test. So there is no need of manual people involved in it. So something is already readily available. So you'll use that and you will test your software. That is one advantages for using your automation test process. Next, let us explore few tools and the frameworks that can be used in the software testing. Selenium is the very first tool. It is a automation framework which is basically used in the web applications. So which means there are few web applications like your Gmail, may it be your Facebook. So these are all the web applications, right? So all these web applications also needs to be tested after the development. So these kind of web applications can be tested using this Selenium tool. The second tool is nothing but the Appium tool. It is always working with respect to the mobile applications. So it is an automation tool which is used in mobile application testing. So there are n number of applications that are present in your mobile also, right? May it be your contacts or your ebook that you use or Instagram. So there are n number of applications that you can install on your mobile phone and use it. So all these mobile applications also need to be tested. So these mobile applications can be tested using the Appium tool. The next tool is JUnit. As the name suggests, it is to do something with Java, right? So it is a framework that is used with the Java applications. So there are n number of applications that you can develop using Java language. So those applications can be tested using this particular tool, that is JUnit. So the next tool is the TestNG. TestNG is a testing framework which is actually working with the Java application testing. It is a similar tool that is used in testing the Java applications. So the next tool is nothing but the Cypress. So this is a testing framework that is used to test the modern web applications. So there are n number of web applications that are coming up. It may be with respect to designing a web application online. You use few applications that are already present and you just use drag and drops in order to create your applications. So all those modern web applications that are being developed these days can be tested using the Cypress tool. So these are few tools and frameworks that are present in order to test your applications. May it be your web applications or mobile applications or the applications that the user develop. But we have to understand the difference between what tool is and what framework is. Definitely tool and framework is two different concepts. It is not similar. So we'll see few differences of what tool and framework actually is. So let us understand few differences between tools and frameworks. Tools are always used for specific purpose, whereas frameworks are always used for generic purpose. So tools are software applications or software programs that are designed for accomplishing or checking a specific task or a function. But when it comes to frameworks are very structured and they are organized collection of libraries or APIs. It is nothing but application program interfaces and the components that provide a foundation for developing a software application. So the next difference is Tools are standalone, but the frameworks are reusable code. So we'll see what it is. So tools are typically standalone software applications that can be used for independently with other tools or software components. But when it comes to framework, they provide the reusable code. We already understood that, right? Something is already present and you can reuse it. So they are also having guidelines and the best practices for building or developing the applications. The next difference is user interface. So many tools will have this user interface or a command line interface where you can actually give the commands using VS Code and all of that, right? So the tools will basically have the interface so that the user can give the commands or he can control it. But when it comes to framework, developers will actually develop your frameworks. Developers use a framework to build their applications by plugging in their code into the predefined structures or functions that are already present in the framework. Few examples with respect to tools are text editors, version control systems like Git, and the browsers, for example, the Google Chrome that you use, and few debugging tools and IDEs. These are few examples when it comes to tools. But Ruby, Rails, Django are few web frameworks, whereas Angular, JUnit, TestNG, and Selenium that we saw all this while are few testing frameworks. So these are few differences between what actually tool is and what framework is. So we have to know this difference in order to use them. So next we'll understand more about Cucumber testing. Cucumber is a popular BDD framework. It is nothing but behavior-driven development framework that actually allows the user to express the expected behavior of the software in plain or human-readable language. So anybody who is involved in the Cucumber testing should be able to understand the whole testing process. So this framework, that is the BDD framework, will have a human-readable text in it. So anybody who is involved in testing will be able to understand it. It actually bridges the communication gap between non-technical stakeholders, like may it be the project developers or the marketing people. They are nothing but they come from non-technical background, right? So that communication gap between the non-technical people and the technical teams like developers or the testers or any content related people, so they all come under this technical team. So that communication gap between the different teams is also resolved. So this Cucumber testing tool bridges the gap between these different teams or domains by providing a common language to discuss and document the software requirements. So that common language will actually help in documenting the requirements as well. So that is the use of this particular language. Cucumber tests are written using a language called Gherkin, which is easy to understand and write. I will tell you how it is easy to understand. So this Gherkin uses a simple given, when, then structure to write your text. So this will define a behavior of a system. So that is why it is used. So we will see what is the role played by this given, then, and when in the structure. So this is the structure. Now say suppose user is expected to log in. So login is the functionality. So that is called as feature or the problem. The problem is also understood as feature. So the scenario is now the user can log in with its credentials, right? So he has to use something to log in. What is that called? It is called as credentials. So that credentials, there are two possibilities. He will give the valid credentials or he will give the invalid credentials. So we'll see what is actually in that given, when, then. So given, as the name suggests, the user is on the login page and he will give. So that is called as given. He should give the valid username or the password when he is on the login page. So that is called as given. And then it will go to when. When is nothing but when he gives the valid username and password. If you observed, I used when. So when is nothing but when he gives the valid username and password, only then what will happen? They can be logged in successfully. That is nothing but given is nothing but he is on a home page, he will give something. So once he gives the valid information, that is called as when he gives the valid information, then in the sense after that only he will be able to log in. So if you can see, there is a flow that is called as given, when and then. So when you write these instructions, that is given, when, then and all in a normal language or a plain text or a human readable text, it is very easy for anybody to understand, right? So this is the advantage of this language, that is Gherkin. So this human readable format allows anyone involved in the project to understand and contribute to the testing process. This makes it a powerful tool for collaborating in the sense different domains are coming in collaboration, right? That may be non-technical people or technical people. So they all collaborate with each other to actually do the testing process to ensure the software actually meets the business requirements. So this is the advantage of using a simple human readable format in the process. So we'll see a small history or a background of this Cucumber testing. So Cucumber was created by Aslak Hallerson and it was first released in the year 2008. It emerged as a solution to a problem of effective communication between software development teams and non-technical stakeholders. This is where the BDD methodology comes into picture, right? So the behavior-driven development framework is actually used to solve this problem or to make the communication established between the software development team and the non-technical team. Before even Cucumber came into picture, there was always a gap in understanding between these groups, which always led to the misunderstandings, and the software didn't meet any of the business needs or requirements. Cucumber's Gherkin language was designed to address this issue, making it possible for everyone involved in the software development process to understand and also to discuss and to validate the expected behavior of a system. It is now used by many organizations to improve the collaboration and the quality of their software. Having known the history and the background of Cucumber, we will now understand few benefits of using this Cucumber. So the very first advantage or benefit is improved collaboration. We have already understood what collaboration is, right? So it is nothing but bringing different domains or people as one unit. So the Cucumber process always has a better collaboration between technical and non-technical team members. The business analysts and the testers can work together to define and to verify the system's behavior, ensuring that the software aligns with the business goals. The second benefit is clear documentation. So this Cucumber also has helped us maintaining a clear document, which means Cucumber test serves as living documents for the system's behavior. They are written in the plain English text or English language, and it provides a clear and concise overview of what the software is expected to do. As we saw in our previous example, we already understood what exactly the problem was. It was related to the login functionality. There is no need of having any coding background to understand that, right? Similarly, for bigger problems, this language is a solution. So that is all about the clear documents. The documents are very clear to anybody who actually involves in the process. The next one is reusability. The word only tells us everything, right? Reusability is nothing but there is something already present and you will use it to actually execute your testing process. So Cucumber promotes the reuse of step definition. So here we also have to understand what this step definition is. We will understand it better in our next slides. So once these step definitions are defined, it can be used in multiple scenarios and multiple times, reducing the redundancy and making the maintenance more efficient. So when we understand this step definition, you will understand what this reusability actually is. It is very beneficial when you're actually doing your Cucumber testing. The next one is automated testing. The word only tells us everything. It is nothing but something is automated. So there are scripts or tools that are already present and you will be using that. So Cucumber allows for the automation of these plain language scenarios. The testers can actually execute the tests quickly and reliably, making it easier to catch regressions and ensure the software's continued functionality as it evolves. We also understood what regression is, right? Any modification made to your application should also reflect in a better output. So that is taken care by the automated testing method. So that is also allowed by our Cucumber. So that is again a beneficial aspect. So the next one is continuous integration support. So the Cucumber integrates seamlessly with continuous integration pipelines, enabling automated testing as part of the development workflow. So here we have the plus point of using something continuously, and we can integrate those things in our pipeline or in our automation testing, so that which actually helps in developing the software efficiently. So that integration is also supported. The next one is parallel execution. We already understood what parallel execution is, right? So there are different units that are parallelly executed so that it reduces the overall time that is taken for testing. So Cucumber supports parallel test execution, allowing multiple scenarios to run concurrently, which means simultaneously. Then the next one is community and resources. So Cucumber has a vibrant user community, providing access to a wealth of resources, including documentation, tutorials, libraries, and etc. Many more. All of these can extend its functionality. So this is also a beneficial aspect when it comes to Cucumber testing. Language agnostic, which means it is a plain text language, which is nothing but the Gherkin, is a preferred language for defining tests in Cucumber. It can be used with various programming languages like Java, C, or sometimes it can be used with the other programming languages which are very known to the developers. So this language, that is Gherkin, is used because it is very beneficial, because the entire team involved in the process can understand what exactly the requirement is. The next one is the data-driven testing. Cucumber facilitates data-driven testing by allowing different sets of data to be used in test scenarios, making it easier to validate software behavior under various conditions. So as I said, different inputs can be used in order to check whether the software is actually working right or not. The next one is tagging and hooks. So Cucumber offers this tagging and hooks mechanism that actually allows specific scenarios or groups to be executed selectively. This feature is useful for running subsets of tests based on criteria such as priority or category. So as you saw, it is nothing but it is to do something with different groups or specific groups, right? So this feature is also very helpful when it comes to Cucumber. Next is extensibility. As the name suggests, extensibility is nothing but you are adding some feature to the existing one. So Cucumber can be extended with custom formatters and plugins to enhance test reporting and integration with third-party tools. So whatever you want to integrate, or if you want to document your report in a better way, you can enhance it. So all those enhancements and integrations and all can be considered as extended feature, right? So that is also supported in Cucumber. So we already understood that Gherkin is a language, right? So it is a domain-specific language that is designed for specifying and documenting the behavior of the software systems. And it is a plain text or a human-readable language that is actually used in simple syntax to describe the expected behavior of the software in a structured format. Gherkin is particularly popular in the context of BDD, that is nothing but behavior-driven development, and test automation. The primary purpose of Gherkin is to bridge the communication gap between the technical and non-technical stakeholders in the software development process, including the developers, the testers, the business analysts, and product owners as well. So to have the communication built between these people, Gherkin is playing a major role. So the Gherkin documents are also often referred as feature files. That is why we also have to give .feature as file extension when we are actually creating this Gherkin file. So this we will understand when we get into our hands-on or the practical implementation. A Gherkin feature file includes the following key elements. We will see what those are. The very first thing is feature. We already saw this example, but here we will understand what is feature, what is scenario, and what is inside scenario as well. So feature is nothing but it describes a high-level functionality or capability of the software. So it will just inform the readers that what exactly the functionality is. So that is nothing but the feature. Next is scenario. Scenarios are individual test cases or examples of how the software should behave under certain conditions. So there are few things inside scenario as well. It is nothing but it includes 3 scenarios or 3 sections in it. So the very first one is given. Given always describes the initial context or the preconditions of the process. When describes the action or the event that triggers that behavior to be tested. Next one is then. Then always describes the expected output or the result. So this is a simple structure of what Gherkin actually is, or Gherkin feature actually includes. So we will see a simple structure. This we already saw in our previous slides. So feature is nothing but the user login. So login is a functionality here. So as a user, I want to log in into my account so that I can access my profile. May it be any profile for that matter. Let it be Facebook, let it be Instagram, let it be LinkedIn, any profile that you want to access. The very first thing that a user should do is he should log in into the account. Only then he can access the profile. How to write the Gherkin language for this? So there are 2 scenarios now, right? So one may be a valid input that user gives. Second one may be the invalid credentials that the user gives. So the very first scenario is when he gives the valid credentials, right? So when he gives the valid credentials, so in given, you have to always write the user is on the login page. When the user actually enters the valid username and password, then they should be logged in successfully. So this is for the valid scenario. Now we'll see what comes in our invalid scenario. So the scenario is user can give the invalid credentials also. So given the user is on the login page, when the user enters the invalid username and password, then they should see an error message telling that your username is wrong or your password is invalid. So that error message has to be displayed. This is the scenario when the invalid credentials are given. So this is how you write the entire structure. So it should have the feature in it, then it should have the scenario, what scenario is, and then you have to give all three key pointers, that is nothing but the given, when, and then. So only then it is a complete structure when it comes to Gherkin. So next we'll understand what these step definitions are, right? So in this example, we saw that the Gherkin steps, that is nothing but the given, when, then, in the feature file are matched to the corresponding methods in the Java class, that is login steps. So we will be writing a Java code, and in that we will be writing the methods for all these three things, that is given, when, then. So we will simply understand this for now with a screenshot. Later we will actually implement it using our Java code. We'll understand it better then. So the next one is when the Gherkin scenario is executed, the cucumber is actually invoking the appropriate step definitions to perform the actions described in the scenario. The step definitions are where the actual test automation logic is implemented. So the step definition is what you can call it as the logic that is written. So they interact with the application and make the assertions and validate the expected behavior of the software that is under test. The main use of step definitions is that it allows the test scenarios to be written in the human readable language, that is nothing but the Gherkin. So the step definition will always give the freedom to write the feature or the scenarios in the Gherkin language. So this is how a step definition can be written. So you can see the methods that has been written here. So for when, given, and then. So there is some methodologies that are written in the Java at the backend. So all these will help the actual invocation of corresponding methods in the Java class. When these scenario steps are written in the scenario, that is given, when, and then, they are actually written as methods in our Java class. So we will understand how these step definitions are written, how to incorporate these step definition, or how the feature file are matched to this corresponding methods. All this we will understand in our practical execution of the concept. So now, having our snippets ready, that is nothing but the Gherkin structure, we now have to add our step definitions. So how do we do that? So now we have a folder called source test Java. So there I will go and right click and I will open a new folder. Go to new and open a new folder. And I will name that folder as step definitions. And then give finish. So what happened? I got a new folder under my test Java, right? So now under my step definition, I have to open a new class. So right click, new, and there is a class icon here. So click on that and name your class. We have to name our class. So I will give it as login steps. Okay, I'll give it as login steps and I will finish it. So I got my login step here. So under this, under my public class login steps, whatever is there in my console from given snippet to then snippet, I will just copy it and I will paste it here like this. Okay. So now what I can do is I will remove these two sentences under my each function and I will add a system dot out.println. Okay, under this I will add a sentence that is nothing but it is an inside step, and the step is nothing but user is on login page. So that is my first function, right? So that is why, and I will end it with a semicolon, right? Like this. So inside my user is on login page, I am writing this sentence. Similarly, let me change for all the other 4. Okay. So what I can do, I will copy the same statement, that is system.out.println, and I will paste for when, and I will paste for one more function, that is when, and for my one more function. And now let me make the corresponding changes. So now user is doing what? User is actually entering his username and password. So user enters username and password. Okay. Here also we'll change the sentence. So user is what? Doing. So user is doing what? He clicks on the login button, right? And then what is happening here now? Here the user is navigated to the home page. So that I will type navigated to home page. Okay. So having this ready, what next we have to do? So you can see a red line that is given for all our structure, that is given, when, and then, right? How to remove that? So just place your cursor on that word and it will ask you to import the package there. So just click on given io-cucumber.java. It will get imported. And what happens? An import package will come here. So that is nothing but io-cucumber.java.en.given. So next, same with when. So import when. So when got imported. So next is then package. So import then. So this is ready now. So having this ready, let me save this first. I need to save this. Now I will go back to my console and check what output I will get. So to do that, I'll go to my test feature, and on the same snippet, I will right click and I will run as cucumber.feature. So now what happened? We passed, which means 1 scenarios, 1 passed, 4 steps, 4 passed, which means something is working fine now. So apart from whatever was missing, the step definitions were missing. But now we have our step definitions. This is the proof that we have our step definitions. Next, after adding our step definitions, our last step is to have the runner class. So we will see how to do that. So now we have to create a runner file now. So same thing, what we can do is we have to go to our step definition folder. From there, I have to go to new, and then I have to go to class, and I will name my class as runner. So runner class is my class name, and then I will give finish. So when I do that, a runner class comes into picture, right? So what do we do next? I will copy my code from my file, which I've already kept it ready. I will copy this and I will paste it here before my runner class. Okay, and then this should be in a single line. So now I will remove all this because I need to give a proper quotes. Only then it will work properly. So I'll remove this, step definitions. I'll remove this and add, and we have this, right? So now we can see that we still get a red line under run with cucumber class, cucumber options and all. Now if I go and keep my cursor on it, it is telling me that run without cannot be resolved on a type. Why? Because we don't have this packages in our, or we don't have this plugins in our dependencies, right? So we have to now import those dependencies. So one, we have to import JUnit dependencies, and we also have to import Cucumber JUnit dependencies. We will see how to do that. So we have to go to our Cucumber pom.xml and we have to paste our dependencies here. So we will see how to add those dependencies. Okay, so now again go back to Google and we will go to our repository and we will type JUnit and then search. When you do that, you will get this result. So you can click on JUnit, this one, the second one. And when you go there, you will get the versions again. So you will get the versions, right? So you can click on the first version and I will copy my dependency from here. I will Control C. I'll go back to my project and I will paste my dependency here, right? Make sure you are adding your dependency under your dependencies tag only. So this is the dependencies first tag that I have opened, inside which I had already added the Cucumber Java dependency, and now I added JUnit dependency, right? I also have to add one more dependency. Having this Cucumber Java dependency and JUnit dependency, now let me import one more dependency, that is Cucumber JUnit. Go to Google again and in the repository type Cucumber JUnit. When you do that, again, the Cucumber JUnit has two options, right? So it has IO also, it has info also. So let me always select IO when it comes to Cucumber. So when I do that, the very first version also you can take, but I am comfortable taking the 5.7 version. So let me do that. I am going to this version and I am copying my snippet from there and I am adding this dependency in my project. So under this JUnit dependency, I am adding my Cucumber JUnit dependency also. Did you understand? So we added all the dependencies that is required, that is Cucumber Java, Cucumber JUnit and JUnit. So now I will save this successfully. And when I saved this successfully, in my Maven dependencies, you should be able to see the JUnit plugins or jars and also the Cucumber Java or JUnit. So here we have Cucumber JUnit jar and we also have JUnit jar here. So it is successfully imported. The dependency is with us now. So I'll go back to my runner class and I will place my cursor on the runner. So now I am able to import. So import run with, I'll click on that. And I will also place on my Cucumber. So it gives me an option of importing. I will import Cucumber. But my last, that is Cucumber class, to resolve this error, I have already written a import package here. So I will just copy and I will paste. It is nothing but import iocucumber.junit.cucumber. So having my runner class ready without any errors, I will check whether it has any errors or not. So right click on it and run as JUnit test. When I do that, if there is any errors, I will get errors or I will get a green line here telling that there are 0 errors and 0 failures. And it will give me that 1 passed and 4 passed. So you can make sure that whatever you have entered in your code reflects here. You can also customize this particular output by giving few features here, and that I will leave it to you to explore more about it. So here, this is how I can use different packages and different jars and create my different files, and the execution can be done like this to check whether it is running properly or not. This is a testing method using Cucumber Eclipse plugins in our project. After understanding what Gherkin language is and what the step definitions are, now we will understand how to practically implement those in our software testing. For that, you should have Eclipse installed on your system. So without any further ado, I'll teach you how to do that. So search Eclipse software and you can install it. And then I am launching my software. And my software is now ready. So we will understand how to do it step by step. How to actually create a project, how to create folders, how to create files, and also how to import Cucumber or Java or JUnit into it. And how to do the testing. We'll take up the same example that we saw, that is how to log in into a page. You should give the user and the password credentials, and then there are two possibilities. One is it will successfully log in or it will give you the error. So this process we will implement. So for that, we have to first create the project name. So for that, you have to go to File and from there New. From New, you will click on Others. And there you have something called as Maven project. So click on that and you can check in the box that is create a sample project. You have to click on that and go to next. Then you will be asked to give the name or it will ask you to give the group ID. So for that I will give it as Java Cucumber. Same name I will give it in the second ID as well. Now I will finish. So once this is done, you can see that the name that you gave came here, right? So now this is how you create your project file. There is one more option where you can view menu. There you can select your working set. This is an optional point that you can work on. So you can just go to new and you can select your Java and you can select your Java Cucumber and you can type the same name here and give finish. So irrespective of the previous projects that are present in the list, you can get into your project that is Java Cucumber. Here I have just one project. That is why it is easy for me to select my working environment. But if there are n number of projects which you have created priorly, if you want to get into your project, keeping the other projects aside, you can follow this procedure that I taught you just now. Next, after creating a new Maven project, now we have to add the dependencies, that is the Maven dependencies. So we will see how to do that. So there is an arrow mark which you can just click on this, that is the drop down, and you will get all these folders that are present inside that particular folder. So you should also get pom.xml in your project that you have created. So having these things, it is very sure that you have correctly created your project file. Next, so for the second step, that is to get your Maven dependencies, you can go to your Google. So now in Google search box, you can type as Maven Central Repository. When you select that, you will get a web page. So you can select the very first repository and keep it ready. Here now, so once you get this page, you can type as Cucumber Java and you can search. When you do that, it will take you to the page where you will have the different versions of it. So now we have two things related to Cucumber, that is Cucumber JVM and Cucumber JVM Java, two different releases, but then or repository. But then we have to always select IO. IO is the main repository which will have all the versions in it. So I will select the Cucumber version in it. Now there are n number of versions that has been already developed and it has been added in the repository. But for ease, I am using the 5.7. You can use the latest version as well. So now I'll select this particular dependency that is related to Cucumber Java. I will copy it. I'll go back to my project and I will open my pom.xml. Double click on it. When I open my pom.xml, you will already have some version in it. You will have some snippet in it. So here what I will do is, after my version, I will add a tag called dependencies. It will directly come. So you can add that particular tag. So you saw the tag coming up. So inside my tag, I'll add the version that I copied from the repository, or I'll add the dependency that I copied from my repository. Now having this, what I can do is, after pasting the dependency, I will save my file. So you have a save icon here. You can save the file. Once you save, you can make out the difference that you have got something called as Maven dependencies in our project. So just click on the drop down and you can see all the jar files and all the plugins that have been added into our project now. See, you can see the tag expression jar, you can see the data table jar, you can see Cucumber Java jar, and there are few plugins also, that is Cucumber plugin also. And these are all the jars and the plugins that we actually need when we are executing our snippets. So having these Maven dependencies, next we will see what to do. So next, having this source test resources link here. So you have to right click on it and you have to click on new, and from there we can go to the new folder. So when you go to the new folder, a pop-up window pops up. So here I have to name the folder. I will name it as features. Features, right? Having this, I will finish it. So what can we observe here? Under this source / test / resources, we have a folder called as features. Now, under this feature, I will create a new file. I will name the file as login.feature. Okay, and I'll give finish. So now you saw that a file is created and now a pop-up window pops up, right? So it asks editor available on the marketplace. So I will tell it as okay. Now what I can do is, which means there is no Cucumber Eclipse plugin in our software. So what we have to do is, we have to install that plugin. It will directly pop up and I can tell to install. When I give install, it will start getting installed like this. So we have to wait. Then you have to tell I accept the terms and then finish. And then a trust window pops up wherein I have to check in the always trust all the content, and yes, I accept the risk, and then click on trust selected. Once I do that, all my plugin is ready at the backend and it will ask us to restart the software. So you have to give restart on. So now once it's get restarted, our entire software will get restarted. We have to wait for it. Once the software gets restarted, we can observe a small difference. So in our features folder, we created a file by name login.feature, right? You can see a Cucumber icon next to that particular file. It has come along with the Cucumber icon. So there is one more method to download the Eclipse Marketplace. It is nothing but, say suppose a window is not popping for you to install the plugins, or if the software doesn't restart automatically, then you can use this method. Or in case the Cucumber plugin is already present, then you will not get the pop-up, right? So we can recheck on it like this. Go to help and you can go to Eclipse Marketplace. You can click on that. It will take you to that particular pop-up window. There you can check whether whether you have installed Cucumber plugin or not. Okay, here you will find. You can go to popular and you can check. whether your Cucumber is installed or not. So Cucumber Eclipse plugin is already installed, right? So this is one more method to check whether it is installed or not. If this is not installed, you can click on the install here by coming into this window. That is nothing but help, Eclipse Marketplace, and then you can go to popular tab. There you will get to know whether it is installed or not. So now, having all our Cucumber Eclipse plugins ready, now our next step is to create the feature file and to add the content into it. We will see how to do that. So we have to go and click on our login feature now. We are already in that login feature page. We all know the structure of our Gherkin format, right? So I will type that here now. So the very first thing is nothing but the feature and then the scenario, and then comes your given, when, and then. So this structure, I am typing it here now. So the very first thing is feature. In feature, I will type as feature to test the login functionality. Okay, this is my feature. Next is my scenario. So what is my scenario now? I have to check whether the login is successful with the credentials, right? Inside my feature folder, let me try creating one more file, new. I'll go to new and I'll create one more file and I will name it as test.feature and I will finish. So when I do that, you observe that this is a default code that is coming in our file. So instead of having default, what I can do is I'll control all and I will delete. Then now I will type the Gherkin snippet code that we saw in our previous slides, right? We saw how to give feature, how to write the scenario, and inside our scenario, we have to write the given, when, and then, right? So we understood how to write the structure. So now I will just type my structure here. So having my feature, and feature will have feature to test the login functionality. So this is my feature now. Inside my feature, what did I have? I had my scenario. So scenario is nothing but I have to check the login credentials, right? So it is nothing but check login is successful with valid credentials. Okay, so my main job is to check whether the credentials is valid or not. So now I have to write given inside the scenario. So given user is on login page. So this is my given scenario. Now I will write when user enters username and password. After giving the password and username, credentials and all of that, what will the user do? He will click on the button, right? So that also I will add before writing the then. So to add that sentence, I can use and. So and clicks on the login button. Okay. And then what will happen? User will be logged in successfully or he will get an error. That will be the criteria, right? So user is navigated to home page. So now this is my structure that I have written. Okay, we have to open a feature file and we will be writing all this structure inside it. And now I want indentation. I will select Control all, and I will do the indentation, that is I. Okay. After writing the structure, I need to save and I have to run my feature now. So you will right click on the code and you can make the format proper by clicking on pretty format. It will do the formatting by itself. And now let me run it. So again, right click, and there is one more option called run as here. So run as Cucumber feature. Click on that. Once you give that, it will ask you to give a confirmation. So give OK, and it will give your result here now. So if you can check here, we have successfully written our scenario and we know what the scenario is and we have explained it. But it is telling that scenarios are undefined. If you can notice, let me increase the size of the tab. So here you can notice that the scenarios are undefined. This is what I told you, right? You giving the scenario is okay, but you don't know what is the scenario all about and what each scenario should actually do, right? So that is where our step definitions come into picture, right? So we have the snippets ready below. The console is already giving us the snippets. So it is telling when you're using given, what should happen, when you're giving when, what should happen, and when you're giving and when you're giving then, what should happen. This when has come twice because this is also related to when statement, right? So I just told and after giving user password and the username, password, credentials and all of that, you will click on the button, login button, right? So that is why I used and. But then it is considered as when only. That is why we have not got and here, okay? And then is nothing but the user is navigated to the home page. Now having this ready, we will see what to do next. So next we will have a brief recap of what all we actually understood in this particular course. So the very first thing is that we understood what testing is. Testing is a critical phase in any software development as it involves evaluating a software application to identify any issues, to detect or fix the issues in ensuring that its functionality is better and the performance is efficient. Next, we also understood what exactly the software testing is. Software testing is the systematic process of accessing software to identify the correct issues. It will make sure that the issues are resolved before actually implementing at the final state of the project. So the next one is we also understood what automation testing is. Automation testing is a software testing technique in which the test cases and scenarios are used and they are executed using automated testing tools and the scripts rather than manual testing. Next, we understood what Cucumber testing is. So Cucumber testing is a specific framework that is used for BDD, that is nothing but behavior-driven development for testing, and this helps to bridge the communication between the technical and non-technical members. Next, we understood the benefits of Cucumber testing, where we explored how the documents are maintained, how the collaboration is done, how the code is reusable, and also how to automate, and many more things. And then we understood something called as Gherkin language, right? So Gherkin is a human readable language that is used to write the Cucumber scenarios. Also, along with Gherkin, we understood what step definitions are and how to map the Gherkin steps to actually perform the actions in the software. Having understood everything about Gherkin and step definitions, we also implemented it in the Eclipse software, and we also understood how to import packages and how to import the plugins in the software. Congratulations on completing the tutorial. You have now gained a comprehensive understanding of various testing methodologies from manual and automation testing to unit, integration, and API testing. Plus, you have explored the power of Cucumber and behavior-driven development. To further enhance your skills, explore our platform for more advanced testing courses and resources. Keep learning and happy testing!